GM, AlgoFam, hello and welcome to Decipher 2022. This is our second annual conference here. Welcome to the Developer Greenhouse. I am thrilled that you guys are here today. Thank you very much. I hope you were inspired by the talks this morning on the main stage, right? We heard from Sylvia. What an inspiration there. From Paul, from John, from Stacy, and a great MC, Matt, my colleague over there as well. All right, in the Developer Greenhouse today, our first of 2 days here, we have this agenda. Here it comes, right? All right. So we've got a couple of sessions here this morning. We've got a pitch competition over the lunch period, and then afterwards we've got some more speakers. I'll go through and tell you about those, and we are going to repeat it again tomorrow. Everything that we are doing here in this room is live streaming, so I want to welcome everybody around in the Algo fam, all the Algo devs that are out there. Hello, and we are glad that you are here and joining us. To everybody in the room, thank you very much for being here. All right, so this morning we've got a couple of sessions going on. We're going to hear from some of my colleagues here about the AVM, about what's been going on there, and then we're going to hear a little bit about the performance improvements that have been happening within the protocol. Then we'll have the pitch competition, and then afterwards we're going to hear some very exciting talks about the enduring value, about post-quantum computing from Chris Pikert. Let's see here, the spectacular distributed systems, right? This is going to be an exciting talk as well. And then we've got a panel onboarding the next 10 million users, and we're going to, then we've got Coinbase going to come up, and we're going to wrap it up today with a demo from 2i2i. So right now, I want to make sure that you guys help me in welcoming my colleagues here, John Gennady and Ann Kenyon here. All right, John, there we are. They're going to be talking to us a little bit about the design improvements that they have been making to the Algorand protocol over this past year. So Ann Kenyon, Senior Technical Product Manager, and John Gennady, Head of Applied Research. It's wonderful to welcome you guys to the Algorand Greenhouse.
Thanks, Ryan. So I'm JJ. No, you're JJ. I'm Ann. I work in product. JJ works in engineering.
Yeah.
And yeah, we're going to talk about the AVM today. So you heard from Paul's talk this morning. This is part of our programmability pillar, the second core pillar of our three. And when JJ and I met, we were both at Brown. JJ was a professor, and I was a student. And I never took JJ's class because I heard there was a lot of homework. And
there was.
I had other things to do, I guess. So today, we thought we'd do things a little differently and give JJ a chance to show me his lecturing skills. So I'll be the student today, and JJ will be the teacher.
All right, so the goal here is to actually walk you through some of the things that we've been doing with the AVM of late, and to do so in a way that you understand why we made the changes, not just throw changes up on the screen. So, in our last class, which was a year ago, in Miami, we told you how teal evolved into the AVM. So teal was a assembly level language, just for evaluating extremely small, non-Turing complete predicates, handwritten. Now the AVM is a Turing complete target. A language could target the AVM. A Turing complete language could target the AVM. And we're seeing more and more people aren't writing teal assembly language code. They're instead writing high teal or reach or teal.rb or tealish. And they're targeting those languages are targeting teal. And so more and more we're designing so that it's a great target for compilation as opposed to a great language to write your handwritten contracts in. So when we made those changes, can anybody tell us some of the concepts that we introduced in order to improve teal and turn it into the AVM? Ann?
Contract calls.
That was a big one. So that allowed us to compose contracts and build an ecosystem of one contract needing to use another contract as essentially a subroutine. Anything else?
Inner transactions?
Inner transactions, important as a precursor to contract calls. So the first thing we did was we gave you inner pays so that contracts could actually perform things like payments, could hold on to assets. Before that, it was pretty complicated. You had contracts on the one hand that could manipulate state, and you had logic sigs on the other hand that could manipulate assets. But it was quite difficult to combine them together. So one of the big changes was to introduce accounts that were connected to apps so that apps could perform more interesting things. So, today we're going to talk about that. Almost all of that work had to do with improving the AVM's computational performance, allow you to do things that we didn't previously allow you to do, like something as simple as jump backwards in your program so that you could implement loops and subroutines. This year, we spent most of our time working on improving the AVM so that you can manage state better. And so today, you need to know what the AVM is so that we can tell you how we've improved the AVM to manage state. So the AVM, despite its name, is not something like VMware. It's not running an x86 virtual machine. It's a VM in the sense of the JVM. It's a language interpreter. It's a simple stack-based language interpreter. You have scratch slots, which are just places you can store temporary variables. You have a stack. Almost every opcode in the AVM manipulates the stack. The plus opcode takes two things off the stack and puts the sum onto the stack. We no longer limit you by forcing your program to run forward the entire program, therefore outlawing loops. We now limit you by the cost of individual ops. So your program can't run forever. We obviously cannot allow you to run forever if we intend to do 6,000 transactions per second. So we let you run instructions, and each instruction has an associated cost. Opcodes, most simple opcodes like plus, have a cost of 1. It's not complicated to keep track of how much time you're spending. More interesting opcodes, things like built-in crypto and built-in hash functions, those things do have to have a higher cost, and those things are implemented in native code, not in the AVM itself, not in AVM bytecode. Those sorts of things you might find in an existing language interpreter. So the JVM has opcodes like these. But blockchains need specific opcodes to do more interesting things. In particular, inner transactions are the way you actually get the blockchain to really do something. And so inner transactions require that we introduce new opcodes that just talk to the blockchain, so to speak. And similarly, something like the JVM would never have an opcode that talks about persistent state. When your Java program runs, if you change a variable and then your program ends, that variable's gone, unless you're talking to databases and so on. But a blockchain is all about persistent state. And so there are opcodes that manipulate persistent state, and those are particular to this sort of VM. And so we're going to spend time talking about that today. All right. So we're going to talk about two kinds of state management that have been improved in the last year. There's going to be runtime state management, and in particular, we're going to talk about managing state when you call functions, call subroutines, and persistent state. We're going to talk about how you onto the blockchain, have them live there permanently until your app invokes again and needs that data again. So that's going to consist of two new features. One is frame pointers. So frame pointers are help programs manage runtime state, manage calling subroutines with arguments that return values and local variables and so on. And this is actually a pretty normal thing for a VM to have. The JVM has opcodes that help in passing arguments to functions. And on the other hand, we're going to introduce something that's special to blockchains, an interpreter like the JVM wouldn't have, and that's going to be boxes. Boxes are where we're going to place persistent state. You can create a box, you can put things in it. The next time your app is invoked, if you look up that box again, you'll find the same information inside of it.
Hey, Teach.
Yeah.
Are both of these going to be on the exam?
They are.
Okay, thanks.
All right, let's talk about frame pointers. So in V4, which is one of the first VM versions that I worked on, we introduced call sub and ret sub. These are so simple. These are just a way to jump to a piece of code, and when that code is done, jump back to where you started. It turns out the call sub function is literally 2 lines of Go code. This is really simple. So this was minimal support for subroutines. Suddenly, we had a Turing-complete language because you could call into code and come back. But it was very simple. And do you remember any of the problems that we ran into when we actually tried to use call sub and ret sub?
Well, I guess it's pretty complicated if you're calling a subroutine and you got to pass several arguments, and then your subroutine wants to use those arguments maybe multiple times, but at the same time it's using a local variable or multiple, and then it needs to put the return value somewhere and clean everything up and make sure nothing gets lost in the stack management. So I guess it seems pretty complicated.
Yeah, that's right. So we were proud of how minimal the support was. Just two tiny changes to the AVM, and so we were pretty sure there were no bugs. That's great. But on the other hand, it's a little bit complicated to do real-world things with an AVM subroutine with only this level of support. The calling convention, what in a normal programming language would be passing arguments, manipulating those arguments, using local variables, returning things from the subroutine, all of that had to be decided upon by the programmer. So the programmer had to say to themselves, how am I going to send my arguments to the subroutine? Because the subroutine call itself is just a jump. So should I put the arguments onto the stack? Should I put them into some scratch slots and my calling code will know where they're to be found and so on? Most people decided to put them on the stack, and then they expected their calling code to remove them from the stack and leave the return values. But there's nothing enforced at the AVM level and no support for it. So the nice thing, I guess, is that simple things are really simple. So here's an example. I think I'll walk you through this code. On the next slide, I won't. It's too much code. But here you can see how you would write something to compute the hypotenuse of a right triangle. So it's the Pythagorean theorem. So if you pass in 4 and 3 by putting them on the stack, that's the second, third line. And then you call the theorem subroutine. Jump down to it. Duplicate one thing from the stack and multiplies it. Squares it. Then it swaps. Get it out of the way. And use the other argument. Squares it. Adds them together. Takes the square root. And then it calls ret sub. And so it has the arguments off of the stack, and it has left the return value on the stack. And we're back home on Mars. Sure enough, it's going to be equal to 5. This looks great. It looks like we support subroutines. True, but as Ann mentioned, realistic examples of real subroutines, variables, accessing the same argument multiple times, different points in your computation are a lot more complicated. And so, if you need to do all those things and then clean up stack when you're done, you have to do it all by hand, and that's not so great. So that's what frame pointers are intended to support. Let's see. So I should say, because this was so hard, I shouldn't say many, there aren't that many high-level languages compiling to Teal, but both PyTeal, the work that we did on our own, and some developers that I've spoken to who have compiled high-level languages using these subroutine calls, both fell into what I would call an ugly pattern. Every single time that a function was called, they immediately took the arguments off the stack, shoved them into scratch space, and then retrieved them and manipulated them from there. Yeah.
Wait, so why is this an ugly pattern? I mean, it seems very convenient to use the scratch slots for that.
Yes, I suppose it is, right? So scratch slots, I told you, were for temporary variables, right? So it seems reasonable that if you're going to access these arguments multiple times, put them somewhere where you can access them multiple times. The trouble is, the reason I call it an ugly pattern is because now you have to decide at the global level of the program which subroutines are going to have full control over, let's say, scratch spot 7. Because if function f is going to put things into scratch slot 7, and it calls function g that also immediately puts things into scratch slot 7, you've just lost track of your variables. So this having a static place to put your arguments means that you can't do recursion. You have to be very careful about subroutines calling other subroutines, and so they become not very composable. So we saw in actual practice, when PyTeal was using this pattern, that some of our users were very quickly running out of scratch space. Maybe they have 20 or 30 functions. Each of those 20 or 30 functions has a few arguments, no more scratch space, because they all have to be allocated different scratch slots. So we wanted to get rid of that pattern. We wanted to make that pattern unnecessary. So you're not intended to follow all of this code. I'll be happy to show it to you later if you want. The intent here is to show a slightly more realistic. You want to compute the roots of the quadratic equation. You take A, B, and C. You compute and you want to calculate the quadratic formula. So none of this is particularly hard. But I want you to just imagine that you're trying to write the stack-based code to read various variables and compute expressions. But you're going to need to access multiple times. You're going to access multiple times. You're also going to calculate the square root of the discriminant in the upper right. And you're going to use that intermediate computation multiple times. So you need a place to put local variables. So what I'm showing is code that does that without using the new frame point. And all you really need to know is that when because we keep track of the height of the stack at the time the subroutine was called, you can now access the stack using frame opcodes offset from that height. So every time you want to access variable A, regardless of whether or not you added the stack in the meantime, you can always say frame dig negative 3 back from where you called A, B, C on the stack. If you want to get it A, always say frame dig negative 3. If you want to store something, you want to change it, it's a little like your arguments. You could say frame bury negative 3. And you don't have to worry about whether your stack has grown in the meantime. And if you want to put things onto the stack, you can. And here you'll use a positive index off of frame dig or frame bury. So for example, after we calculate the discriminant, we say frame bury 2. Because we're going to be able to get it back out by saying frame dig 2 whenever we need it to either subtract it or add it to negative b. And finally, when you want to return things, you put them into frame bury 0 or frame bury 1. We're returning two things, so we're putting them at 0 and 1. And these are offsets from the frame pointer, not from the top of the stack, so they stay the same for the entire length of the routine. And then retsub knows how to clean everything up when you're done. Because the first instruction here is this new instruction called proto. Proto says this subroutine is expecting 3 things, and it's going to return 2 things. So when you're done, get rid of those 3 things, slide the 2 things down, and get rid of anything that you put on top later for local variables. And so it suddenly becomes very easy to implement subroutines that need local variables, that only using the stack for space. If this had been a recursive routine, it would have been fine. It would have worked just fine. The things just would have been deferred. And this is not that surprising. This is the way C compilers work, Pascal compilers work, even Fortran once they had recursive. Yeah.
Okay, so can I just make sure I understand what you just explained? So it seems like the key thing is I need to use proto to say how many arguments and return values I'm going to have. And then everything is easy from there. If I want to access the arguments, I use frame dig. If I want to put the return values in, I use frame bury. And if I'm doing stuff on top on the stack, it'll get cleaned up automatically with retsub at the end. That's right?
That's right. You could push as much as you want onto the stack because you need some local storage space, and it'll all get taken care of at the end. Great. So none of that is super surprising, and none of that is really blockchain specific. But it's an example of what we're trying to do to make the AVM more useful as a compilation target for the sort of world of high-level languages that are slowly coming into existence and compiling, so they don't have to do the amount of work. It is possible, by the way, to do all of that without frame pointers, but it's hard enough that people weren't doing it, and so we improved the AVM to make it possible. Now I want to talk to you about something that's blockchain specific, and that's boxes, so this is going to be about persistent state. All right, so in order to do that, I need to remind you a little bit of how Algorand's on-chain state works. So the Algorand is an account-based blockchain. That means it's much better to think of, in some sense it's logically equivalent, but it's better to think of Algorand's state as being the local ledger, the balance table as of the current point. What that consists of are accounts, assets, and apps. Accounts hold things like your algo balance and your voting keys. Assets are things like USDC, and there is an extra object that is how much a particular account has of USDC. And then there are apps, which are things like code and some storage space that we'll talk about in a minute. Let's see. But to understand boxes, so it sounds like I just told you that apps have state, and they do. They already have global state and something I'll explain called local state, but they aren't good enough. And so I'm going to need to tell you what local state and global state and local state are so that we can then tell you why boxes improve upon the situation. Let's see. So one question, the first question you need to keep in mind is that all of the work we do is constrained by various limitations. Usually it's a performance limitation, sometimes it's a space limitation. So if I just tell you that Algorand programs are allowed to allocate these objects whenever they want, the obvious question you might ask is, well, Algorand, how do you prevent participation nodes from needing to hold on to an arbitrary amount of storage and do a lot of work? Any ideas?
You can make people pay for it when they use state.
That's the usual blockchain argument, right? You make some economic trade-off. You say, if you pay for something to happen, it can happen. And that's what we do for transactions. We charge fees. But storage is permanent, or until you delete it. So we don't really want to pay a fee and be done with it and possibly have to hold on to that storage for the next century. So we instead, in some sense, I like to use the expression rent. We force you to rent the storage by locking up some of your algos, and you can't get back your algos until you free that storage. So we call this thing the minimum balance requirement, and I'll often say MBR because minimum balance requirement gets a little long after a while. Every kind of allocation that you can do in Algorand that sticks around, that's persistent, requires that you pay, loosely I'll use the word pay for it by locking up some of your algos. If you create a new account, that account has to have at least 0.1 algos in it. You can't pay 0.01 algos to a brand new account because it's not allowed to exist. It's not allowed to waste the space to hold the balance unless it has at least 0.1 algos in it. Similarly, if you want to make a new ASA, you have to make sure that whoever the creator is has to have an extra 0.1 algo in their account. Same thing for apps, same thing for balances even. This is why you need to opt into USDC as an individual account. Because if we're going to permanently keep track of your balance, then you have to have set aside 0.1 algos that you won't touch to sort of pay for the fact that we need to store that on the ledger state. And apps are a little bit more complicated because their space requirements are not as standardized as ASAs. One app may need more space than another. If you're an app that requires more space, you have to set aside more minimum balance. So here's the state of the world until boxes come out tomorrow, essentially. On BetaNet, boxes are out, but they'll be released in the next few days to mainnet. So an app can have global state, and that means that at creation time, when you create an app, you say, oh, and by the way, this app also needs to have 4 pieces, or 5 pieces, 10 pieces, up to 64 pieces of state that I can manipulate in the program. I can set maybe I have a variable called sum, and every time this app gets interacted with, it adds or decrements that sum. It's limited to 64 pairs, not a whole lot, and those pairs are pretty small, 128 bytes total, to split up amongst the key and the value. It's useful to know that they're stored all in one place, so if you invoke an app, all of that app's global state is read into memory so that the app can be evaluated rapidly. And it's the creator the creator of the app who's responsible for locking up MBR. That wouldn't be enough stuff for a lot of interesting apps. A lot of interesting apps need extra state depending on how many accounts are interacting with that app. If it's got 1 million users, it needs space for 1 million times X extra things. Maybe it's got some sort of abstract balance for those things. So that's local state. Local state is when the app says, if a user wants to interact with me and they opt into me, how much extra space should be set aside? And that extra space is set aside by the account that does the opt-in. The account that does the opt-in has to have increment to their minimum balance. And it seems like we're almost there. We almost have an arbitrary mechanism for apps to have whatever amount of extra state they need. If 10 more users come along, they get 10 more units of this local state. But do you think it's good enough?
Well, no. No, because I mean, okay, what if I need more state that's not at the user level?
Right, so there's two problems here. What if you need more state, just more? 64 global variables just isn't enough for your app. And the other is, what if when you need more dynamic state, it's not because more users have interacted with your application, it is, for example, I don't know, they've submitted extra orders or put more things up for auction or something like that. There's something else that's causing the app to require more dynamic state. Let's see. I think I forgot to tell you how programs interact with this state. Today, there's individual opcodes for accessing those global and local state variables. I don't think there's much more I need to say about that. Sorry about that. Oh, yes, there is. Yeah.
You revealed the answer, but
if it's the case that there are opcodes that allow me to look up, let's say, the USDC balance of an arbitrary account, why would that be bad for an app? Why would that be dangerous in Algorand? Algorand, by the way, we just promised you 6,000 transactions per second, and now we're letting you execute apps that can access arbitrary amounts of local state. That sounds dangerous.
Yeah, well, I took a peek when you revealed that answer. So I think the answer is that, with this system, you are giving a lot of power to the app to access lots of state during its execution, which makes it difficult to evaluate the whole thing in the times that we need to be able to have 10,000 transactions per second. Yeah.
Right. So one mechanism that we use normally to keep your app from running too long is just the opcode budget that I told you about before. But that's not good enough here, because here you're accessing persistent state, which is generally an order of magnitude or so slower than regular memory. And so we need an even stronger bound on what you're allowed to access. We have a mechanism that you might call static access bounds. So
wait, Professor, don't we already have some bounds, though? Because there's your opcode budgets. You can only do so much in one app anyway, right?
That's true. You can only do 700 things per app because you have an opcode budget of 700. So you can only access 700 objects, but that's a lot of objects, especially if those objects are I/O. You actually have to perform I/O as opposed to read from memory. So opcode budget isn't a strong enough bound for us for when it comes to accessing persistent state. And so the stronger bound that we use are called these foreign arrays. So transactions arrive at the Algorand network saying what application they're going to call. It's just an application ID and their arguments. But they also have three more surprising fields. If I showed you what an application call transaction looks like and you hadn't used Algorand before, you would wonder why there's these three extra fields. An array of accounts, an array of assets, an array of apps. And what those are, they're hints to the evaluation engine that tell the evaluation engine, when you execute, before you execute, you should read in these objects so that, because during execution, I'm only going to access those objects. And so if you've read them in ahead of time, if you've prefetched them, you'll be able to run sort of straight line fast at memory speeds rather than have to access external disk. And in fact, Algorand requires that transactions specify in these arrays what they're going to touch so that we can guarantee that we can run fast.
Wait, so is it the number of things that we're accessing that matters, or the total size, or what?
That's an interesting thing. So until now, these things have been somewhat conflated. We say you're allowed to access up to 4 accounts, up to 8 total resources. And we've sort of there's a conflation between how much you're allowed to access and how many different things you're allowed to access. And that was an okay conflation because none of these objects are of arbitrary size. An ASA, for example, has a URL in it, the name of the unit, the number of decimals. They don't get out of hand. And so we can just say, well, you're allowed to access 8 of them total, and we don't worry about the exact size of them. But in fact, we are implicitly keeping track of 5 different things. The total number of things you read in, the total size of the things you read in, the total number of things that you might have to write, because if you're allowed access to these things, you're also allowed to change them, the total size of the things you might have to write, and finally, this is related to the size both of what you read and what you write, how much memory we're going to have to hold on to as we're evaluating this transaction and what we have to hold in memory for a little while until we write the transaction to disk. So 5 things, all related to the number of things you access and the size of those things. And we're going to have to tease that apart when it comes to boxes. So at this point, still haven't told you what boxes are, and I'm supposed to convince you that this is pretty good. This is what last year I would have tried to convince you. This was pretty good. We've got global variables, we've got global state, we've got local state. Apps can get at their global states. If they need more user state, they're fine. And although there are these limitations, it happens to be 8 right now of how many things you can access in one transaction. If you think our core engineers are going to do a good job, over time that might grow, and that's probably a good limit. The limit's there for a reason. But it's not so great. Can you see some problems with what we have here?
Right. Well, as I said earlier, you have a limited amount of state, right? And what if you need an unlimited amount?
Yeah, and there's even trickier problems. So that's a definite problem. Let's see.
I mean, you've said that I could just use more local state, and that's a form of unlimited. But are you actually suggesting that I should, create accounts just to use their local state?
See, that was the trick that is possible to do, but is utterly ridiculous, and boxes solve. So if you wanted an arbitrary amount of state in the past, you could, if you wanted to, conjure up an account out of thin air. And in particular, Algorand has nice support for this in the form of logic sigs. Logic sigs give you a way to sort of create an account out of thin air that can only do certain things. So if you were a very clever and needy app, you might conjure up logic sigs in your app to create a new account and then opt that account into your own app just to get the extra space that would be associated with that account's local state. It's really complicated, wastes a lot of opcode budget just to give yourself the state, and we've heard from those who have gone down this route that it's essentially unauditable. One of the things that we pay much more attention to these days is how auditable the AVM programs end up being. If you have to do something very, very complicated, then you're probably going to have bugs, and you're not going to be able to convince your auditors that you don't, even if you don't. So we really wanted to help people move away from that pattern and give them a more direct way to allocate state that they control. There's also a couple funny things where even if you think you're going down the happy path, where an account opts into an app and therefore you have extra state, in fact, that account remember, the account is the one that paid the minimum balance, and therefore Algorand allows the account to remove the local state. The app doesn't really have full control over that state. The account does. And this makes it very tricky to do certain kinds of apps, for example, that want to keep track of debts. If I can wipe out my debt by wiping out the state that's associated with my account, then that's not a place where an app can safely store information about my account. Finally, we hear from some people, especially those implementing high-level languages, that this model that was originally designed to make it easier to write TEAL code, where you have this associative array of key-value pairs, that's just awkward. They want their 8 kilobytes or 2 kilobytes, depending on whether it's global or local storage, and they just want easy access to that big hunk of memory. They don't want to use the key-value pairs. And so these are all things that make using local state as a proxy for arbitrary global state awkward. So let's design boxes. What would you do to improve them?
Well, this is probably obvious, but why don't we just make global state unlimited, right? We use global state already. Why can't we just remove that 64 limit? I mean, didn't we remove the limit that previously existed for opt-ins and assets?
Yeah, we figured this out before. Why don't we just figure it out in the same way here? So with, it used to be that you could only opt into, I think it was 100 ASAs as an account. And the reason for that was because we stored all that information in one place. And so as you opted into more and more accounts, more and more ASAs, every time we touched your account, we had to read in a big blob and then write a big blob. We separated that out and solved that problem. So why can't we do that with global state? Why couldn't we make all each global variable, put it in a different place, and so now you can have as many as you want? And the answer is now, if we did that, remember, you can access any of the global variable you want. So what if some app had 1 million global variables stored in this way, And then they started iterating through them and touching all of those million variables. That seems slow.
Yeah, I guess we maybe need to limit how many a single transaction can access.
Right. So we've done this before. I just told you about the static access bounds. We could start doing something like that, except that's not going to fit in very well with the way today's programs are written to use global variables. Today's programs assume that they can touch all of their global variables. That's part of the convenience and nicety of allocating your global variables at the beginning. So how are we going to deal with all of our existing programs that expect to be able to touch their global variables, like rational programs?
Well, I guess the current programs, they expect the limit of 64. So why don't we make the limit 64?
Yeah, it's kind of a trick. We often play tricks like that. We say, well, existing programs couldn't possibly think they're going to access more than 64 global variables because today's limit is 64. So maybe we could enforce a limit that says, well, even if they have 1 million global variables, they can only access 64 of them. The trouble is, our static access rules gave us two nice properties. One of the properties was how many things you're going to touch. But the other nice property that I didn't spend much time on is that they tell you ahead of time which things you're going to touch. And so you can figure out whether two transactions would be touching the same information. And we can prefetch it. We can get it ahead of time. It's not just how many, but which ones.
I see. So we can't just limit them. We also, I guess we can use the same for an array trick that we did previously. We can create maybe a new array for this new type of state, these key value pairs.
Right. So we'll make a new boxes array. You'll have to tell us which boxes you're going to touch. Global state array. You have to tell us which pieces of global state you're going to touch. That would be pretty awkward for existing programs because existing programs don't really want to tell you which ones they're going to touch.
I see. So we should give the existing or all programs access to those 64 that they're already used to. Stays the same, but maybe we create a new type that you can have as many as you want, and you have to, when you're using a transaction, pre-specify which ones you are going to use.
Yeah, so let's separate these ideas entirely. That way we don't have to worry about tricking old programs into seeing their old behavior. We'll just keep global state the way it is, and we'll make a new thing that are key value pairs that are separate from global state. They are globally accessible. Let's just use a different word for them. Any suggestions?
Yeah, let's give it a cool and pithy name, like boxes.
That sounds nice. I like the word boxes. Let's see. So at this point, we've got something that sounds like it's going to work. Have I not been going down this thing? This is everything that we just said. Sorry about that. So now we've got a pretty decent story. So the story so far is that we've got a box that's a new kind of key value pair. We've got a new boxes for an array where you have to say which boxes your application is going to touch. We'll use the same limits as we had before, so you're allowed 8 total references. Before they could be ASAs, accounts, and apps. Now they can be ASAs, accounts, apps, or boxes. For a technical reason, they have to include the app ID as well, but basically you have to specify the names of the boxes that you're going to touch. And the MBR here, this part's slightly tricky. Remember, one of the problems that we had with local state is that the account that opts into an app is still in somewhat control. They can delete that state. So let's, instead of charging let's not say that a user has to opt in to allocate these things. It's the app that wants to allocate these things. So it's the app that is going to have to pay the MBR. So apps have associated accounts. Apps are going to have some algos if they intend to use boxes. They're going to have to hold on to some algo, a minimum balance.
Wait, I have a question on that.
Yeah.
So does this mean that when I create my app, I have to give it like 100,000 algos if I want to be able to use lots of storage?
Yeah, if this worked like our existing global storage, you'd have to say ahead of time how much you might ever use. You have to say whether you need 20 pairs or 64 pairs. But here we're going to have to allow the app to make a dynamic choice to allocate. And so you're only going to need those algos when you perform the actual allocation. So you're going to have to, at creation time, you'll need them. And I forgot to say, if you ever want those algos back, if you, the user who created this app, ever wants those algos back, you're going to have to make it so that your app knows how to delete those boxes when it's done with them. So just as you wouldn't throw away your keys if you've got algos in an account, you shouldn't throw away your app if the app has algos. That would be throwing away the authority for those algos. So don't delete apps if they still have boxes. Right. Any other objections?
Yeah, this all sounds pretty good, but as long as we're creating a new thing, can we reconsider this key value system where we limit it to 128 bytes? I mean, that made sense for global state, but is that what we need going forward here?
Yeah, we used to require that they be quite small because we knew that you might have a bunch of them together. You might ask for up to 64 key value pairs. So we needed each one to be small enough so that we would do one big read off of disk and get the entire global state of the app. But I think we can make them bigger. However, with global state, if we knew how big they were, and so we could charge you your MBR. If you're gonna have big boxes, and I don't know how big they are to begin with, when do you think we should charge the MBR?
Well, I guess the MBR should hopefully work, proportionally to the number of bytes that are in the box, and it would probably be easier if the box stays, like the box size cannot be changed. So the MBR gets locked up when the box is created and returned unlocked when the box is deleted. So different box sizes could have different MBRs, but you could not resize a box.
Yeah, right. So we're going to move that when we enforce the MBR to the creation or deletion of the box, not the creation or deletion of the app. That was part of what we did to deal with the million boxes case. And we're going to charge you a larger MBR if you want a larger box. We're willing to give you a large box because we're charging you sort of the full cost of an object read for having a box, so we might as well allow those boxes to be kind of proportional in size to our existing objects like ASAs and local states, total local states. So we're going to let them be bigger. We're going to allocate them at creation time. How much bigger, by the way, do you think they should be?
Well, we should make them as big as possible, but maybe, I don't know, 8K?
8K sounds nice because that's kind of proportional to how big apps are. The trouble is the AVM has a limit on the size of internal types. You can only have a 4K string in Teal, so boxes that are bigger than 4K.
Right. We would need to create some way to read in those boxes in pieces, I guess, onto the stack in the AVM.
Yeah, let's make basically a read-write sort of interface. The way normal programs don't have to read in entire files at once. They read in the parts that they need using a read-write interface. So we happen to already have opcodes that deal with pieces of strings. So we'll make very analogous opcodes that deal with pieces of boxes. So we'll introduce opcodes. We'll call them extract and replace because those are the name of the box extract and box replace because extract and replace are the opcodes that deal with strings. And that'll allow you to, if you have a box that's bigger than 4K, you can just ask for, please give me the bytes from 100 to 132, for example. That still seems, by the way, that if each of these things can be 8K, and I let you access 8 of them, now you're accessing 64K. That's an awful lot of state for something that should execute so quickly that we can do 6,000 per second. So if our boxes can be that big, how are we going to deal with the fact that that's going to potentially make our transactions access a lot of data?
That's a tricky one. Well, what we use to limit this is the foreign arrays, right, traditionally. But so I guess we need to change the way these work a little bit. Right? We're expecting each foreign reference to give us access to a certain amount of state, but now we have state entities that are bigger than what we previously expected. So maybe what we should do is, if you want to access a large box, you actually need to use up several of your box array references.
Yeah, this is where we're going to tease apart what I told you about before. We're teasing apart the notion of how many things can you touch and how big is the total size of the things you can touch. We used to not have to tease those apart. We gave you 8 references. We knew that none of them were going to be particularly large, so we basically, by giving you 8 references, we controlled both the number and the size of the things that you were touching. But now we're going to say you get 8 references per transaction. You might just sort of use up your quota of touching things. We don't want you to use 1 reference for a very big box and then the other 7 references on reading 7 different ASAs. If you have a very big box, you might have to use all 8 references to tell us, I want to access 1 big box. And so we're going to, what we've settled upon for now, it might increase in the future, is that for each box reference that you give, you're allowed to read in 1K worth of data. So you might use the same box reference 4 times to tell us that you're going to access a box that's of size 4K. Now, that works pretty well for reads, because if you tell us what boxes you intend to touch, we can, in fact, I told you, we're going to prefetch these objects. We can count up how big they are, and we can say whether or not you violated this constraint. But for writes, it's a little trickier, because if you tell us you're going to access a box named hello, and it doesn't exist yet, we'd say, great, it's very small. No problem, that doesn't violate your I/O bound budget. But you might create that box to be very large, and now it's too late because the program is running. So how are we going to deal with not knowing what programs are going to do?
I see. So for writes, we don't know ahead of time how big the box is going to be. But maybe it's not such a problem because we don't need to prefetch it because it doesn't exist yet. So I suppose we can calculate at runtime how much you're writing, and if you're writing more than you had budget for writing, then the execution could fail.
Right. We've done this before, right? The opcode budget is a dynamic tracking of, we don't know ahead of time what your program's going to do, so we watch your program and we see how long it runs and what opcodes it executes. And if you execute too many things, lots and lots of hashes, for example, your program fails. We'll just do the same thing. We'll dynamically keep track of the number of things that you have pending for write. And so if you end up trying to write too much, we'll stop your program when you get to the point that you have too many things pending for write.
Well, yeah. So this all sounds great, Professor JJ, but we already have foreign apps, accounts, and assets. And if I'm writing a complicated application, I'm already using all my foreign references, pretty much. We only have 8. So how is this possibly going to work if I want to use a big box?
That sounds like a real bummer. What should we do? I recommend that we share these box references. So if the first, remember why we do these things. We force you to have these box references so that we can prefetch these things, and we know that we're not going to waste time during your execution going to get them. So if you've got a transaction group and your first transaction says, I'm going to read box A, B, and C, do we really need to force your second transaction to also mention that if it wants to touch A, B, and C? Instead, we can just read them all in for the whole transaction group and allow access across those groups so we can share these references. And so if you need to access, the maximum box that we're going to let you touch, by the way, is 32K. If you want to access a 32K box, you need to use 4 transactions worth of box references. But you are allowed to do that now because these references are shared across the transactions of the group.
And you're paying for that by the transaction fees.
Yeah, in essence, we were willing to give you 8 references for paying 1 min transaction fee. So if you give us 4 min transaction fees, we'll let you reference 32 of these boxes, or 32K of stuff. All right. So we'll make them shared across the group. Okay. So now I can summarize the final story. This is what you're getting now, or in about a week when mainnet votes it forward. The size and the MBR of boxes that you want to create gets determined at creation time. When the program is running and you execute the opcode box create, then the app's account must have enough algos to pay for it, and that MBR is tracked. And that's also when we would keep track of that write. Each box reference that you have in the transaction, and in fact in the entire transaction group, is summed together, and the sum of all the box references in your entire group tells us how many bytes you're allowed to read and how many bytes you're allowed to write. Writes do count the whole box. So if you have a box that's of length 3K and you write a single byte to it, that counts as a 3K write, because in fact that's what ends up happening. We have to write the whole 3K to disk. Create is considered a write. If you create an 8K box, then you had better have a budget of 8K available, because we're going to have to write 8K worth of zeros. Because boxes, by the way, I don't think I've explicitly said this, boxes always have their given size. They're not like files where you append to them. They have the size that they're given when you create them, and if you were to read them before ever writing to them, you'd see zeros. However, if you delete something, that wipes out the pending write. So if you create a box of size 1K, manipulate it for a little while, and then delete it before the transaction group ends, you don't need to have quota for that write, because in fact, we will never have to write that. We're going to know by the time your transaction finishes that you don't need it. And writing to the same box is fine. If you manipulate the same 2K box 6 times, you still only need 2K worth of budget, because we're only going to have to write it once when the transaction group is finally done and is ready to commit. And we recommend that you use something called the empty ref to grow your I/O budget. If you just need more I/O budget, you need to tell us that you're going to need more budget. Put in a reference to the empty box. That is the box with no name, because a no-named box is otherwise illegal. They count across the group. This is true both for availability and for I/O budget, so I think that's clear. And this is actually a nice change that I think people will appreciate compared to the way our foreign arrays work for inner transactions. You do not need to load up the box foreign array when calling an inner transaction that needs to access something. All of the box references that occur at the top level are available to all transactions in the group, whether at the top level or down below. So in fact, not only don't you have to, you can't explicitly set box references for inner transaction calls, and you don't need to. The ABI, I should say, needs some work, and that's something that will probably be a little bit community-driven. We're going to need to see how people use boxes, how you ought to specify that a particular application call needs a certain box. Yes?
Professor, so I have a question. If we're sharing box references across the group now, could we consider sharing other references across the group too? Why can't we do that?
It makes sense, right? For the same reason, right? If we've done an algo transfer of USDC in transaction 0, and then I want to read the USDC URL or unit name, we know that the USDC object is already in memory, so we should be able to share other kinds of references as well across the group and really simplify some programs. And in fact, that's one of the things that we're going to be working on next. It's not quite as simple as it appears. With boxes, it's really simple, because specifying that you're going to access box X, that's all that means. But when you specify that you can access account A and asset X, you're also implicitly saying that you can access the holding, the balance for account A's value of asset X. And so there is an interaction that we need to be careful of to make sure that when you share these things across all of the transactions, that you don't have a quadratic blow up in the number of objects that you can access and cause an awful lot of disk access. But we think we can just check at the beginning all of the objects that you can access, not only at the account, asset, and app level, but also at what we call the holding level, the balances of assets, and let you access them throughout the entire transaction group.
Hey, that's great to hear that we'll be able to do that. But these foreign arrays are already pretty annoying to work with, and this sounds like it's going to make them even more annoying. And can we make that easier? Like, I don't want to have to specify what I'm going to need to use before I call something.
Yeah, it's pretty annoying that you write a program, and the program, in its code, accesses a particular box, and you have to not only write the program that makes its choices and accesses what it wants to access, you have to write down as the programmer ahead of time what things you're going to access. That's something that we don't want to change in the sense that these are valuable hints to the evaluator and allow the evaluator to run very fast, but we want to simplify your life as a programmer so that you don't have to do that sort of grungy work of keeping track of what you're touching. So we're introducing something called the simulate endpoint that is similar to the dry run endpoint, but works better. And in particular, we're going to end up with a mode for simulation that runs your code against the current blockchain without worrying about whether you've specified static arrays or not, but it's doing it off-chain. It's just, since an AlgoD has this whole state of the chain, it can execute your code, find out what you would have touched, and then report that back to you. It says, yeah, your transaction would have been fine, except you didn't specify the following 6 things. And then your code can just pack those things in, actually sign the transaction now, submit it, and never have to do that grungy work of keeping track of what you're going to touch, especially if that were to change based on the block, the current state of the block.
Awesome. I look forward to next class.
We're happy to take questions, and otherwise, we'll see you next year.
Great work, JJ and Ann. Thank you so much. Yeah. Questions, we are going to make sure that you guys know how to connect with them. Of course, I do DevRel. We're certainly out there working closely with Ann on the product team and also with JJ on the engineering team. And they are here for you, Algo devs, out there to solicit those types of questions. We bring them through Ann, through the product team, so they get into the protocols, so JJ can build them in. So we want to make sure that you are connecting with us on our Discord server and on Twitter as well. Follow @AlgoDevs, and we will get those questions up to you guys. So I want to thank you very much for taking us through really what is programmability. When we heard Paul speak earlier today about the three pillars of the Algorand development, like what he's working on in product, he talked about programmability as one of the big things. So that's what JJ and Ann were talking about here. And next up, we are going to take a look at the core protocol part of that. And we are going to welcome to the stage Noah and Chris, and they are going to talk to us a little bit about the performance improvements that we have been enjoying over the past few months as the engineering team have been delivering once again, as we have consistently been doing, in delivering new features and new performance to the Algorand blockchain. So with that, I want to welcome both Chris and Noah to the stage here. Noah, like Ann, is also a senior technical product manager, and Chris is an engineering lead, director of engineering.
And present the thing up there.
Technical engineering. I apologize, Chris. Yes, Chris is awesome. We are thrilled to have these guys here. So hope you guys are all enjoying. We will have more talks on this stage throughout the day. So after they are wrapping up, we will also have the pitch competition, which will be going off following this presentation here.
Yeah.
Again, we are going to be looking at Algorand performance improvements with Noah and Chris. You guys all set? All right. We will just have some fun. So
there you go.
yeah. And who's got questions for me? Right. I can do a little stand up here. Shout out to everybody out there on the live stream. I told you to follow @AlgoDevs. You can follow me. I am Ryan R. Fox. If you want to follow me on Twitter. Who else we got out there? We've got the DevRel team here on site, and we are also available for you online on the Discord server. Right, you can follow us at discord.gg/Algorand. That's where we've got over 35,000 developers connecting with us there. Asynchronous communication is there. We've got Nullen and Barnji here in the back of the room on the beanbag chairs. If you are here and want to come and meet those guys, we hope that you will do that. We've got Pranjal, who is coming in from the India region. We got Joe P. He shares Massachusetts with me in the States. Yep. And we are ready to go. Glad you guys are here. Noah and Chris, welcome to the Greenhouse Tech Talk stage.
Hey guys, I'm Noah, and this is Chris. We're from the core protocol team here at Algorand, and today we're going to talk to you about core protocol performance. So blockchain performance is a highly touted area. While first and second generation blockchains offer a lot of promise, they become difficult to use if only a few people can afford to use them at once. Over the past few years, we've seen a rise in the number of Layer 1 and Layer 2 blockchains competing to solve these scalability issues. With so many options out there, it's been hard for projects to choose which chain to build on when so many of them claim to safely solve or reach these scalability issues. Sorry, technical problem. As our industry starts to move into the value creation phase, we're starting to see consumer-grade applications solving real-world problems built with blockchain technology. These teams want to know what security or decentralization trade-offs are being made behind the scenes as it can directly impact the user experience. So where does Algorand fit into this picture? Well, a few years ago, Algorand launched with a novel pure proof-of-stake consensus mechanism. Pure proof-of-stake is hyper-focused on decentralization and security, which impacts how we approach scalability. So there's a lot to cover here, but I'll call out a few highlights. First, Algorand uses a verifiable random function, or VRF, which randomly samples consensus members to propose new blocks and to form voting committees that validate these block proposals. Since the VRF uses random sampling, Algorand fixes each committee to a maximum size, regardless of how many online participants there are. By fixing this maximum committee size, the network can scale up to handle millions of participating accounts without restricting performance. Second, Algorand has a low barrier to entry. People can participate in securing the network with as little as one algo, which allows it to become more decentralized over time. And third, Algorand is one of the first movers on post-quantum security. By launching state proofs, the Algorand blockchain now uses post-quantum cryptography to attest the state of the blockchain, allowing it to protect blockchain history from quantum computer attacks. What this all means is that the blockchain is well protected from risks like downtime, censorship, deplatforming, economic attacks, and lots of other nasty stuff that comes from centralized trust assumptions. For example, since Algorand uses random lotteries to select block proposers, the network needs to route traffic to all online participants, which means consensus votes, transactions, etc., rather than filtering it to one specific node. This makes it really hard to target or bias individual proposers or voting committee members because nobody knows who they are until after their job has already been completed. This is in contrast to many other blockchains who know who block proposers will be in advance, which allows them to achieve large performance gains by routing traffic to a specific set of nodes. However, this comes at the cost of reducing decentralization and increasing the associated risks that come with it. So Algorand has made some design choices that boost decentralization and security, but restrict some of the ways that we can boost performance. So how do we scale it up? Well, there's a bunch of different techniques. First, you can increase the block size, because bigger blocks means there's more space to add more transactions inside of them. Second, you can reduce block latency, because producing blocks more frequently means you can settle more transactions on chain per second. Third, you can parallelize block production and verification. Now, this one's pretty cool, and it's something experimental that we're trying to play with right now. But if you think of each round, every round, you have a block that's assembled with transactions inside of them. You can think of this block as a train that's leaving the station. The block size determines how many transactions or how many seats there are on this train for transactions to fit on board, and the latency is how fast that train goes or how long it takes for that trip to be completed. Using this train analogy, currently only one train can leave the station every round, which is currently 3.7 seconds, but as I mentioned, that round time's continuing to come down. Well, what if in addition to this, we also added more tracks to this train station, so that rather than having one train depart every 3.7 seconds, you could have multiple trains departing within this 3.7 second interval. This would allow you to greatly boost your TPS and also, very importantly, reduce transaction latency, which means shorter queue lines, nobody likes waiting, you can have a transaction get on board a lot faster. Now, there's a bunch of other cool things that we're experimenting with, but I'll leave Chris to talk about some of those interesting technical details. So, what did we accomplish in the past year? Well, we delivered a bunch of optimizations under the hood that allowed us to 5x our performance to 6,000 transactions per second. First, we optimized the database for higher throughput so that, I'm sorry, just lost my train of thought. Higher throughput by making it faster to read and write to disk, especially when accounts have a lot of assets or have opted into a lot of applications. Previously, accounts were limited to create up to 1,000 assets or opt into 50 applications. Well, this new unlimited apps and assets feature removed a big blocker for higher TPS, with an added benefit to both the creator and DeFi economies. Creators can now mint as many assets as they want, and people can use as many DeFi apps as they'd like. Second, we delivered a bunch of optimizations on how we score account data. By significantly reducing the memory pressure on each AlgoD node, we were able to safely increase our maximum block size. So coming back to this train analogy, there's more seats on that train. And third, we reduced round times. So blocks are produced and verified more frequently, providing a better user experience and boosting TPS, which makes that train go faster. So you might be wondering, what comes next? Well, we're going to continue focusing on faster rounds, so we continue to make that trip faster. As Paul talked about earlier, we've got instant finality. So once that train reaches the station, there's no question on if those transactions on board are legitimate or not, making applications much snappier and making it feel even more like a Web 2 experience. So this 6K milestone is 6K TPS milestone is great, but what does this actually provide? Does this one number cover such a broad area as scalability or performance? Well, our industry has some problems with how we benchmark performance. We're missing a common framework to evaluate blockchains on some of these core protocol properties like performance. Looking at TPS, we have a few issues. First, there's a lack of standardization. So if different blockchains have different definitions for what even constitutes a transaction, how can we try to benchmark transactions per second across the industry? Second, there's a lack of breadth. TPS is a broad metric, capturing how many transactions can be settled on chain per second. But there's many different flavors of transactions. On Algorand, for example, you've got payment transactions, which moves algos from one account to another. You've got asset transfer transactions, which moves NFTs and other ASAs. You've got application calls, which is the bread and butter of smart contracts. And when you look at actual use cases on chain, they may use a mixture of these different types of transactions. So if you're looking at actual user actions that you can accomplish or outcomes per second, you might have a mixture of these different transactions. We can try getting more granular to demonstrate how these different use cases scale rather than some broad metric like TPS. Third, there's a lack of transparency. If people like the numbers they're seeing, how can they actually verify that these numbers are legitimate? And what trade-offs are being made that might expose people to security or decentralization risks? Well, it's very early on this, but we're starting to think about how to create these frameworks to measure blockchain performance and other core protocol properties. This is going to be a collaborative effort, so we're looking for feedback from the community and builders to see what types of benchmarks and standards you think would be helpful. So if you find this interesting or have some cool ideas, please come talk to us after the talk, and we'd love to chat. That's it for my part, and I'm going to turn things over to Chris.
Hi. So I've been asked to talk a little bit about what goes on in a typical round in Algorand, and then how that maps to our priorities on roadmap for performance. And these are really broad categories of work for each of these different phases of what happens in a typical round. And there's a lot of work we're currently working on, or we've already completed, or we're still thinking about or doing research on. So the first thing that happens in a block's round, the round of an Algorand, the consensus protocol has these three phases. There's block proposal, there's the soft vote, and then there's the cert vote. And if you've read about the protocol, those are typically the terms you hear. And then in between, there's this idea that we need to make the blocks and then push them out to all the voters and then get them to them in time and then validate the blocks in time for the cert vote. So I'm going to go into each of those different phases and then talk about some of the work we've been doing or are thinking about or have already done on each one. So the first step is block proposal assembly, and this is kind of a race, right? You get the last block was just confirmed, the cert quorum was observed, and now it's a race to just evaluate the transactions you've got ready to go against the state that may have been changed in the last block's confirmation. And so you're at this moment you're both accepting the state that just confirmed from that would have changed the ledger, and then reevaluating transactions against this updated ledger from the previous block. And this is really, a great place for benchmarking, optimization, and just focusing on, as blocks get bigger, how can we make it quicker to assemble blocks and get them out to the network as quickly as possible. So this is not at all a complete list of all the types of optimizations you want to do. This is kind of a grab bag of topics that we put together for this discussion. But in general, with larger block sizes, more transactions, block assembly can take more time. And so one of the first optimizations Noah already mentioned is this idea of optimizing the storage and the database that represents the ledger from the point of view of a transaction so that a transaction's data can be retrieved as quickly as possible. In the last year or so, asset transfers have taken up the majority of transactions on Algorand. And so optimizing for asset transfers, led us to this idea that splitting the resource storage of assets and apps and from their holders and their creators, so that when you transfer an asset, as little state is required both in memory as well as on a disk, or CPU required to copy pieces of information. This led us not only to optimize the storage and the handling of asset data and app data, but also to dereference them from the accounts that are the creators and the holders of the assets and the apps, and then also make it totally unlimited, the number of assets you can hold. Whereas before there was this limit of 1,000 assets and 50 apps you could opt into. And this type of feedback from just what people are doing on chain, is driving the benchmarking and the sort of the profiling we're doing on the types of transactions you want to make faster. And similar to database and storage optimizations on the schema and the ledger, there's also just the evaluation and how much caching we can do from when we first observe a transaction. It comes into the network, nodes evaluate the transaction right away, and then later when it's time to assemble, there are side effects of the first evaluation that can benefit the second one, right? And so anything we can do where when the transaction is first received, this gives us a chance to observe ledger state that may have been touched or read or written as part of transaction processing, or even just validity checks and signature checks that we can use to speed up that second evaluation. And so that's a very large category of caching improvements we could make. CPU optimizations is as general as it sounds. Everything about the way we process transactions and the code we write and the way our systems are built to make it as quickly and uses a little CPU work as necessary to handle a transaction and assemble that block as quickly as possible. And then finally, parallel transaction evaluation. That's the idea that two transactions that may not at all affect each other's state, logically should be able to be processed in parallel. And so this is some work we've been thinking about and researching about how to handle transactions and assemble them in parallel when they don't touch each other's state. After a proposal is assembled, of course, you need to get it out to the world, and the most critical path is between the proposers and the set of the soft vote and cert vote committees that are responsible for voting on whether that proposal should be accepted by the network. And so a small detail is that the proposal is split between this small proposal hash and then the proposal payload. And so non-winning proposals are just sort of discarded by the network as they propagate, but the soft vote is basically, as we'll see later, is based on the proposal hash, who's the winner of the proposal, and then the cert vote is based on the proposal payload, whether a payload was actually validated and received and certified by all the validators. And so the proposal propagation problem is sort of two-pronged. There's this small message that needs to get propagated quickly, and then there's larger message that needs to get out to everyone who's watching consensus traffic, whether they're voting or not. And so in this moment, it's drawn as a gradient because everyone's experience of when a proposal arrives is based on their position in the network from the proposer, right? So if you're really far away, either geographically or logically, all these different hops and different paths between you and the proposer would determine your observation of when that proposal arrived. And so that's why there's a big topic here about just network routing and gossip protocol improvements, where we're always looking at how we can more effectively use the gossip network that connects everyone on Algorand to get as quickly as possible this consensus traffic, and especially the proposals from proposers to voters and observers. And so one simple technique is just compression, right? We've got these bigger blocks all the time. We want to have bigger blocks, and so compressing the proposals and having effective but also performant compression to support the slower bandwidth times. And the network is there are constraints between any 2 points in the world that the network is the speed of light and bandwidth between ISPs and things that you can't control for as much as what you can do on a local node. And so there's all sorts of work we're doing on how to optimize the routing and the payload sizes. And then transaction deduplication refers to this idea that if I'm going to send you a proposal and you've already seen some of those transactions, I don't necessarily have to tell you them all because we have the shared knowledge of the same transaction. And so there's this opportunity for even better compression where we both have observed the same transaction, and so a proposal I send you might only reference those transactions in a smaller way than they would appear originally in the proposal. And then finally, this is something we're working on right now, is this idea of framing a block proposal. As we see block proposals get bigger and bigger, if you could split them into smaller verifiable frames, and that sort of optimizes the forwarding of all these different paths that are available between you and the receiver of a proposal. So if I'm getting the same proposal for 2 or more sources, I shouldn't have to sort of duplicate and have all this wasted bandwidth where I'm receiving the same data from 2 different channels, right? I should probably be able to make better use of the bandwidth so to get unique chunks or frames of the proposal from the multiple peers I'm connected to, and sort of speed up the transmission and the forwarding of proposals. And there's a whole bunch of optimizations we could make once we start to split up proposals into smaller verifiable frames. And then after proposals have been delivered, there's this whole concern of making sure they're valid, right? And so a soft vote is, again, not based on the validity of a block, but rather on the lowest credential, the winning VRF credential. But the cert vote requires that a block's been validated. You're not going to certify a block that hasn't been validated. So validation is very, very similar to assembly. You're just evaluating transactions and a block header. You want to make sure that everything is correct. And so all the optimizations we already discussed related to assembly do apply here for validation as well, with the extra benefit that a little more time has passed since the last round completed, so you have a little more space to make use of any information that might have happened from then. This is one big change. We changed the consensus protocol, and we changed our ED25519 signature validation rules to support batch verification. And this was a consensus protocol change that was pushed sometime this year to support just this case, right? You get a whole bunch of transactions you may never have seen before, and you need to check all their signatures in a batch. And so this is a speed up of roughly 2.5x, where you can process them much more quickly as a batch rather than one at a time. And all the other optimizations I discussed for assembly also apply. The idea of transaction evaluation being as fast as it can. Again, if you've seen some of these transactions before, there's opportunities for optimization as well. And then after the proposals are sort of propagating, maybe they haven't all fully gotten to everyone, or they haven't been fully validated, this idea of the soft vote, also known as the filtering vote, or the filter vote if you've looked at some of the specs, is this process of filtering down 20 proposers on average to just one winner, all right? And then everyone votes on who they observed was the lowest credential. There's this winning VRF credential hash that signifies you're the winner of the proposal lottery. And so the soft vote is the only fixed timeout, or in this diagram is the only fixed timeout event that occurs during a round. Is every X seconds since the beginning of the round, the soft vote fires and everyone votes for who they observed was the winner. So our goal is to make sure that by the time that happens, all this information is in place to make sure that everyone votes correctly, as well as we try to squeeze round times closer and closer together, have faster and faster rounds, we need to have a higher throughput of votes that we can process, right? And so we don't typically think of consensus traffic as a huge bottleneck or a very big draw, but as we make more rounds, you need more votes, right? And so having all the optimizations we can make on assembly, agreement traffic, consensus traffic, so that we're always keeping up with the demands of the higher throughput from faster rounds is a project that we've continually been working on. And so this continually improving in terms of the batch verification. Every vote is actually 3 votes, so even just a little batch verification there speeds that up. Again, all the idea of network routing and priorities for consensus traffic and the gossip protocol improvements that really pay off here as well. And then, one thing we've been doing is we've been reducing the soft vote timeout, and that creates faster rounds. The more we get towards comfort about the effects of changes on the network and how we think mainnet can handle it, we've been reducing the soft vote timeout as well. And then there's this idea of a dynamic soft vote timeout that has come up in research, where you are adjusting according to the network conditions. As in a rapidly changing network environment, there are occasionally possibilities that huge tier 1 disruptions occur, and you might want to have that be reacted to by the soft vote timeout. And so this is something we've also been thinking about and working on. And so the cert vote, final step, last slide, and is the process by which everyone finally says, okay, this is the winning block. And so the proposal that received the quorum of soft votes is the winner of the cert vote. And so there's this whole separate committee of a couple thousand people who vote on the first quorum, but with the extra requirement that they've also all validated the block, or else they won't make a cert vote. And so here's another opportunity where being able to process all the soft votes really quickly so you can turn around the cert vote is important, and that's where batch verification might come in handy. Again, all the network routing improvements we discussed. And then also the cert vote, you're basically, the dead time in a cert vote is just issuing a cert vote and everyone observing a cert vote quorum. So it's kind of this all pairs broadcast situation where you're just sitting around waiting for the entire network to exchange the cert vote and observe that a cert vote quorum has been achieved. And so you could just get started making the next block, right? If you're reasonably sure that the block you just voted for is going to be the winner, why wait until it gets confirmed to start the work on the next block? And so this is something we're excited about called speculative assembly. It's this idea that you might benefit or get a little more, squeeze a little more assembly time out of kicking off that next block before the first one, before the current round to confirm. So that's why I've drawn, right after round n+1, this idea of block proposal assembly being able to start maybe a little bit earlier. Of course, if the block you voted on didn't win, you should not, that's not a proposal you should send anyone, right? But the idea that you can get started a little earlier is something that's related to pipelining, which is another technique of kind of making, taking advantage of parallelization of the rounds, right? So speculating on n+1 leads you to think, well, if I've already pretty sure that what n+1 is going to be, maybe I should speculate on n+2 and so on and so forth. And so the idea of pipelining is, speculative assembly is sort of like the first step towards this idea of this more general concept of pipelining. That's all I got, but I hope this was illuminating for some of the parts of the consensus protocol that might have been. Any questions? I already see one. Thank you. Right. Yeah, so this is part of the engineering team.
Please repeat the question.
Oh, yes.
Maybe
yeah.
I'll let Anne ask it again.
Oh, when you make these performance optimizations, how do you then test the network to make sure it worked?
So this is in the theme of the engineering team's process of continual improvement. We're always running benchmarks. We're always running internal test networks, simulating networks of dozens to hundreds of nodes and even 1,000 nodes to make sure that we've got different use cases mapped out to different benchmarks and making sure that different transaction workloads or different node profiles and hardware constraints are all kind of modeled out. And and so this is just sort of something we're always doing and always thinking about, and even small improvements and big improvements are sort of measured against this baseline, or the various baselines that we've worked on.
I have a couple of questions on the consensus protocol. One thing is that is a pure proof of stake, right? And it uses a VRF. So does it prioritize, let's suppose VRF chooses the node, validator node randomly. Does it give priority to someone with a higher stake? Because VRF will have to choose the node randomly, right? But what if I have the higher stake? Because proof of stake means that if you have the higher stake, you should get the more priority to assemble the blocks and get more rewards, right? So how does that work?
Oh, you're asking how does the VRF interact with the amount of stake you have?
Yeah.
Yeah. So your stake is weighted, right? The stake determines your weight, and so you can think of it as the number of lottery tickets you have is relative to the stake amount you have. So when I said the lowest proposal is the winner, you actually have more than one lottery ticket in that scenario, and so the lowest hash you might have 20 chances to get the lowest proposal hash, whereas someone with less stake than you might have 10 chances to get the lowest proposal hash. And so it's like you've got more raffle tickets, basically, if you've got more stake.
Right. And I think one of the previous talk there was one of the thing that the block validation at the final time is 3.7 seconds, and the throughput is 6,000 transactions a second. So how do you fit 22,000 transactions in a block? Because right now, if I see the block explorer, the transaction I can see is 30, 40. So I think the current usage is 10 transactions a second, right? Current usage is 10 transactions a second.
Oh, current usage.
Yeah.
Yeah. So right.
Yeah.
So internally, we're always testing, much higher levels.
But if you fit from 10 transactions a second, if you fit a 22,000 transaction in a block, from current I can see is 100 transactions in a block, right? So would it reduce the validation time? Would it increase the time of the block validation? Because I think it is tested in the testnet that you are actually putting 22,000 transactions in a block, but right now on a mainnet I can see is 100 transactions in a block, right? So would it increase the time? You are trying to reduce, which is good, but wouldn't it increase the time if you put a 22,000 transaction in a block?
I didn't fully understand.
6,000 transaction is a throughput. But if you assemble a block in 3.67 seconds, then it means that you are putting the maximum transaction of 22,000 in a block, because that's 3.7 seconds, right? The throughput is 1 second.
Oh, I see. Right.
Yeah.
So you're right. So bigger blocks you're observing on different networks have different finalization times. Yeah, and this is something we're also working on continually improving. You know, on test networks like testnet, there's a vastly different performance characteristic based on how many nodes and the size of those nodes and what their CPU and performance constraints are. And so internally, we test on a lot of different profiles, and this kind of informs our recommendations to validators and node operators for what they should be running. You know, bigger blocks just need more CPU for more signature validations per second, for example. Higher transaction workloads are going to require just higher TPS means more in there's only so many signatures per core you can verify, right? And so the idea that there are some baseline CPU requirements for these higher TPS, either for validating the transactions as they come in or for assembling the blocks, this is going to be observed in different ways on different characteristics and hardware constraints. And so internally, we do test on all different sizes, and certainly with bigger nodes and beefier nodes, you get better numbers there.
But internal verification is typically on the network, which is not very decentralized, right? It is because internal validation is testnet is centralized, right? It's not so when you put 22,000 transaction propagation delay and propagation through the network, I mean that would cause, I think, immense amount of delays actually. Yeah.
It still depends on what transactions are you actually validating, because every transaction is different.
Yeah.
So that's only a theoretical level.
Yeah, this is what I mean. I mean, it's a theoretical level, yes. 6,000 transaction throughput seems achievable, but putting 22,000 transaction in a block is actually immense amount of work, especially if you have to propagate it to thousands of nodes, validated nodes, right?
It's not a hypothetical number. Like, these numbers are observed in mainnet, observed on testnet, long-running networks with full blocks at whatever it is, 26,000 transactions a block. So it's not we're not saying, hey, theoretically we think it would hit 6,000. We're saying we've observed this in long-running public networks.
It still depends on what the transaction does, because every transaction is different.
Sure. Yeah, absolutely. You know, all tests have characteristics about the test. We also have, you know, runtime guardrails. If you know, talked with the last presentation talked about the static bounds, but we've got bounds to make sure that you know you don't get one transaction that you're going one transaction a second. But yeah, you're right. Yep.
Yeah, hi Chris. So I think all these improvements are exciting and make sense. All the directions. Yeah, can you hear now?
Yes.
Yeah, I think all these improvements are exciting and make sense. You know, different pieces that you're trying to improve. I think my question is about, you know, back to the initial paper and you know the architecture of distributed system. You know, some of the fundamental parts of the whole thing. How much you guys are thinking about changing those parts? For example, you know, the architecture of this. So having relay nodes, how different nodes are connecting to each other, or you know, changing more fundamental parts. I'm not sure whether that's something that your team as an engineering team wants to work on that, or the research team, but it seems that any change there can produce probably much more, you know, result if it's possible. So how much work is being done on, you know, thinking about what parts of the whole you know, consensus and also particularly distributed architecture can be improved or, you know, fundamentally changed?
So you're referring to the consensus protocol or just the overall?
Anything that comes from the, you know, initial design, right? So it can be questioned. There is no reason that that's the final thing or the best thing, right? So of course that was an improvement to anything that existed in the past. But many parts of the design, initial design, there is no, you know, final answer that why it should be the best thing, right? It can be theoretically changed or replaced with something better. So yeah, so I think that's my question. How long you want to just stick to that design, or how much you are thinking about changing that design?
Yeah, I think there's a lot of changes we've thought about that are sort of radical changes to the consensus protocol itself. The idea of having sort of overlapping consensus traffic and having this idea of pipelining or speculating on the next round, those are big changes to the consensus protocol that we didn't originally consider. This idea of splitting up the proposals and having them be more optimally forwarded, and a lot of the network routing improvements I think might be more closely mapped to what you're describing. This idea of a totally flat architecture, or the idea of a gossip network that is relatively elegant, but could, optimization of the routing itself is like a huge opportunity for us to kind of depart from some of the more, naive gossip traffic forwarding techniques that you might see. There's already some work we've already shipped and currently rely on where nodes are kind of preferring faster nodes, and there's this behavior in the network that optimizes for faster paths, but we can always improve on that and do better, and that's something we're actively researching. A lot of the papers kind of present things in this kind of mathematically abstract way, but since those papers were written, there are a lot of in-practice optimizations and improvements and under-the-hood changes that you might not notice, like the routing improvements that already exist, for example. But yeah, without drilling in on every individual topic, I couldn't speak to like the architecture that you're describing. But I think there is more difference between the abstract sort of mathematical presentation of the Algorand protocol and its implementation than people might be aware of. And maybe that's on us for not documenting it as clearly or making the specs as clear. But I think there's a lot of sort of practical implementation decisions that have been made since then. Thanks.
All right. Well, thank you very much, Chris. Thank you, Noah, as well, for coming up and giving us this wonderful talk about performance and kind of what's been going on. All right. Well, this is going to bring this stage to a temporary close because it's time for lunch. Oh, who's hungry around here? All right. Right outside here, we've got some food for you. I want you to come back here in a half an hour's time because we will have the pitch competition starting right here on this stage. Come back at 1 p.m. here locally. GM. All right, welcome back from lunch. I hope you guys had a wonderful time at lunch. Welcome back to the Algorand Greenhouse Tech Talk stage. Please come on in. Welcome back from lunch. I'm Ryan Fox, Developer Relations at Algorand, and this is a really exciting afternoon that we're going to have here on the Tech Talk stage. We're going to kick it off with with a pitch competition. All right, so we've got, I believe there's like 10 different groups that are coming up to give pitches. So with that, I want to welcome to the stage my colleague, Joanna Moran, to come on up and MC this part of it. Welcome, Joanna.
Thank you, Ryan. Thanks a million. Okay, so I'm so excited about this pitch competition. So first of all, welcome to the Developer Greenhouse Pitch Competition. I'm head of developer programs for the Algorand Foundation. My amazing colleague here, Dave Greeny, beside me is a developer program lead. And I just want to, I guess, kind of tell you that this is not just a pitch competition that happened like out of the blue. This is picking up developers that have engaged with us through all of our hackathons throughout the year. So whether that was through our Developer Greenhouse hackathons, through AlgoBarat, ENCODE programs, Reach, EasyA or Wormhole Activate, and Angel Hack through Tribe. So there's just been so much work going into it, and we did the semi-final yesterday, and we got down to the final 11, which we're really excited about. So just to let you know that they have been on a journey, and please give them like a really warm and like, clap with them and cheer and really support them. Dave, you're going to do a quick pitch. So the format.
For sure. Thank you, Joe. So yeah, welcome everyone. I would just like to speak to the participants more so than the audience, and to explain to them that we are operating on a strict 3-minute pitch time limit. Okay, so at 3 minutes, we'll be cutting you off. I'll give you a 30-second warning that will sound something like this. After which you'll have 30 seconds. I'll give you a hard stop at 3 minutes. And then we'll have 2 minutes of questions and answers from the judges. We have 4 lovely judges here sitting at the front, ready to pepper our participants with questions.
So these projects are pitching to the accelerators in the Algorand ecosystem. So we have Michael Hoffweller. You want to raise your hand, Michael? Is from AXL Accelerator, and you are ending your applications in January. Is that correct? Yes. So any budding startups in the room that want to apply for the AXL Accelerator, you have till January. This guy over here. We have Lorenzo. Amazing, from the Rocker, Miami Accelerator. All the startups love Lorenzo. Sorry, not that there's favorites. So that's Lorenzo. Then we have Asim from Eterna Capital, and they just announced their cohort yesterday. So go online and check out the projects. And we have our new head of developer outreach, Jack Chan. Want to say hi? Okay, so we're going to kick it off with our first project, is Chessbox, excuse me. They were a Greenhouse Hack 1 winner, so that's where they came from. So please give a really warm welcome to Carlos.
Best of luck, everyone. Thank you.
Hello. Yes, today I will talk about Chessbox, an easy way to manage Web3 games assets on Algorand blockchain. So, the games industry global market size is about $200 billion. And basically it's increasing, and we can have a great relationship with Web3, metaverse, and games for the next years. And that's the Chessbox, a platform that won the Algorand Green Hack Hackathon. And I am looking forward to push this project for the next level. So here's the platform, and basically integrate an asset system in a blockchain can be difficult and can be expensive. It can be because it requires knowledge, know-how. So basically, Chessbox makes everything easy because it brings the complexity to the integration complexity to the platform, and the game developers don't need to worry about coding and this kind of stuff. So Chessbox, basically the game developer can use the Chessbox platform UI and create assets and integrate with games easily using the Chessbox SDK. So here is the business model of Chessbox. Basically, it's a SaaS, a software as a service. So we can have different plans for different business size. And yeah, currently Chessbox is a single-member project, but I'm looking forward to have a SDK developer and also a product developer as well. So why blockchain, why Algorand, and why now? Yeah, many players are very loyal to the games, and they enjoy having collectibles and ownership of the assets. So blockchain and NFTs are great for this. And Algorand is fast and has an on-chain standard asset. So basically, on-chain asset. So basically, it's so great for that. And the games industry it's growing, and it's a great moment for build a product like that. So next steps is develop SDKs for other languages, implement the SaaS business, and implement different types of assets. Games plus Algorand, it's equal Chessbox.
Finish it off with a mathematical equation. Beautiful. Thank you very much. Going to throw this open to our judges if you have questions, please.
So you mentioned you're looking for a couple of developers to complete the team. Can you also tell us what other needs besides development do you have right now, like business or financials or?
No, so far that project was built on the Gitcoin hackathon on Algorand Greenhouse, so I built everything so far, but yeah, I'm looking to have partners on this project and push this project to the next level.
So, quick question. What inspired you to build Chessbox?
Sorry?
What inspired you to build Chessbox?
What?
Inspired. Like,
yeah, that's a great question, because I was trying to build a 2D game, and basically it was so difficult to implement the game and focus on the Algorand itself, on the blockchain. So basically, I think it's a great product because small business like indie game developers can focus on gaming and not integrating on Algorand. So it's a straightforward path to integrate Algorand in a game.
Hi there. Who's your key customer? How do you know when you've reached product market fit?
Yeah, you mean who is my main customer, right?
Yes.
Yeah, the main customer should be the indie game developers. Like they have low budget and they need a platform straightforward to integrate with Algorand because it's so expensive to have a team dedicated to build the blockchain side of a game. The indie game developers are focused on completely build the core of the game.
Can you talk about your go-to-market strategy?
Sorry?
Your go-to-market strategy.
Yeah, my growth market strategy is basically focus on create a great relationship with the indie game developers and create a strong community in the environment of indie game developers and starting building games on web and later on, who knows, implement create a relationship with big players. But for now, the indie gamers would be a great fit for that.
Fantastic. Thank you very much. Round of applause.
Thank you, Carlos. Okay, so next up we have Contrato with Smriti. Contrato is contract to code solution on blockchain. So
quick tech briefing here.
Welcome. Please give her a big round of applause.
So good afternoon, everyone. I'm Smriti Chaudhary, and I'm building Contrato, the world's first contract-to-code solution on blockchain. The reason why we are building Contrato is to bridge the gap from paper to digital to smart contracts. Now, when we started, we realized that the World Bank data said that small and medium businesses world over is represented by almost 90%. So that is when we thought that we should help solve the problems that the small, medium businesses face regarding their contracts, invoicing, and the payments. We want to start with India, which is home to 63 million small, medium business users. So the first version of Contrato that we built is an integrated solution with eKYCs, e-signatures, and notarizations. And what you see here is a live snapshot of the product that we have built. The first dashboard is a complete overview of all the documents, the contracts, the actions, the reminders. The second one that you see is a document vault, which has the contracts, the documents, the notarizations. The third is a CRM, which is the business contact network, and we can initiate the smart contracts from this point. The last one, the transfers, is the financial transaction statements that involves the one-to-one transactions and all the activities under the contracts. So to summarize, what we have done is we have brought together all the business elements inside our relationship and built Contrato in a single window, providing all the services which was not available before to the small, medium business users. It is a complete SaaS business model, and we also want to build a blockchain, the smart contract, and DeFi on a commission basis, use it like a marketplace. So talking about why Web3, COVID has accelerated the process of digitization and moved people away from their traditional comfort zones. And thus, this is requiring so much of extra security, and there also has to be an ability to verify the documents from anywhere in the world. So we feel that Algorand, which has a very unique two-tiered structure, the base layer, which actually supports security and scalability for smart contract usage, and also because Algorand has a unique fusion of ability of fusing the traditional finance and DeFi to bring about a complete decentralization. This is going to actually help us at Contrato, and this is the reason we feel that it's a perfect fit for our use case.
Okay, I'm going to have to stop you there. Time is up. Thank you very much. We might start in reverse order with our judges' questions, if we have one, please.
Oh, okay, yeah.
Thank you. Could you talk a bit about your team, who's in it, and their roles?
Yes, I'm Smriti Chaudhary, and I have done my MDP Master's Development Program from IIM Lucknow, and I worked for 6+ years at Tata Motors, a very reputed organization in India. And my technology lead is Satya Prakash Verma. He is a young, very energetic, and a very fast learner. We have a great team of mentors, Mr. Vikram Pandya, who is an expert in fintech and blockchain domain based out of Mumbai. We also have Prasanna Lohar. He is the CEO of Blockstack, and he is also advising us. So we think we have a great team to take it on.
Hi. Can you go into your SME segment a little bit more? Can you be more specific about which kinds of customers are going to need this tool or this product?
The SME, the segment we want to target?
Yes.
Yes, that's wonderful. We actually have been awarded several times, and one of the organizations that awarded us was the NPCI, National Payments Corporation of India. We want to use that as a GTM strategy and go to the 10 banks which are already onboarded by NPCI and help them onboard their merchants and vendors. And we do know that the UPI is a huge success story in India, supported by the government of India. So we think this is a fantastic GTM strategy for us.
Why? Hi. Why can't this just be built on Web 2?
Why not Web 2?
Yeah, why can't it just be built on Web 2? Why do we need a blockchain?
Yes, we do. We already have built in the Web 2, but we want to scale it up by providing a very secure and a trustworthy network to our users. So that is the reason we want to build it, do a transition from Web 2 to the Web 3. And also, since we want to actually take care of all the financial transactions coming under the contracts, so the DeFi aspect will actually help, the small and medium businesses which actually are suffering today. They have a huge loss. That is where we want to actually help solve the entire problem.
Fantastic. Thank you very much, Contrato. Round of applause, ladies and gentlemen. Well done.
Thank you. Okay, so everyone who's just joined, welcome to the Build Pitch competition where we're finding the next wave of builders on Algorand. We have Wise pitching now, which is Saurav. Wise is tokenization as a service. This project came to us from the AlgoBarat endeavors, so please give them a big warm welcome.
Right, good. Good afternoon, everyone. I'm Saurav, and I'm going to talk about Wise, which is my solution. And this is just briefly talking about myself. While I'm building Wise, I'm also an astronaut at Algorand, right? This is my LinkedIn profile. If you go in there, you'll see that. And by looking at this, you know what is absolutely wrong with everything that is happening with social media today and the Web 2 world. So what are we solving for, actually? Trust. Everything that we are doing at Algorand, everything we are doing it with blockchain is to solve for trust and look for those green signs. That is when things move. That is when entities trust each other. That is when we get into business, right? But if businesses have to come to Web 3, they have a lot of challenges. It's a stack, which is complex. Infrastructure is difficult to manage, and they lose time. So we build Wise. So Wise is a tokenization as a service solution using NFTs. Why NFTs? Right? Because you cannot push data into a blockchain transaction. That is where we take blockchain, we put the data into the NFTs, and that is what starts to make sense for businesses who need data assurance first. They need availability 24/7, and they need a backend CRM or ERP integration. When we solve these things, many more use cases become live. The way we actually do it is by allowing predefined templates. So you can issue soul-bound tokens for academic certificates. You can do NFT ticketing, POAPs. You can do awards, membership tokens, even work credentials for gig economy, right? And all of that by just selecting your options on the dashboard, and you don't have to worry about anything else. We have taken away all those challenges. Using this, you can launch your token in about 60 seconds flat. That's our promise to you. Where we are doing this, where we are using this, education, we have already live projects working on this. Events, conferences, and ticketing. There is a Filecoin Bangalore event happening today where we have issued over 2,000 tickets, and about 600 people already checked in today using our workflows. That's actually happening today, and that is an example of how we further simplified. You don't have to worry about wallets, addresses. You scan a QR code, and you can get into an event. And the promise we are saying is NFT inside. If you remember it, this goes back to the fact that when microprocessors, computer chips came, Intel inside was the slogan. People remembered, they believed, they had the trust, and that is why we want to bring the trust back to blockchain and Web3. Work credentials, not for people like you and me, but for the gig economy. They are financially marginalized because they cannot prove their work history, and this is a very good tool to help them do that. These are some examples. And finally, some of our new projects are in healthcare, personalization of medicine, and real estate tokenization in India, which is going to be one of the biggest differentiators. And this is where Algorand, out of the box, provides tokenization and fractionalization of NFTs, right? So this is how I'll skip that. End of the day, we want to get to this where you have a NFT-based profile of the user. These are some of our achievements. And actually, we want to introduce the form factor. You use credit cards for making financial transactions. We will allow using cards to exchange data, And with that data, you can have a DeFi protocol sitting in back where everyone in the ecosystem gets rewarded on who's asked for the data, who's created the data, and who owns the data.
Thank you very much, Saurav. I'm going to have to stop you there, and I'll start where we left off in terms of questions. Thank you.
So what are you looking for as far as support, specifically from an accelerator, and taking into account that usually, accelerators last for like 3 months. So what can you accomplish in 3 months as far as traction?
Right. So that's a great question, because as a startup, for people and businesses to believe in what we can do and what Web3 can do, it's a lot of challenges. But if we get an accelerator, we get Algorand, it gives them the trust factor that we can actually deliver this, and Web3 is something which businesses can trust. With all the noise that has happened in crypto, we get a lot of challenges, and our sales cycles are much more difficult. To convince a user to come onto this, it takes much longer. If we have an accelerator, we say, yes, this is a startup, they're working good, they're doing a good job, these are the use cases you can do, we can go and deliver much faster. Plus, it will increase our scope to wider customer base and actually help us get more use cases. So those are some of the things which will actually help us.
Just a quick question. You skipped the slide on the team. Can you spend 5 seconds on that?
Right, I can go back. I think. Yes. So as part of the team, I am leading the technology front. 3 years back, I didn't know how to code. Throughout COVID, I learned, I sat, I built. Along with that, I have a small development team of my own. And we have a legal advisor because we work with a lot of companies. In addition, we have various mentors who help us build these bridges within India, within the government regulation as well.
Yeah, I'm going to help you save a few seconds. You started with minting NFT and went to the cards. What was the story behind that?
Right. So NFTs will help you generate the data. You will own the data, but you will need a form factor to exchange and transmit the data. Today, you'll have to go to your computer. You'll have to do something. In future, today, like you can scan a QR code and make a payment. In future, in about 6 months of time, that's what we want to do. You can scan a QR code at a bank, and you can say, I'm applying to a loan application. This is my salary for the last 6 months. This is my home address. This is my everything. Tick, tick, tick. And you exchange the data by scanning a QR code, which is consent-based, using smart contracts on the layer.
Hi, great presentation. What is, or do you know your cost of customer acquisition? And then how does that tie into your revenue model?
Right, so today, our cost of customer acquisition is way through the roof because we have to spend a lot of time in kind of getting there. We have early customers, so I cannot put an exact dollar number, but somewhere in the range of $100 plus each. In terms of revenue model, we are billing them on a per transaction basis, so it's a SaaS model, which helps them get on board faster because first thing is they don't want to buy and then you put a cost. So early use cases that we are building, we're kind of giving them grants, right? So they come on board faster, and that is where we say that we're getting grants from the blockchain companies as well, which we are helping you, promote and build the solutions.
Okay, so I'm going to have to stop you there. Thank you very much, Saurav, and Wise.
Thank you, Saurav. The guys are setting up. Are any of the DevRels in the room? Can you all just stand up for me, please? Just stand up, because these there are more, Ryan's down the back, and there's a whole other team. There's about 7 or 8 more of them. They are the DevRels who were reviewing these projects throughout the year as well, and they're a massive help to me and Dave. So just thanks a million. Okay, so. So next up, we have AlgoPay. We have Abe and Sagar. AlgoPay is a simplified crypto payments platform, and they were an Easy A hack winner. So they came from one of our hacks throughout the year as well. So are you guys set up? Are you ready to go? Perfect.
There you go.
Great. Please give them a warm welcome.
Hello, everybody. My name's Abhay. He's Sagar, and we have one more team member called Teja. So we are a grad student from Northeastern University. Right. So recently, we came up with an idea, like we were finding it so hard to use our crypto money in the real world. Like, what if I want to purchase a product on Amazon? What if I want to purchase a product on Walmart using crypto? Is that possible? Yeah, it is. So we built a prototype around it. So let's see the real demo of it. So let's go. So this is the Amazon website. So we'll use Algorand's crypto to actually buy a product on Amazon. So as soon as you add an item to the cart and you add your shipping address, our Chrome extension that we have built immediately pops up
and asks you to connect your wallet. Which wallet? It's the Para wallet from your mobile app. So let's connect. So in order to connect, we use the QR score model. So a person can use his QR mobile app to actually scan it. Once it's authenticated, you have access to pay using crypto. So let's make a payment. There you go. It's under processing, and he actually passed it through his mobile. So once it's processed, the Amazon gift card is activated, and the actual product can be bought using crypto. So how did we achieve this? Pretty simple. So this is actually a live order, and it's actually been delivered to India. So it's actually on the main network that we are doing it. So there we go. An order is processed, and it's actually placed. So our main motto of building this is, guys, we don't have to make everything decentralized. There are more powerful websites that are already built. Instead, we can make sure that we build small tools or helper functions that can immediately make the whole product decentralized. Well, that's what we came up with. So this is a simple Chrome extension that we have that the user can install, and they just have to install the Para wallet on the app in order to function this. Right. So what's our future scope? Right. We have built the prototype. What's our future goals? So our expansion is not just through Amazon. We want to enter the bigger markets like Walmart and other e-commerce systems, and we can also enter Uber and different architecture platforms. So it's the main functionality is to make sure that making crypto payments is as easy as possible. So here we go. This is AlgoPay.
Time to spare. Seeing is believing, ladies and gentlemen. I'll start up this end, please. Thank you. Start down the bottom. Any takers?
What's your go-to-market strategy?
Right. Our main growth marketing strategy would be to build a community for this, mainly and actually to grow this out. So currently, we are planning to make sure this Chrome extension is free for the users so that they can make sure that crypto is easily available and they can easily sell it and then they can easily use it. Right? Once we actually grow it to a phase where we have accomplished tying up with different markets like Walmart and Target, and once we have different gift cards available from all the lenders, we are going to actually charge a processing fee, which makes sure there is revenue generated out of this. Well, that is our main growth marketing strategy right now.
And how do you convert the algos into dollars for the payment?
Right.
What's working in the background for that?
Currently, what we are doing is once the algo is processed from a user to us, we'll be using it for trading. We'll not be actually directly contacting Amazon with this. Instead, we'll be buying the products to Amazon through their Amazon gift card APIs. So we use their gift card APIs in actually to buy the product. So user doesn't know that we actually buy it using crypto. It's we who actually do it from the backend.
If I have a credit card and I use Amazon already to make purchases, why would I use this Chrome extension?
Right. So the main goal of actually doing this is to make sure crypto payments are as easy as possible. Like currently in a phase where crypto is so much booming, we all have so much of resources in crypto, but we are not able to use it properly. Right. That's our main motto.
Great presentation, by the way. You mentioned the gift card API. I actually had a question, but you answered it. But for other platforms or e-commerce sites that do not have the resources to build APIs like that, how do you go around it?
Right. So the most of the resources that we checked out, like popular websites, they do have gift card vouchers readily available. If the resources aren't available, we have several third-party APIs that we can use to actually generate the gift cards. So through that, we can actually contact the companies to give us gift cards, and then we can actually make the payment.
Yeah, the question is, beyond payments, by the way, that was great. But beyond payments, what's the vision? Or do you think that payments is just big enough and you don't need to go beyond it?
Sorry, could you repeat that?
You're going to take over the payment space, let's say. Do you think that's big enough? Or your plans are eventually to build on top of it?
Right. So currently, the future scope would be to make sure like we expand this to a state where it's pretty stable among a lot of users. Why we want to scale it to a lot of users. But we are thinking of some additional features that we could do on-chain. It's on the future scope for now.
Thank you very much. AlgoPay, ladies and gentlemen.
Thanks, you guys.
Thank you. Thanks, Abe and Sagar. Thanks. Okay, so we're halfway through. I want to give a warm welcome to Kinemo. Morgan Wild will be pitching for this, and Kinemo is the decentralized developer wallet. So please welcome.
Hey everyone. So my name is Morgan Wild, and I'm the founder of Kinemo, the decentralized developer wallet. And you might ask, why build another wallet? Well, there's two reasons. The technical reason is that currently we still have a lot of problems when it comes to mobile wallets on Algorand. And primarily because Wallet Connect and WebSockets introduce issues to end users that, for example, can't connect to a decentralized app or have their transactions not submitted and they can't show up. But the bigger reason is that the current crop of wallet apps are absorbing the decentralized app experience that are provided by dApps and plugging it all into their walled garden apps. And I want to change that, and I'm going to do that with Kinemo. So how? Well, first up, I'm going to limit the scope, right? So Kinemo has 3 design principles from the user's perspective. One is we're going to keep private keys private. We're going to sign transactions, and I'm going to do those 2 things securely, fast, and accessibly, all right? Let's remind ourselves that the killer app for a wallet is processing transactions. So from a user's perspective, Kinemo will provide and innovate with an accessible way for reading what's inside of a transaction. It will provide an easy way to ask for help confirming what's the contents of a transaction if it's as advertised. And this will add a social layer that's totally lacking from the current crop of apps that are totally isolated from a social perspective. And then finally, it'll provide a seamless transition from and back to the dApp that originated that transaction. And I'm going to focus on the developers as a target demographic number 1. That's good for the ecosystem because a good developer experience yields a good user experience. So these are the design principles from the developer's perspective. Number 1, the decentralized web app will own the user experience, not the wallet. All right? All the heavy lifting will be shifted over to the mobile app, so like translating, packing, hashing, so forth. That will enable a lightweight web client SDK, which Web 2 devs will gladly import. We're not talking about megs here. We're talking about a couple hundred K in terms of the package size. And this will also be allowed by the accessible wallet to web app communication protocol. Now, in terms of onboarding, there's going to be a native iOS app, a JavaScript SDK, and a browser-based game that's going to be a reference project, kind of like an NBA Top Shot. For business model, there's going to be a fee that's extracted from users that are paying for someone to confirm their transaction is valid from the community. So who am I? My name is Morgan. I've been working on Algorand since November of last year. I've been a part of Decentology, worked on developer content and bootcamps for Flow. Before crypto, I led a team at K-Health, which is a healthcare startup. And most importantly, I've been a developer mentor since 2018. And yeah, thank you so much for your attention.
Thank you very much. Any questions for starters?
So you build it. Is there anybody else on the team, or what are your needs as far as resources?
It's just me. I'm a full stack engineer. I've made progress on JavaScript SDK, and I've made progress on the native app side. I need runway, and eventually, once I've proven out the product more, I need extra devs to help.
What does the next 3 to 5 months look like for your roadmap?
With enough runway, the next 3 to 5 months will yield an iOS app for the wallet side, a JavaScript SDK to go along with it, and maybe an inkling, a start of the browser-based game.
Okay, thank you.
Thank you.
Short and sweet. Thank you very much.
Okay, hi. So everyone that's just joined, welcome to the Developer Greenhouse Build Pitch Competition at Decipher 2022. This is where we're finding our next wave of builders on Algorand. Next up is Blockchain Verified. It's Sahil Malik, and it's Instant Certification Verification. Welcome.
Hello, everyone. It's exciting to be here. So as you can see on the screen right now, we have developed a product called Blockchain Verified. In a developing country like India, it's a huge challenge when it comes to credential verification. Despite the fact that the government has taken a lot of initiative in this direction, we have Digital India. Still, students who are going abroad cannot present their degrees. They have to go through a different route, which is called transcript. Because they do not trust the degrees coming from the student, the university can contact the university. When it comes to the trade finance, the bank guarantee issued in India is done in a digital format in such a way that the verification takes around 3 months and sometimes even 3 weeks. This is the reason why a $2 billion scam recently happened in trade finance, whereas a diamond merchant pulled off a scam worth $2 billion. At the same time, when an employee is joining a new company, the verification of his previous company cannot be done because all the details are coming from the employee and he can easily manipulate that data. So we have built a tamper-proof, time-stamped, digitally signed document which can be verified under 30 seconds. And this is only possible on blockchain. It's low cost. We are only paying for the transaction. Instant verification hardly takes 30 seconds. It's tamper-proof because we are using hashes, and it's privacy-focused because we are not taking any data. We are simply pushing the hashes from which you cannot get the data. Government has taken a lot of initiative in this direction in India, but they are not able to really solve this problem. As you can see on the street, there are a lot of startups building on Polygon as well who have issued caste certificates. We are building something bigger, much bigger on Algorand. Initiatives have been taken by universities. I have graduated from Pune University. They have included Algorand as part of their curriculum now because they know what kind of a great technology Algorand is now. They have conducted a lot of workshops in this direction. So why we need blockchain? I have already covered that part. Apart from that, blockchain is built on hashes and digital signature. Both of them are legally recognized in Indian court of law. So if we are building any solution on that, we can make use of that part as well. Why Algorand? The credibility. The Algorand is working with a lot of educational institutions already. So if we are building a product for students, they are going to accept it. Feasibility, because we are paying only for a transaction fee, we are getting a storage of 1 KB for life. We are bringing the next generation to Algorand because the student has to create a wallet on which he will be receiving his degree. In future, he will be using the same wallet to get the NFTs which he can showcase on Instagram. And in future, probably he'll use the financial products of Algorand because he has the trust as his certificates are there. Market size is very big. We have more than 1.5 million engineers graduating in India. Then there are other disciplines and other sectors as well. So if we are only targeting engineers, we can easily have a market size of around $200 million. We want to go live in the next 5 months. We have already conducted our MVP at this stage. This is the product that we have built. The verification can be done on this page. We can scan a QR code or upload the file.
Okay,
we are a DPIT recognized startup, and the Startup India has recognized our company.
Thank you very much. Okay, questions, please. Here we go.
Have you spoken to any potential customers about this yet?
Yes. So initially, we are targeting the colleges, the private colleges. We already have 5 colleges where we have conducted the minimum viable product testing. And we are very much confident that the next graduating year, in June, we will be able to make those degrees on Algorand.
What's your revenue model then for these colleges?
That's a great question. So we are charging the student $2. Out of those $2, we are only paying for the transaction fee. That is hardly some pennies. So we are getting a 1 KB storage out of that, right? So 90% of this $2 is actually our profit. And the revenue is that $2 coming from the student.
So your MVP is in about 5 months. So what do you expect to achieve from an accelerator program?
That's a great question. So since we are building on Algorand, and Algorand is already associated with a lot of educational institutions. They have Center of Excellence. Then there are other initiatives as well. So through Accelerator program, we want to engage with these educational institutions, and we want to showcase this product to them so that the degrees coming out of India can be accepted by these big universities. Once that will happen in India, we can easily able to sell to a lot of institutions and universities.
So the whole blockchain thing seems to probably is going to work, but that's all within the digital space. But what about the analog to the digital bridge? How are you solving the security of that?
Yeah, so that's a great question. So the universities are already having data in a digitalized format, but when they issue it to the student, they make it on a hard copy. They print it on a hard copy. They store it either on Excel sheet or on a database. We are saying if you're storing the data, but you're not giving it in a digitalized format, give us the data, we'll issue, or we are only calculating the hash and pushing it on Algorand. We are not taking the data, only pushing the hash for verification, and the data is again given back to the university and the student. So we are not touching the data of the student in any way. But the hashes, you can verify it very quickly.
Well, a quick one. This is a classic and pretty much expected application of the blockchain. What about the competitive landscape, and why are you better than other solutions that are out there?
I did not get the question.
The competitive, why are you better than your competitors?
That's a great question. I've been working in blockchain for 5 years now. I have done big projects like peer-to-peer energy trading. What I have realized is in a developing country, Web 2.5 is something that can be adopted today, not Web 3.2. So this is a product where the Web 2.5 will happen, the transition will happen. In future, we will move on to NFTs, we will move on to self-sovereign identities. But by this Web 2.5, go profitable next year itself.
Very good. Thank you very much.
Thank you, everyone.
Okay, we are on pitch number 8. This is Jordan Kaufman from Block Reward. So this project was also a winner in our Greenhouse Hack 2 that just finished a couple of weeks ago. Block Reward is decentralized reward system. So please give a warm welcome to Jordan.
Hello, everybody. I am Jordan Kaufman. I am the founder of Block Reward. So what is Block Reward? It is a membership and loyalty system for online and brick-and-mortar retailers. You earn a token on purchases, Block Reward token, or BRT, and that is also then used on our platform to redeem discounts offered by businesses in our ecosystem. So the blockchain application for Block Reward. We are using NFTs as membership. They're going to be upgradable NFTs using ARC19. Block Reward token is earned on purchases. Think of it strictly as a reward point. Having it on the blockchain allows for easy accounting for both the end user and the businesses that are in our ecosystem. We created already a custodial wallet system. This allows for easy onboarding for the average consumer. I currently have 3 retail stores and about 7,000 customers that I'm trying to get on Algorand's blockchain. So the development roadmap, about a year ago, I minted my first NFT membership for my shops. This kind of allowed me to test to see the onboarding process for the average consumer. One of the biggest problems I ran into is they didn't want to download a Wallet. They wanted to log in with a phone number or email. So then I started selling my membership on an open marketplace. This allowed me to test my concept through Discord. If you had my membership NFT, special discounts were unlocked in the actual Discord, so you could go use it on my e-commerce site. September 2022, we started the actual development of the platform. November 2022, we were lucky enough to win the Gitcoin Hackathon 2 for the customer loyalty app. In my go-to-market plan, like I said, I have 3 retail stores. As soon as I get Stripe Pay integration, my customers will be able to upgrade and buy membership with their credit cards. As soon as that goes, we're going to be beta testing in my stores as well. So the market size, global retail sales are massive, over $21 trillion. Both e-commerce and brick-and-mortar stores have seen significant increase over the past year. My main target is local businesses. I want to build out a business ecosystem where all the end consumers can use the same token to redeem discounts offered by businesses in the ecosystem. So, business model. First, we're going to build the actual ecosystem. We're going to allow 10 to 15 businesses join free, and then we're going to charge a small joiner fee anywhere from $200 to $500. Businesses in our ecosystem are going to be selling NFTs. We're going to take a 20% cut of that. That is going to go buy Algorand on-chain so we can facilitate the transaction fees so the transaction fee does not fall in the end consumer. Another thing we're going to do is run ads for businesses like featured membership, things like that, anywhere from $300 to $600 a month. So our team, me, Jordan, the first person I had to find was a technical founder, Padram, and we have a full-time software engineer working for us as well. So if I'm ended up getting funding, I'll be able to integrate with Square and build a phone app as well. Thank you so much.
Perfect timing. Bang on 3 minutes. All right, thank you.
So your BRT token, is that something which anybody can buy as a utility token?
No, you can only earn it on purchases. There will be other ways in the future to earn it as well.
Okay, so it's
strictly a reward point.
Okay, so it's closed within the ecosystem. Nobody can speculate on that.
Correct, yes.
Okay, then why do you need blockchain technologies? Isn't it just a simple loyalty, like a credit
Absolutely.
solution between
So having it on blockchain allows, like I mentioned, easy accounting for both the business to see exactly what rewards are being redeemed. And since blockchain is not able to be changed, it's just the easiest and most efficient way that I found to have a reward system.
But don't businesses get to see that from their loyalty programs already without the blockchain?
Yes, absolutely. But I do know a few businesses that I have talked to have had people make fake accounts. They have figured out a way to game it, essentially. They can make multiple accounts. And of course that could happen here, but the main thing was having the blockchain component was the easiest ability for accounting for the businesses to see exactly what's going on. Of course that can be done in a Web 2. I just figured that blockchain was going to be easily acceptable in that way. And the main focus of Block Reward is to get the average consumer using blockchain without them really knowing it. So of course the accounting perspective is a Web 2 thing, but the main thing is to get the technology in the hands of the average consumer.
Okay, so there's probably a learning curve to this. I'm just wondering if the advantage of blockchain in this, the marginal advantage is net positive versus the disadvantage of having to have a more complex process from a user perspective.
So it's not a complex onboarding process for the user at all. They create an account with a phone number or email. There's a custodial wallet waiting for the end user. So there's no downloading Coinbase, buying Algorand, then going to Parawallet, then going to our platform. We have an all-in-one platform for the average consumer to get on blockchain.
How are you going to scale your customer acquisition?
So to start out, I am going to test it out in my stores. I have talked to a few other local businesses that are very interested to join the ecosystem. I am connected to 100 other retail stores through my franchise. I have already talked to the CEO. He is very interested to get this going once I have proven it in my stores.
Very good. Thank you very much, Jordan.
Thank you.
Okay. So pitch number 9 is AlgoHelper. It's Artem and Valentine. They are also a Greenhouse Hack 2 winner, which is great. And AlgoHelper is the platform for developers who are building in the Algorand ecosystem. So please give them a warm welcome.
Good afternoon, everyone. Today I want to introduce you AlgoHelper, a non-profit platform for developers in Algorand ecosystem. The main topic of our project is open source and overcoming its daily problems. The first problem is the lack of a sufficient amount of quality open source code, and it's usually very hard to find the original code of smart contracts. The next problem is there is no way to see if the on-chain code matches the off-chain code. And as a result, these problems complicates the lives of developers, especially of new developers. And our solutions are, first of all, creation of a database of high quality proven open source code and a media platform about it. The second solution is to implement our open source verifier to explorers, so people will be able to easily compare on-chain code with off-chain code. And also, they will easily find the original code of smart contracts. The third solution is the expansion of open source code base with our own developments. Like, for example, we have Algorand blockchain approved VRF randomizer. You can check it at this link. And this is how our open source verifier looks like. It supports versioning by different commit hashes. And you can also check it with this link. So what's the problems with code on explorers? Here, for example, you can see only decompiled bytecode, which has more than 15 hundreds of lines. But original code can be in Python or Rich, and these languages are much more compact. So our solution to this problem is to implement a special widget to explorers, so people will be able to easily find the original code of on-chain apps and to compare it to on-chain code. So our vision, to summarize, is that the development of open source culture will increase the amount of new developers on Algorand, and combined with open source, our own developments, will lead to more high quality projects and a boost of entire Algorand ecosystem. Before we can go to the market, we need some partnerships, marketing support, and help of some experienced mentors. This is our team, and we strongly believe that development of open source will make Algorand and world better. That's all. Thanks.
Fantastic. Thank you very much. Questions from our judges?
What's your predicted revenue model for this?
Sorry?
How are you going to make money?
Actually, this is an ecosystem project, and we aren't going to make money with this one, but we are going to provide exposure to ecosystem projects like once a week. The best verified open source code will be announced on Twitter to help boost the overall ecosystem and attract more money, but in a very indirect fashion.
So, I mean, this is quite necessary and it's a really nice widget, but what's coming up in the next 6 to 9 months? What do you guys want to work on?
So your question is just like what's going to happen in next 2 months? 6 to 9 months. 6 months. Oh, it's a big time frame. I guess we are going, first of all, we are going to pass an ARC standard on handling the verification data, how we store it, and how should explorers pull it, first of all. Then, like the next month, we need to build partnerships with explorers themselves and wallets, and then we will have to do some marketing, just getting people to know how it's an alternative way to see if this smart contract is trustworthy. You can see just the stars this code has there. So, I'm sorry.
Fantastic. Thank you very much, gentlemen. And I could just ask as a courtesy, please, while the pitches are ongoing, we only have 2 more left. It is rapid fire. Just a little bit of hush down the back. There's networking areas outside. We understand that's an important part of it as well. We only got 2 more to get through, please. If we could just keep a little bit quiet down the back. Thank you. Joe.
Okay, so pitch number 10 is In Fiction by Kalga Labs. This is Abishar. This project came through the Algo Barrett endeavors again, so well done. In Fiction is a platform for filmmakers and content writers. Welcome.
Hi, good afternoon, everyone. I'm Abhisar Srivastav, co-founder and CEO at Kalga Labs. Let me take you into the world of movies through In Fiction, a platform for filmmakers and content writers to collaborate in a smarter way. Bollywood, the world's largest film industry, is currently facing massive headwinds. Their success rate has dropped to less than 25%. There's an extreme disconnect between the content and the fast-changing audience palette. In fact, close to 100,000 screenplays remain unread every year. The industry is heavily centralized and is begging for diverse content. To tackle all these pain points, In Fiction is building the perfect solution, an app that is secure and simple to use and connects screenwriters, register on our platform, upload their work in the form of NFTs at the click of a button, get access to a 2-tier feedback and evaluation service, eventually leading to our native marketplace showcasing all the top-rated screenplay NFTs. Producers can subscribe to our platform and will be able to search and access both the writers, and the screenplay database. Finally, through the marketplace, they can buy and sell the NFTs they like. Our product prototype, shown on the screen here, is simple and convenient. Upload, get professional feedback, engage in the marketplace. It's no secret India produces the maximum number of movies in a year. The size of the industry is $7 billion, with the writing segment amounting to $350 million. At InFiction, we are projecting $6.5 million in the first 3 years of business. Our revenue model largely consists of subscription fees from the producers, various paid services for the writers, and finally, a 10% commission on all NFT sales and writer recruitments through the platform. My co-founder Ridhiman and I have been friends for 19 years now. Both of us are massively interested in the business of filmmaking, and given our backgrounds, we think we have the ideal combination for such a venture. Anjum Rajabali, our industry advisor, is a veteran, multiple award-winning screenwriter and a script advisor at international film festivals like Sundance. The evaluation process is being built under his mentorship, giving us huge credibility in this space. We act as a systematic matchmaker, solving a manpower-intensive problem. Registering screenplays on the blockchain is better for copyright issues. We give industry access to diverse talents from all across the country. And finally, with an expectation of 500,000 transactions in the first phase of our business, getting on board the greenest blockchain, Algorand, is an icing on the cake. At InFiction, we truly believe content is king. Thank you.
Fantastic. Thank you very much. We have a question.
My fiance is in the film industry. She's a producer. One of her biggest concerns is the protection of IP and screenplays that come through the industry. Screenwriters are typically very protective of their works, and so how does your platform guarantee that IP will be protected, or let's say stories won't get read, copied, and then resold?
So the current practice right now in India is a one-on-one meeting that you have with the producer, and the writer and the producer, and they sign NDAs, which are difficult to enforce given the legal structure in India. It takes a lot of time to enforce any of these NDAs if they are violated. But having an established company in the middle on a platform basis gives more protection to the writer, and registering screenplays on the blockchain helps you prove your copyright ownership, and that helps the cause going forward. Violating it on a one-on-one basis becomes more easy compared to having it on a platform basis.
What if I'm a producer, I find a screenplay, I like 75% of it, but I want to change 25%? How do you handle that situation?
That would be the case with mostly all the screenplays that the producers like. Mostly whenever they like a screenplay, they take it into development, and that development phase lasts typically for 3 months. So we have the option of contacting the writer. All of the writers who register on our platform will be issued a digital ID card in the form of an NFT. And as soon as someone buys an NFT of a particular screenplay, they will get an NFT card of the writer as well, who they can contact. So whatever remuneration that the writer is getting for the development of the screenplay into the final product, we charge a 10% commission on that, and of course on the screenplay sale that has happened.
How much have been built so far, and what's the validation on your product?
Yeah, so right now, we incorporated the company in June, and since in the beginning phase, the business is pretty much B2B, we have spent the last 4 months establishing connections within the industry. We have met with top production houses and streaming services like Netflix and Eros and MX Player in India. We have run the product by them. We have gone through multiple iterations. We wanted to open it up to the audience initially, but after taking their feedback, we have restricted the product to screenwriters and producers. So now, since we are happy with the product and the feedback that we have got, we are taking into the development stage.
InFiction, ladies and gentlemen, thank you.
Thank you.
Thank you. I'm gonna give them. Okay, so we are on our final pitch of the day, and can you just give a big round of applause to all the pitchers so far? They've just done a lot of work. We had the semi-final yesterday. We got down to the final 11 today, so there's been a lot of work that got into it. Our final pitcher is JP Miller. He's a director of developer experience at Reach, so he's no stranger to us. We're delighted to have him here today pitching, and his project is Proof of Mushroom, and it's a decentralized carbon exchange. So please give JP a really warm welcome.
Thank you for the introduction. I'd like to introduce you to POM. So, consumers are giving a number of mixed and conflicted messages when it comes to how to reduce their carbon footprint. And then there are questions about who are actually the largest emitters of carbon dioxide. There's questions about large corporations, big agriculture, billionaires, and these mixed messages leave consumers feeling disinformed, disillusioned, and frustrated. POM seeks to cut through the noise with a decentralized carbon exchange marketplace and an IoT device that incentivizes consumers to participate in regenerative economies. So POM is discovering the true cost of carbon. In centralized carbon exchange marketplaces, we found that a ton of carbon dioxide will vary between $100 and $250, whereas it requires to plant 50 trees to offset 1 ton of carbon a year, which costs $25,000. And so there's an extreme arbitrage between what the markets say a ton of carbon is worth and what the economics actually say a ton of carbon costs to offset. So we introduced the POM box, which uses a special fungus that's found in Ecuador that actually biodegrades plastic. And as plastic is biodegraded, we incentivize consumers by rewarding them with carbon tokens. This begins to create a virtuous cycle as plastic is biodegraded. Consumers are rewarded with carbon tokens. This begins to raise the value of the carbon token on the decentralized exchange, eventually getting the interest of industry, causing a virtuous cycle to help us find the true cost of carbon. POM belongs on Algorand because we have a common vision of a green future. A green company like POM belongs on a green blockchain technology. This is my wonderful team. Sally Koo is our researcher, Angela Chen, our backend engineer, and Rosa Lee, our full stack developer. POM, together, we are discovering the true cost of carbon through regeneration and restoration.
Fantastic. Thank you, JP. From our judges, hands up. Yep.
Can you further elaborate exactly what you have on screen? So how do I discover the true cost of carbon by having this device in my house?
I'm sorry, there's a little bit of reverb and I'm having trouble catching the words.
How does it work, right? So I had this device in my house. How does that help me discover the true cost of carbon?
Yeah, so like you as the consumer, you would put your plastic in this box and this microspora begins to biodegrade. It actually turns into organic material. It's an IoT device, so it measures the weight difference, which rewards you with the carbon. And you do what you want with the spores. You can eat it or you can put it in the garden. How it helps us find the true cost of carbon is that as consumers collect the tokens, right, it would be a tokenomics that we haven't quite figured out yet, but we would implement tokenomics. And as more of these tokens are created and held, that would increase the value in the exchange. Thank you.
What's the barrier to entry for an average customer getting into this? How much would a box cost?
Yeah, so we plan on selling the box for as cheap as possible, around 29 to 39 USD. Be a barrier entry. We could also imagine a market plan where the box is given away for free or at a loss, and then we're taking a small cut from the tokens that are generated.
Awesome, thank you.
And that is the end of our 11 rapid fire pitches. Turned it all the way up to 11. Thank you very much, JP.
Okay, so that is the end of the Build Developer Greenhouse pitch final at Decipher 2022. Really just, I know I keep on saying there was a lot of work that the developers and the projects put in over the year, so please give them another round of applause and woos, please. I wanted to give a big thanks to the judges, Lorenzo from Rocker. We have Michael Hoffweller from Accelerator, and we have Asim from Eternix Capital as well. So a couple of those accelerators, Eterna just announced their cohort yesterday. Acceler are going to be doing your closing in January, right? So any startups, take note, look at it. They're open for applications. Okay, so what's going to happen now? The judges are going to tot up. We are going to be announcing who the winner and the runners-up later on today. So that'll be announced on the main stage. Okay, so great. So listen, thank you so much, everyone. Thanks a million.
Joanna Moran, thank you so much. Congratulations to Joanna and David and everybody who participated in helping organize this. Thank you guys so much. To the developers out there who are thinking, hey, that could be me. I'm developing on Algorand, or I've got an idea and I want to do this. I want you to know that you can come to the algorand.foundation website, click on developers. In there, we talk all about the greenhouse hack, and we talk all about this series. You can get connected with not only learning materials, but also the accelerator programs and so on. Come and join us. All right, next up, I'm really excited to welcome to the stage one of my colleagues at Algorand Inc., the head of cryptography, Chris Pikert. Now, he is going to be talking to us about the third pillar that Paul Riegel started the day off talking about, right? So Chris is going to be talking to us about interoperability, and he's going to be talking to us about the cryptography part of what that looks like for state proofs. We've got the title slide going to come up and tell us all about it. Right, we're going to get there. There you are. All right, right. So with that, Chris, welcome to the Algorand Tech Talk stage.
Thank you. Thanks, Ryan, for the introduction. Thank you, everybody, for coming. So I'm Chris Pikert. I'm the head of cryptography research at Algorand Inc. And I'm glad to be telling you today about how we are looking at the enduring value of Algorand via two intertwined techniques, state proofs and post-quantum cryptography. So when we think about Algorand's long-term value, there are a lot of interesting questions, a lot of important problems to solve. But two of the things that we've really been focusing on, and Paul talked about this in the morning, and we've been thinking about for a long time, are two key goals. One of which is interoperability and exchange between the Algorand network and others out in the world. And the second is what's called security against future quantum computers, should they emerge, also known as post-quantum security. And both of these are really integral for the long-term value and integrity of Algorand network and blockchain. And in this talk, I'll tell you about one new tool that we have created that addresses both of these goals at once. And it's known as Algorand State Proofs. So let me talk a little bit more about these two goals and give the motivation for where we're going today. First, interoperability. So Algorand nodes running the layer 1 protocol, this great Algorand protocol, are very quickly and frequently and very cheaply reaching consensus on what's happening in the network. So what are the accounts? What are the balances? What are the transactions that are happening? What are the results of smart contracts? Everything that's going on every few seconds. The Algorand protocol, pure proof of stake, allows the whole network to agree and move forward and what's happening on the network. So that's really great, and for everybody who's running the layer 1 protocol, running an Algorand node, no secret to any of these benefits. But what about the rest of the world? The ones who aren't enlightened enough to be running Algorand nodes, or maybe can't because of certain constraints. What about talking to other projects outside the Algorand network? So let me give you a few examples of those which we might want to interoperate with. So one is just new nodes on the Algorand network. At present, if you want to start up a new node, you may need to verify the entire chain, the entire history of the chain, starting from the Genesis block. And this is not terribly expensive, but it may take a little while. You just have to run up and retrieve the entire history of the blockchain and verify it over maybe a few hours or a day or so. So we'd like to do better than that and allow new nodes to come online more quickly. Another example would be light clients. So nodes which maybe are coming offline and then back online, or don't have a lot of computational power, don't have a lot of bandwidth. They can't track every update that's happening to the chain, but they may be able to show up here and there and get updates of what's been happening. So they can't afford to run the full Algorand protocol for whatever reason. And then a third, even more extreme example would be other blockchains, like, for example, Ethereum. Ethereum, you can run smart contracts on Ethereum, but those contracts are too expensive to run a full Algorand node on. So you can't, there's just way too much computational cost, gas costs way too much to run a full Algorand node on Ethereum. That's just not going to fly at all. So in terms of constraints, these smart contracts are very highly constrained on other blockchains. So these are the kinds of examples of things we'd like to be able to operate with, even though they're not able to run the full Algorand protocol. And that's one of the goals of the topic for today, to allow these to securely interact and transact with Algorand nodes. The second goal, as I mentioned, is something called post-quantum security. And the story here begins in 1994 when Peter Shor, this mathematician, published this paper entitled Polynomial Time Algorithms for Prime Factorization and Discrete Logarithms on a Quantum Computer. Okay, so that's a big mouthful. What does that mean? Well, in short, it means that a large-scale quantum computer, if it were ever built, would be able to totally break all of the widely used public key cryptography that we use today and have used for decades. All right, now that means all the cryptography, all the signature schemes that are used on blockchains, all of the VRFs, all of the zero-knowledge proofs, basically all of those, on and on and on. Basically all of the cryptographic primitives that the security of all blockchains rely on would be up in smoke. Now that requires a quantum computer, a large-scale quantum computer, which are still some distance off. People are putting in a lot of work to build such quantum computers for various reasons, not just breaking cryptography. And there's a ways to go. But when we think about the future, 15, 20 years out, there's a substantial, significant chance that such a quantum computer would be developed in that kind of time frame. And so it's the kind of thing that we have to be thinking about now when we think about the long-term security and integrity of our cryptography. So in recognition of this, the United States National Institute of Standards and Technology began a post-quantum cryptography standardization process in 2016, which has largely been completed, but not entirely. There's still work happening there. And many other agencies and organizations around the world have recognized the importance of this topic and are working toward standardizing post-quantum cryptography and deploying it. And there have been many experiments, real-world, large-scale networks, Google, Cloudflare, and so forth, have all been working on this topic in practice as well. The research on it goes back decades. So to be a little more concrete, what would it mean, the emergence of a quantum computer, a large-scale quantum computer, what would that mean for blockchains and the security or lack thereof of blockchains? So a quantum computer could potentially attack future progress of the chain. So for example, the quantum computer could compute your private keys, anybody's private key, forge transactions, steal money out of your account, steal money out of your wallet. It could do something even more fundamental to break the actual consensus of the protocol itself, causing some kind of fork. Different people in different parts of the world see different progress of the chain. All of this would be really bad news. But this is forward-looking. So you would have to have a quantum computer attacking the future development or future progress of the blockchain. There's another more subtle and somewhat insidious possibility as well, which is an attack on the history of the blockchain. So a quantum computer could potentially create an alternative past, basically, and rewrite history or fork history. So not just starting from what's going on today and into the future, but even looking back 5 years, 10 years, however, to the beginning of the chain even, and create some alternative past, which would then fool potential joiners of the network, those who haven't already seen what has happened. And so this is, when you think about it, even somewhat more worrisome, or at least it's more subtle, right? Forging transactions, that's something we can kind of understand clearly, but the consequences of creating an alternative fork of history are a little harder to grapple with. But I think George Orwell, in his book 1984, put it very nicely: whoever controls the past controls the future. So if you can control the past history of the blockchain, you own it completely. And another work from the mid-1980s also demonstrated the risks of changing the past, right? So if you know what this refers to, you know what I'm talking about. But here Marty has put his existence at risk by going into the past and interfering with the creation of himself, right? And so he's starting to dissolve. All right, so that's what post-quantum cryptography is about. And our goal is to protect today's chain, the chain that's developing and progressing today on Algorand network, from the possibility of future quantum attacks against the chain's integrity. All right, so our tool for addressing both this interoperability and this post-quantum cryptography, or post-quantum security goal, is called state proofs. And just in a slide, here's the sort of high-level idea of what state proofs are and what they do. So a state proof would look something like this. It's a claim that, for example, some large majority of the stake, more than 70%, says that round 187's block header is XYZ. Right? And this is a relatively small proof. It's just a blob of data. And it can be provided to what's known as the state proof verifier. So the state proof verifier is just a piece of code that runs. And when you provide it with a candidate state proof, it will look at it and perform some checks. And it will say, OK, yes, I believe this. This looks good to me. Or no, this is suspicious. I don't believe it, and I'm going to ignore it. Right? So if the state proof looks good, then the verifier can say, yep, now I believe this summary of round 187, or everything that's happened up to round 187. All right, so in a few words, a state proof is some kind of small or small-ish summary of the recent state of the Algorand network, and it is backed by or attested to by a sufficient percentage of the overall stake in the network. What makes it important for our goals is that it's cheaply verifiable outside of Algorand. So you don't need to be running the Algorand protocol. You don't need to do, keep any updates about what's been happening. You just need some tiny amount of trusted data to start with, and then from that point on, you have a route with which you can verify all state proofs that will be generated. And a state proof will not be convincing. No one will be able to create a state proof unless the claimed percentage of the total stake in the network actually attested to the message. Right? So we'll have strong cryptographic guarantees that say the only way to produce such a state proof is for actually this large percentage of the stake represented on the network to have participated in its creation. In addition, state proofs provide post-quantum security, post-quantum integrity, and something called snark-friendly verification, or what I like to call snarky verification. And we'll talk about what that means at the end. But post-quantum security as well. And so what this does is it protects the chain's history from future quantum attacks. All the nodes running the Algorand protocol or not running the protocol, those off the protocol who are checking state proofs, now have a post-quantum security assurance that what they have seen up to that state proof cannot have been manipulated by a future quantum computer. OK, so that's the main properties of state proofs. And let's talk about a couple of the applications that they have, although I think you may have even better ideas about how these can be used. So the first one is as a bridge to other chains, as I mentioned before. So the idea here is that on whatever other chain, let's take Ethereum, for example, there will be a smart contract running, and it'll be running the state-proof verifier, and remembering whatever the latest proven summary of the state, the Algorand state is. And then that contract, because it has had attested the summary of Algorand's latest state, it can then verify Algorand transactions, balances, whatever it's provided about, a claim about this happened on the Algorand chain. It can verify that relative to that verified state. So here's an example. We have the smart contract here running on another chain. It receives the state proof saying that 70% claims that a summary of these rounds, 100 through 199, is XYZ. And here's an update of the trusted data that you need. And then we may have a smart contract running on the chain, which is acting as a bridge. So this smart contract would be provided a claim that, for example, in round 187, Alice paid some bridge account 100 algos intended for Bob over on the other chain, and providing a proof of that claim relative to the state attested to in the previous case here. And so the smart contract would verify this, verify that yes, indeed, that transaction did occur on the Algorand network, on the Algorand chain in this round as claimed. And therefore, I will now, as the bridge, pay Bob some equivalent amount of Ethereum, for example. As time goes on, more things happen on the Algorand network, more rounds are produced, more blocks are produced, and another state proof is produced. That state proof can then be, again, presented to the smart contract, who can update its view or come up to date with what's happened in, let's say, the next 100 rounds, right? So in rounds 200 through 299, we have a summary of what happened, a valid state proof, that indeed that did happen, and the updates that are required. And now at this point, you can then say, okay, here's something that happened in round 250 or 285, and so forth. So this would just be going on the other chain periodically. All right, so that's the kind of bridging application. A second application has more to do with Algorand nodes themselves, or maybe light clients wishing to maybe halfway participate in the Algorand protocol. So we have a way to bring new or returning or lightweight nodes up to date on what's happened in Algorand. So instead of verifying the entire chain from the start, or from whatever your last known good block was, and you've gone offline for a while, and now you've gotten a bunch of new blocks, let's instead skip ahead using a state proof. So you just need to verify one state proof for every, let's say, several hundred rounds, and skipping ahead, basically, instead of verifying every new block that's come along. All right, so this can be done by a light client, and as a bonus, even if you're not a light client, by verifying state proofs, you get a post-quantum security or post-quantum integrity guarantee about the blocks that that the state proof covers. So even if you're not lightweight, it's still useful to verify these state proofs, because now you know that a quantum computer has not interfered with the history that you've been accumulating. Right, so those are two of the applications, but maybe you'll think of more. I think there's a lot of excitement and interest in this. But let's do a little bit of a deeper dive. I won't get too technical, but I'm a scuba diver, so I like to kind of go down to maybe 15 meters and hang out there, maybe dip down to 20, 25 at a moment or two. But let's get a little bit deeper into things. And I'll talk about some of the cryptographic techniques that are used in state proofs and the design and implementation choices that go into them. Oh. So in a little more detail, is this clicker working? All right. So state proofs adhere to Algorand's ethos of keeping things highly decentralized. We don't want to introduce some small number of nodes that you have to trust or anything like that. So this is a highly distributed idea, which keeps in keeping with Algorand's idea of pure proof of stake, providing the highly distributed consensus mechanism. So in particular, what this means is that a supermajority of the total Algorand stake on the network must contribute in order to create a state proof. If a supermajority does not contribute, then it will be infeasible for any attacker, no matter how much power they have, no matter how much quantum computing power they have, it will be infeasible for an attacker to create a valid state proof. So here's an example. All the participants in the Algorand network are contributing to the creation of a state proof. And then an untrusted prover, in this case, it would be like a server that Algorand runs as a community service, but you don't need to trust this prover. This prover would just assemble the contributions that all the participants are making, and then assemble the state proof out of those contributions, and the state proof contains just a small random fraction of those contributions. So here's an example in the upper right. We have all these different participants in the network running the Algorand protocol. They all own different amounts of stake, 100 algos, 200 algos, 50, 40, whatever they own. And when it's time to create a state proof, each of them makes a contribution. And then through some basically cryptographic techniques and magic, there's some random, verifiably random selection of these contributions, which would then go into the ultimate state proof created by the central prover. Right? So, and the contributions are selected proportionally to how much stake each contribution represents. Right? So in this case, the contribution produced by the person with 300 algos is more likely to be selected, but also this one from the person with 100 algos is selected, and maybe even the one with 40 algos is selected, and the others are not actually becoming part of the state proof. Right? So we'll talk about how that gives, still gives good cryptographic confidence in this state proof in a moment. Okay, so once these contributions are created and the verifiably random selection occurs, then the untrusted prover is able to package all of these up and create a state proof. On the other side, the state proof has to be verified. So to verify, what do you need to do? Well, all you need to do is start with a very small piece of trusted data called the participation commitment. So there's a commitment, we'll call it compart, and it basically wraps up in a summary all of the participants' current stakes, and verification keys, so signature verification keys. And this is just a small piece, just a few dozen bytes of information. And from that information, you can then verify the entire contents of a state proof. And then the state proof also comes with a certification of the next updated commitment to the participation. So, as blocks are produced, as transactions occur, people's stakes change, right? Some people buy, some people sell, and so we need an updated view of how much stake each party has, and so each state proof attests to the updated state of the account balances and so forth. All right, so by verifying, you can then kind of keep going one step ahead and verify each state proof as it's produced. Okay, so let's talk a little bit more. We're going to dive down maybe to 20, 25 meters at this point and talk about how state proofs are actually generated and verified. So at a very high level, this is coming from a paper by Silvio Micali and others at Algorand from 2 years ago. And it's called compact certificates. And what we've done is added some extra features to this and instantiated with post-quantum signatures and a tool called vector commitments. So I'll just kind of briefly go through these ideas. Each participant in the network is going to sign the data. So it's going to sign the summary state that it wishes to help create a state proof for. And it's going to create that signature, and then the prover will collect all these signatures. So these signatures are sent over the network to the prover. And then once enough of the total stake has provided signatures in this way, the prover then bundles these up and does something called a vector commitment to them. So basically compresses them down into a very tiny, tiny commitment, a very small piece of data that sort of locks down its claim about all these signatures. So these commitments are produced. No, this one commitment, rather, is produced, which sort of encapsulates all of the signatures that were sent to the prover. And then third, by using cryptographic hash functions, the prover can, in a verifiable way, randomly select just a small fraction of those signatures in proportion to the stake attached to each of these signatures. So signatures coming from high value or high stake accounts were more likely to be selected than those coming from low stake accounts, but every signature has some probability of being randomly selected in a verifiable way. And so the prover just includes these in the state proof and also reveals the corresponding stake and verification key of the user who was selected, or of the account that was selected. And so to verify, the verifier just sort of has to check all of these things. It has to check all the openings of these vector commitments, has to check all the signatures, and then finally has to verify that indeed the prover has revealed and chosen the correct random selection of the participants. And so that's done by the cryptographic hash function, just checking that the hash function matches up with what's been revealed. All right, so that's the 25-meter view of what happens. Let's pop up a little bit and talk about the post-quantum security of this. So it's very important, because we want post-quantum security, it's very important that all the cryptography and state proofs be using post-quantum ingredients. If we used any ingredients which were breakable by quantum computers, then state proofs would not provide us any actual post-quantum security. So from top to bottom, all of the ingredients going into this have to be post-quantum secure. So there are two main ingredients. One that I just mentioned is the vector commitment. Vector commitments can be created and verified using Merkle trees. So this is a very standard technique. And what we've done is instantiated Merkle trees with what's known as the subset sum hash function. This subset sum function goes back several decades, been very heavily studied, and we've used it specifically for its collision resistance properties, which is what's needed for Merkle trees. So if you're interested, you can check out the specification and our code implementation on our GitHub here. Second ingredient is a digital signature scheme. So we need a post-quantum digital signature scheme. And we chose, for this purpose, one of the submissions to the NIST post-quantum cryptography process called Falcon. And Falcon was ultimately chosen by NIST for ultimate standardization. So it was one of the winners of this process. We chose it much earlier, and so NIST did a good job following us, I would say. Yeah. But it's a lovely scheme, really nice signature scheme. What we had to do was modify it very slightly into what we call a deterministic signing mode. Let me just say one word about what that means. Falcon signatures, every Falcon signature includes something called a public salt. And by default, that public salt is chosen at random every time. So every time you sign a message, a random salt is used and included in the signature. But for our ultimate snark friendliness, our needs for snark friendliness, we actually need all the users to use the same public salt across all signatures. And so in that case, what we need is to make the signing process deterministic. There's a deterministic choice of salt that does not vary across different signatures or different signing processes. And then once that salt is chosen, the actual signing process producing the signature is also deterministic. So fortunately, this deterministic mode was very easily and naturally achieved with a simple wrapper around Falcon's existing API. So the implementation that the Falcon team gave was really lovely for this purpose. And you can see all the details with the spec and code again at our GitHub. And you can also see a blog post that John Woods at the Foundation wrote about our choice of Falcon and what some of the history there. And in short, it was the foundation of Falcon was created by many Algorand affiliates, myself included, way back in 2008, and then many additional ideas went into the Falcon submission, but it's a lovely scheme, and NIST thought so as well. All right, let me conclude with some kind of what's next, what we're doing new and even cooler with state proofs. So state proofs are snarky. And what this means is that we can ultra compress them, make state proofs really small. So here's the picture that I've shown you before, where here's a state proof verifier. What we're going to do is compress that picture down even further with what's called a snark proof and a snark verifier. So the motivation here is that state proofs themselves are moderately small, certainly small enough to do a lot of interesting things with, but unfortunately they're still too big to provide to Ethereum smart contracts on a routine basis. Smart contracts are just too much gas to provide lots of data to an Ethereum smart contract. And so we need to squeeze down further and make things even smaller. So the big idea, or maybe the small idea, is to replace the state proof with something even tinier and cheaper to verify called a snark proof. And in particular, what we're going to prove is that we know a valid state proof. All right, so this gets a little bit meta. We start with a real state proof, and then we convert it into a snark proof. The snark proof proves that we knew a valid state proof. Okay, so it's this is cryptographic magic, but it's really cool stuff. And it's a very tiny proof. So the snark proof is very tiny, but it stands in for and is a convincing proof that we knew a valid state proof. All right, and so what that allows us to do is to cheaply verify snark proofs on other chains like Ethereum using a snark verifier in an Ethereum smart contract. All right, so one of the big pieces in the design of state proofs allowing this to occur is our choice of our post-quantum primitives. So not only are the post-quantum primitives giving us post-quantum security, they're also very snark-friendly. Both the deterministic falcon and SumHash verifying these functions is mostly linear and hence quite snark-friendly. And so we're able to actually convert state proofs into snark proofs in a relatively feasible way. Algorand will do it as a service to the community, but you don't have to trust it, right? So we do the work of all the heavy lifting of converting the state proof to the snark proof, but the cryptography assures you that we have done it in a trustworthy way. All right, so just to wrap up with some parting thoughts. Again, state proofs are allowing for easy verification of Algorand state by entities that are outside the Algorand network, that aren't running the layer 1 protocol, of which there are many. And there's lots of applications of this. I gave you 2 of them, the bridging to other chains and fast catch-up, but we'd love for you to think of more uses of these state proofs. Secondly, state proofs are giving the Algorand chain long-term post-quantum security. Even if a cryptographically relevant quantum computer were to emerge in the coming years, the history of the Algorand chain would be protected from such computers. And lastly, these state proofs can be ultra-compressed down into very tiny and cheap-to-verify snark proofs, which can be verified on highly constrained environments like smart contracts on Ethereum or other ultra-lightweight clients or the like. Right? And that's all I have. Thank you, and I'd love to take your questions. Thanks for your attention.
All right, thank you, Chris. Yes, I think we do have a question over here.
Okay, thank you, Chris. I have several questions, but I won't hog the mic. So I'll just start with, at the beginning you talked about quantum computers changing the history of the blockchain. Can you talk a little bit more about how that's possible, given that all the participating nodes know the current state? How can that change?
Yeah, so as I was saying, this is a bit of a subtle topic. If you're running an Algorand node and participating on the network as the chain is evolving, maybe from the early days, and you've seen everything happen, then yes, you can have confidence. As long as you think there hasn't been a quantum computer messing with things up to this point, yes, you can have confidence that because I saw everything happen, prior to quantum computers emerging, then I feel good about the current status. The problem is for people who are maybe entering the network for the first time and are provided with, okay, here's what's been going on in the 3-4 years that you were, not on the network, right? And a quantum computer could potentially fork the history and present some alternate history to the newcomers, right? And not just newcomers, but smart contracts, all the ones who are outside the network who haven't been participating from the beginning or from before the time of quantum computers. So that's the risk. And of course, with the interoperability story, there are many participants who we want to show what's been happening on Algorand in a quantum secure way.
Okay, I'll ask one more and then I'll give it up. When we talk about post-quantum security, is there some specific property about quantum computers that makes them special, or is it just a question of compute power?
Yes, so there are very special properties that are very hard to describe in 5 seconds, unless you're a quantum computing expert, I suppose, but then you already know the answer to the question. But for some reason, the ability to have cancellations and do Fourier transforms and so forth over complex probabilities is the kind of magic power that quantum computers have, and it just so happens to be perfectly suited to breaking all the cryptography that we've deployed in the past 40 years. It's kind of a bummer, but at the same time, it's given us all these, motivation to do all these new great cryptography schemes that have other awesome properties.
And there we have it. Mr. Chris Pikert, our head of cryptography. I want to say thank you very much, Chris. He is just a wealth of information, and he takes questions. And I want to, in the interest of time, I'm going to say thank you very much.
Yeah, I'm available. Find me offline.
And we're going to get the next group up here. But I want to make sure that you guys follow him on Twitter. He will answer your questions. I know this because when I'm in the office and he comes into the office as well, we will sit next to each other, and he will spend the time with me to explain this stuff very succinctly, just like he's done here today. A great wealth of information. Give it up for Chris Pikert.
Yeah.
All right, we are going to move along to our next group of speakers today. Our first panel here, I'm really excited to welcome to the stage here. We have Mr. John Woods, Chief Technical Officer, as long as Gary Maloff, Head of Engineering. Welcome to the stage. They're going to have ourselves a little round table here, hosted by Fred Asante, Head of Product Marketing. So welcome all to the stage.
Thank you.
Fred, take it away.
Thank you very much, Ryan. Ladies and gentlemen, welcome. It is a pleasure to be here today. And I got to say, I am so pumped and thrilled to share the stage with these two guys. And John, I love you, but Gary's kind of like a personal hero of mine. My inner Algorand lover DJ is pumping right now because I got to talk to one of my Algorand heroes right here. So John, I love you, but I got to start with Gary today. Gary, everybody knows you're head of engineering at Algorand, but who really are you? I mean, can you tell us a little bit about your education and your professional path that allow you to become head of engineering at Algorand?
Are you my therapist?
Maybe, yeah, we'll see.
So yeah, I'm Gary Maloff. I've been with Algorand for the last year and a half. I've been building distributed systems for about 15 years. Originally in the ad tech space, we were one of the first teams working on real-time bidding systems when ads were going from being largely pre-purchased to on the fly. Did a stop in Forex trading for a few years, which was very enlightening. Learned the ups and downs of the industry, and actually tried to take those two and combine them into a platform. Didn't ultimately work at the time. I think we're about 5 years away from that right now. Ultimately, in my last role, I was leading ML engineering, big data platforms, on-site media trading at Wayfair, and was starting to get interested in Bitcoin around 2016-ish, and ultimately met Paul and got really excited about what Algorand's up to, and here I am.
That is fantastic. Thank you. What about you, John? You've been to some amazing places in the blockchain space and other places outside of the blockchain space before that. Can you tell us a little bit about your background?
Yeah, sure. I'm John Woods. I'm the CTO at the Algorand Foundation. And I've worked in 3 places involved in crypto. I worked at Consensus, where I led software architecture and applied cryptography under Joe Lubin's leadership, and we were building enterprise applications on Ethereum at that point. I also was the chief architect on Cardano for about a year, and I led architecture and applied crypto there too. So I worked at IOHK with Charles, and we were building out Cardano, and it was really interesting. And that's where I left to join the Algorand Foundation about 6 months ago. So I've been here for about 6 months. It's been a good time.
Fantastic, thank you, John. And I guess I'll start my first question with you because you've clearly been around, Ethereum, Consensus, Cardano. What caught your attention about Algorand's tech? What shone to you? Like, what made you really excited about, eventually becoming the CTO of the Algorand Foundation?
Sure. So I somewhat controversially said earlier, because I've seen it on Twitter, that Algorand is the first blockchain that's fit for purpose. And maybe I could dig into that a little bit and tell you why I made that statement and why I think it's true. I think a lot of blockchains out there are really excellent efforts at building distributed systems. This stuff is hard because it's the intersection of a number of different disciplines. So you can't just hire good software engineers and expect to have success. You need guys like Picard there who are like super geniuses on mathematics and cryptography. You need distributed systems engineers who understand how you can build systems that are in distributed locations and still perform well. And you need normal software engineers too. You need architects. So it really is the intersection of many different disciplines. What got me excited about Algorand was during the interview process. And so I remember thinking this is really quite funny. I was working on Ethereum, working on Cardano, working in the crypto space, for 7 years at this point. And yet still, I didn't know how good Algorand was. It was only during the interview process that I kind of started digging into the tech. I think that's funny, right? I think that's why Algorand is just starting to come into the zeitgeist. It's just starting to become a popular chain, is because people aren't aware of how great this thing is. And so when I started playing with it during the interview process, making sure that I was prepared for the interviews with guys like Gary,
Sorry.
I started sending transactions, and at first I thought, oh, I must have got into a block straight away. I must have just been lucky. I must have just a block was minted just at the point where I sent the transaction. Then I was like, it happened again, and it happened again, and I started looking up the block time. It's like, okay, it's done, 3.5 seconds, okay, that makes sense. Then I started looking up the TPS, and that's huge as well. And then when I started looking at the structure of the code, the way it's been engineered, it's written in Golang, it was just seemingly a very well architected product. It's written in an elegant way, and I think it fits together really well. And so all these things together, the applied cryptography that Chris's team leads out, the distributed systems engineering and the software engineering that Gary's team leads out, have put us in a position where we are one of the, I think, best engineered blockchains in the space. And like I said earlier, so good that if a country or a major organization or there was some enormous uptick in transaction volume that happened immediately, the network is prepared for that. And so that you can't say that for all of the other networks that are out there. Many of them would be crushed by a high load.
Fantastic. And well, John, you just laid the framework that building a layer 1 protocol is probably one of the hardest challenges in computer science, right? And well, Gary and the entire Algorand Inc. team, they have done it. They've built a protocol that's been up and running for, if memory serves right, 1,259 days, no stop, zero downtime. So
Zero downtime.
So how do we get there? I mean, how do you build a team? How do you build,
So first of all, zero downtime, I think Paul mentioned it in his keynote, it's really a challenge, right? It's not something we just rest on our laurels and everything's great. We're constantly working at how do you trade off security, scalability, reliability. Sometimes it's direct trade-offs between how distributed I'm going to be and decentralized versus the ability to scale up when you see bursts of transactions, right? In a Web 2 world, you can just, hey, I'm just going to go throw more servers at this and solve this problem really quickly and push a button. In a Web 3 world, you have to plan out how is data going to be sharded? How am I going to make sure that I can get a release out in a reasonable amount of time and get consensus upgraded? So the challenges are immensely more difficult, I find. Even silly things, releases, for example. In prior worlds, I push a button, my release is out there, everything's great. Oh, I got this wrong, let me push another button. In Web3 world, it's a very different story. You're convincing people, hey, I know I just did this release last week, but we found that we can make this even better, or we think there's an area that we have to patch. And instead of being able to quick push it out yourself, you're negotiating with partners. You're going through, hey, if we go and we see this bug, how do we make sure that we fix this in a way that's secure, that people aren't going to take advantage of it before we roll it out? The security is everything as well. If you break the cryptography, it's over, right? There's no oh, I'm going to refund you if I lose 1,000 algos. It's one directional. So the pressure's there, and the level of testing has to be immensely high. The bar for release is incredibly high, and it's real work, is what I would say.
Absolutely.
I would just build on that and just say, there may be a time when Algorand does have an issue. Code is imperfect by definition, right? And so it's not that we're immune to having issues in the mainnet, but I think the team have done a great job in building something that's robust. So it's not up and down all the time, and you can rely on it. But at some point in the future, we may end up being in an unknown situation where there's a bug that we're not aware of that does cause disruption to the network, and maybe we will suffer some downtime. But I think the testament is, when you're building systems like this, if you can engineer them where they're being attacked from all angles, because it's a high-value network and people would love to be able to break it. When it's been attacked from all angles and still it has such a high uptime where it has, I guess, at this point not had any downtime. But if you can build a system that's that robust, again, it's fit for purpose. You've built a system that can be relied upon. And so even Amazon has downtime sometime, right? But if you have production applications that are out there and you're serving customers, you want those customers to be able to rely upon it.
I would just say, add on, the bar for releases is incredibly high for us. The level of testing we go through is immense. We roll out to one network, we watch, we learn, we see how you're all interacting with it. We love when dApps interact with us on BetaNet, by the way. Please do that. We learn immensely, and hey, we didn't think of this situation. Let's make sure we cover it. And so just the level of thought that has to go into every release, and we try to hide it from you. If we're doing a good job, you're not seeing it, honestly.
Yeah.
But that's what we're trying to do, is hide it. It's incredibly hard. The most reliable thing I would say is our consensus protocol has been consistent from day one, and that takes a whole lot of pressure off of us. But it's an incredibly high bar.
Fantastic. And you touched on a really good point about testing of the code, right? Given that it's so hard to roll back anything doing a distributed system. Can you just expand a little bit more on like the testing framework that we have, like what you do like on the code front, but also, private net, beta net, this and that, mainnet?
So there's two aspects, right? There's the functional testing of, do I have this right, which is its own high bar, and you have several levels of automated testing there. You also have the manual, like, hey, go get 10 apps to go use this code. Is the bar. Immense levels of code reviews. We have several senior people that are looking at every commit before it ever makes it to the main branch to go out. And then you think about performance testing, which is a major topic, obviously, in blockchain world. We've built several scenarios. I think we're up to 4 or 5 that we run today before every release. We are running them constantly because we have a heterogeneous network. Different people have different specs on their relays versus participating versus non-participating nodes. You have to anticipate, for every one relay I have, I might have 500 connections to it. And how does that play out? And then this relay, which doesn't perform quite as well, might get half of those. And so if you try to do everything homogeneously when you're testing, it doesn't work. So that's why we run actually several different scenarios. Very large numbers versus very small numbers of nodes. Clustered in certain regions is another thing that we're looking at really hard. That, I think, is probably one of the biggest challenges. And then you go and put it on the main network, and you find out, hey, I got these 5 assumptions right and these 2 wrong. So how do I learn and adjust and build more scenarios, or discount these 2 that don't make any sense? It's a constant state of learning, which makes it a really fun challenge to go after.
Cool. And I got a question that I've been dying to ask for a very long time, so I might as well do it here. Do you guys over at Algorand have any sort of like ops room, like a place? It doesn't have to be physical; it can be online. But where we have all this dashboards monitoring the health in a much deeper level that we've seen in just the plain explorers in the system that are monitoring all these crazy stats about network, making sure everything's fine in beta net all the way to mainnet. Do you guys have something like that? Can you speak to that, or if you cannot speak to that,
we have a great amount of telemetry particularly on relay nodes. People choose to opt in when they want to support the protocol. It's definitely an opt-in process. But it allows us to see when different relays are performing at different scales. We have that available in real time. We of course have the actual main network stats, how many transactions in a given round, latencies, and if they're tweaking between rounds at times. We look heavily at how many different dApps are interacting throughout the day. So yes, we have a bunch of dashboards up in the back room. I can't say we don't have to watch them 24/7. We have plenty of automated alerts, which is beautiful. And first of all, if the network's even having a hiccup, you hear of it. We have a great community. It's a large, engaged community. You hear if there's even a hiccup. So daily basis, we're aware of anything that's going on. So yes, we're pretty dope.
Fantastic, awesome to know. John, any further questions, or can I?
No, I think it's great. I mean, I have experience. I'm not building the protocol now. I'm at the foundation, obviously running the show, keeping an eye on Gary. But from my days in Cardano, where I was building the protocol, and I did have to sign off on the release. It's high pressure, right? Because it's people's money. Like, I don't want to be the guy who signs off a release and then there's some massive break in the code, and then people end up in a lot of pain. And so we had the same testing process there when I was working there, and it really is quite heavy. And sometimes releases would be code complete for months before we actually get them through the performance engineering testing. Again, when you're building distributed systems, a big component after the security, after you've got the engineering done correctly to a spec, there's a big part of it which is like, how does it perform? How will it perform in the real world? You know, so you can have simulation, you can have benchmarks, you can even deploy in the real world and see how it performs. But that piece about regressions in performance is probably something that's very tricky to manage when you're building out layer ones, right? Because you can add new features, and all of a sudden you find that the smart contracts take like a certain number of microseconds more to validate, and all of a sudden it's affecting your block propagation times, and now it's affecting your consensus, and so it really is a tricky one to get right, and so I'm so glad I don't have to deal with it anymore.
Thanks. One other piece I'll add to that. The other challenge that's unique to blockchain is that when I push a button and release, it doesn't mean everybody gets the feature instantly, right? You also need 90% of the online stake in an Algorand to adopt it, and sometimes you're convincing people that they need to upgrade now, right? And this is a decentralized world, so I can choose not to upgrade. And actually, our protocol, we have a pretty high bar before we add new features, and it's not even our bar. It's just the nature of the consensus protocol, 90%. And it can take days to reach that because not because anything's wrong, the code can be fantastic, it's a great feature, it's because it's a decentralized system and you need people to choose to adopt it. And I think that's a very important aspect that we try to make people aware of.
Another one that I have a problem with is like people go to the GitHub repo, right? They git clone the code and then they compile the node based on the main branch. And they're running that, so they're like ahead of everyone else. And you know, it can be a pain in the ass.
We see that with the indexer quite a bit too.
Right, yeah. You know? So yeah, I agree. Trying to keep people on track, tricky.
Yeah. Fantastic. All right, John, well, I guess the next one is to you because you've built either protocol or interesting dApps, you know, Consensus, Ethereum, then Cardano, and Algorand. Can we do a little dive there on what is the difference, like what you see both from the technology stack, you know, looking back at like the core protocol and also developer experience throughout these three major blockchains they worked on, and how do you think Algorand bodes, you know, moving forward in the future?
Yeah, sure. So to contrast the development experience with Cardano, I think Cardano's engineering, its consensus protocol is called Ouroboros, and it's a longest chain wins type consensus protocol, but it's heavily coupled with data propagation. So with Cardano, if blocks don't reach the network within 5 seconds, you start to have short forks in the Ouroboros consensus algorithm, and it will slowly dissolve to the point where consensus is lost. And so development there was very much focused on systems engineering, just like making sure the performance was good. And it was also written in Haskell, which is an insane language to use at any time for any reason. So in contrast, you know, Algorand, although I'm not developing the protocol directly, is written in Golang. Obviously, not my favorite language in the whole world, but a reasonable choice. I think as well, doesn't have as many gotchas. Scaling out Algorand is, I'm not saying it's easy, but it's easier than scaling out some other chains because of the way it's been architected. And so you can see that with the gargantuan leaps that, you know, Gary's team have made over the last year. You know, transactions per second up, you know, 5-6x. Finality down by like, you know, 20%. These are huge leaps. These are gargantuan leaps. And so you're only able to do that if your underlying engineering is strong and if you've built things the right way from the ground up.
It's nice to have the language not fighting you, is what I also say.
Yeah, right? Exactly.
When we're thinking about how do we deal with performance, it's not, we're not thinking about, oh, how do I work around this language, which is focused on static. I know which one you're talking about. I worked in Scala for a decade based off Haskell.
But even like the compiler for Haskell is called GHC. And so there's different versions of GHC. And there was times when like the compiler was putting in, like in the actual machine code, we would find that the instructions it had chosen to use were like outrageous. Like you would like hash include a file or like change a dependency slightly and it would totally change how the compiler would produce the bytecode. And it's just like, you know, it's like there's a ghost in the machine fighting us, you know? And so I think having a choice like Go makes things easier.
It also helps that a lot of the cryptographic functions are much easier to work with as well.
Yeah, exactly.
Yeah, fantastic. But John, you just mentioned machine code, so maybe that's it's a good point to change gears a little bit and ask, you know, Gary, why has Algorand decided to create its own virtual machine, the AVM, instead of just taking the EVM and plugging into PPOS?
So if we go back 4 years when we're building building the Algorand blockchain. We knew we needed to be able to iterate quickly when we launched, and we needed to be able to have something that fit with how our protocol works. So it's going to have the performance and scale that we need. Trying to retrofit the EVM just wasn't going to happen. It's not the most performant system in the world. I know people enjoy writing in Solidity, so no taking shots there. But from a performance perspective, from ability to maintain it, we thought it would be a nightmare. I think that I don't regret that decision that Algorand made. I was not here at the time. It was the right one. And we've ended up supporting layer 2 solutions that get Solidity over. John's worked with some of them most recently. But in short, the AVM is built for us. It performs very well. It allows us to hit the high TPS we want to be able to hit both now and in the future. And we'll be able to continue to maintain and iterate on it. The EVM was not going to be able to do that.
Fantastic. And for those people that may not be as much aware of the differences, can you just say that like the basic differences between the Algorand virtual machine and the Ethereum virtual machine?
It's more of the instructions that each is able to run and how it fits against Algorand. So I think it would be going level too deep into the details to go there, but I would say the EVM does not have Algorand as a target in mind.
Yeah, I would say for the non-techies, the AVM is just way better. Yeah, but jokes aside, it's built for speed and precision. It is easily my favorite VM. I mean, look at the other VMs that are out there. There's the Java virtual machine, and that sucks. I think we can all agree on that. The Ethereum virtual machine, clearly not as good. So I think the team have done a good job with the AVM. And if you look at some of the things that are coming out now, we have really quite mature instructions. So there's like an opcode, there's like a low-level instruction you can ask the AVM to perform in one step that will verify elliptic curve signatures on Edwards 25519. Similarly, there are other kind of pretty cool, I think, constructions around the opcodes that make it, I guess, quite efficient when the compiler is writing the bytecode. So I think they've done a good job with Teal. Earlier on, I was talking about AlgoKit, and really what I'm trying to do there is work with my colleagues at the Inky in order to bring a developer experience that is simple and fun. And so I think you can have the AVM can be great, and technically it can be wonderful, and the opcodes can all be well formed, and we can have it be performant, and that's all great. But just like people don't write really a lot of stuff in ARM assembly or in x86 assembly or in MIPS assembly, we don't want people to have to be down at that level. And building these abstractions happens over time as platforms mature, of course. People used to write code, on punch cards. Then they wrote it in assembly. Now we have nice high-level languages like Rust, and it's easier. And so this is the journey that the development experience for Algorand is going on. And it's maturing at a very fast rate. And I think when you see AlgoKit drop in Q1 next year, you're going to think, hey, this is an experience that I'm comfortable with, that I'm familiar with. And we should see, again, a surge in adoption.
Cool, awesome. All right, Gary, recently you taught me a new word that I had never heard before.
Thank you. Thank you.
All right, when we were discussing protocol, you mentioned about just going back to nodes for a little bit, right? You talked about the polymorphic nature of nodes, and I had to look that up because I had no idea what that meant. But and the explanation you gave to me was nice, so maybe I think people would also appreciate, just understanding, like for the Algorand protocol, why did we decide to go the route that we have, the construct that we have for the different types of nodes?
You want install to be as easy as possible, so you want John to be able to spin up a node as fast as I can, really quickly, and for completely different use cases. So we have one install process with slightly different configurations based on what you're trying to do. So if you're a dApp runner, you probably want a non-archival, non-participating node, and it's basically, you tweak 2 settings, go. If I'm running a relay, the foundation's sponsoring me, and I'm running a relay, I want to be able to tweak 1 setting, push a button, and I've got my full archival, full relay node. And the whole idea with that is it's one code base. The only difference is configuration. It keeps it simple. It's easier for us to test and maintain over time. It allows us to experiment with different combinations of settings to figure out what's optimal for different situations. We have something like 7 or 8 different user stories of user types, that I would call it. Each of them run in slightly different configurations, and being able to quickly support all of them is why we call it a polymorphic. It's polymorphic because you're only changing a configuration, essentially, right? It's one install for multiple types.
Got it. And then moving forward, do you think you're gonna stick to that construct? You're gonna add more
Yes,
options, reduce options?
It makes a ton of sense. We will try to streamline the options to make it easier to identify what I should be running. I think we have instructions, great instructions on our dev portal right now, but we will streamline it even more so it's basically interactive. I want X, Y, and Z. Okay, this is what I need.
Cool. All right. I don't. John, do you have a follow-up to that, or?
No, I think that's very well answered.
All right. Cool. Awesome. We only have. Sorry, you're gonna say something?
No.
All right. We only have maybe 5 minutes left, but so maybe you can shift gears to the conversation, like looking forward to the future. What can you say about the areas of interest, areas of research that Algorand Inc. is pursuing? John started the conversation before. It takes a really multidisciplinary team to research, code, build, test a layer 1 protocol. So what are you guys focusing more resources in terms of research and development for the future?
So you heard some hints of this in the last talk with Chris in terms of building snark proofs, and that will be an effort in the early part of 2023. The sub 3 second rounds is a huge goal for us, and it sounds really simple, and it does. It's like, hey, just turn down the round latency. No, you actually have to change pretty much everything from how the network communicates with one another to how the CPU performance of the nodes in order to squeeze every bit of performance out of that. That will take a huge amount of effort, experimentation. We have like I mentioned, those suites and suites of performance tests. Those are going to only get added to, and it'll be an intense effort over the next 6 to 12 there. The indexer is actually our indexer, many of you rely on for one case or another, is actually getting split out into multiple components so that it can scale with the rest of the chain as we go up to thousands of TPS transactions per second. That'll be a major one. And of course, everything we can do to support AlgoKit's success, whether at the PyTeal level or similar, that is a huge priority for us.
Thank you. AlgoKit is our focus.
Yeah. Fantastic. All right. So basically what you're saying is that maybe sometime within the next few months, we might have another performance upgrade to reach that sub 3 second block finality?
You will see several more releases on the way there. I don't think you'll see one release that drops it almost a second. I think you'll probably see several where we give you a bonus. Hey, with this consensus upgrade, we just cut another 200 milliseconds off. You'll see it gradually get down there. Like we did a 500 millisecond cut in one release earlier in the fall, and you'll see several more over the next few months.
Fantastic. And the objectives around 2.5 maybe?
I'm going to say sub 3.
Sub 3. Cool.
But it's already so fast. I mean, it's like sending a text message, right? Like, I was showing my mom. I was like, hey, Mom, download ParaWallet, whatever, buy some algo, trying to pump it, And she was sending it back and forth between my phone and her phone, and I was like, look, it's like sending a WhatsApp text message or whatever. It's really fast. It's good. It's about the same time you wait when you're in a store and you tap a Visa card, right? Like, it's at a good place right now. And so yes, it'd be great if it's even faster, but I think it's very, very good UX right now.
Using applications built on top of us, I can say it is in a lot of ways, it's a lot more streamlined than the experience I've had in Web 2 applications. But the latency, at one point I thought it might be a concern, it's a non-issue today.
Yeah.
Right. We want to optimize. I think we want to get down so that there's folks that can really benefit from the really tight round times, and that's why we're going to do it. But from hey, we're final in 3.5 seconds. It's pretty amazing.
Yeah, it's pretty amazing. Can confirm.
Fantastic. All right, I think we only have maybe 2 minutes left, so I do have one last question for John, but actually I just want to see if anybody from the audience has, all right, quick hand up. Didn't even let me finish the sentence.
No hard questions, no controversial questions.
Any questions for these guys?
On the panel, you mentioned that if there's an attack with transactions per second, that Algorand is capable of still functioning, unlike a lot of other blockchains. Can you please go into that a little bit further? What's the protocols? What's the fail-safes that you were talking about?
Say that one more time because it's hard to hear you just because of the echo.
Sorry. Earlier on the panel, you said that if there's going to be like a transactions per second attack, like a large amount of transactions per second, you guys are going to have a fail-safe to make sure that the blockchain still works.
Okay.
If I understood, I believe that was said earlier.
Maybe you said that, did you? Fail-safe on transactions?
I think that was you, actually.
Yeah.
Yes.
You said that that unlike other blockchains, that Algorand would keep working, that there's a protocol in place or a fail-safe. I might be misquoting, but something like that.
Yeah, it's okay. So yeah, I think what maybe you're speaking about is when I was saying we had no downtime whatsoever. Is that what you're talking about? And then I was saying sometimes we might hit a problem.
Yes, sir.
Oh, sure. So yeah, what I'm saying there is I just want to set people's expectations because this stuff is really hard. And even like emergency systems go down in countries, right? Like people have issues with like the space stations, you know, like there's issues out there. And so I think when I was at Cardano and when I've been working even with Algorand, I try to stay away from like hyperbolic statements about the network. So like you see a lot of protocols and they say, oh, we've got 60,000 transactions a second. Yeah, but we're like, you know, up and down like a yo-yo, and like half of them are for consensus. Or you see other platforms and they're like, oh, you know, we're so cheap and we're so decentralized. Yeah, but not really, because like you're actually running 80% of your nodes on AWS East Coast. So like, I guess what I'm just trying to say is, yeah, it's great that we've had no downtime, but for the community, I try to discourage a little bit that kind of like showboating, you know, stats and metrics about that kind of thing, because it may be the case at some point in the future. There's an unknown bug. Maybe it's in the CPU, maybe it's in Windows or Mac OS, maybe it's in Linux, maybe it's in the software itself. But it's not impossible, of course, for the network to have issues. And I guess my core point was building a network that you know is strong and you're doing your best in terms of all the testing, in terms of being responsible with how we develop, so not just rolling out features just to be first. These things are important. And so even if we do end up having an incident at some point in the future, it's something that we can recover from, and it's something that won't happen very often because of the level of effort that's been put in to make this thing robust.
I'll just add too, we're looking at the incidents that have happened over the past year with other chains without going into any specifics. And
yeah, so did you say Solana, Gary?
I didn't. I'm sorry, I couldn't hear you clearly.
I think you said Solana.
We're looking at, basically what I'm saying is we're learning from those incidents too, and actually recreating those scenarios whenever possible to make sure that that's not going to, we don't want to see a reoccurrence.
Yeah, I mean, put it this way, you're not going to see Algorand, right, like being rebooted from a Reddit thread while the lads are on Telegram, you know? So you're not going to see that.
Yeah.
Thank you.
Thank you so much.
We appreciate the questions. Let's give a round of applause here to our panel. Fred, thank you so much for organizing this. Gary, thank you so much. I'm going to keep you on stage. How about that? But one more round of applause. Thanks, guys.
Thank you so much.
All right, John, come on up here. We're going to reset the stage, so I'm going to invite you to step forward while they do a little bit of housekeeping behind us. We're going to get you set up for the next talk.
Oh, okay. Nice
job,
You're just like a serial speaker, right? So let's hear. You started this off this morning. You've been rambling on here for half an hour. We're gonna put you together over here with Aubrey Anderson. He's the CTO at the New Computer Corporation.
Thank you, man.
What are you guys going to talk about?
Congratulations.
I think it may have gone on. All right. Well, so you guys are going to talk about onboarding the next 10 million users. Sounds like NCC have made a pretty cool advancement in wallet tech. Did you get your mic back on?
Yep.
All right, we're good.
Yeah. No, is it on? Yeah, it's on. So yeah, the guys at NCC have done a really great job in making this stuff usable. And so Aubrey and I, we were collaborating on various things, and I just wanted to come up on stage and talk with him about his product and demonstrate, I guess, the pushes they're making to try and make it easier to bring people into this space. Because not everyone is going to be comfortable running nodes, not everyone's comfortable even using things like ParaWallet. So we need to make this stuff invisible. If you're using this thing to get into a gig or to get into a show, you want the technology to get out of the way. And so Aubrey's company is really focused on that.
Yeah, and Aubrey's been here within the Algorand ecosystem for well over a year now. I really want to welcome you to the stage, Aubrey. Yeah, great. Yeah, a couple of years. So, Chief Technology Officer Aubrey Anderson from the New Computer Corporation, going to speak with our CTO here at the Algorand Foundation, Mr. John Woods. A little fireside chat, guys. Have a seat. Welcome to the Algorand Tech Talks stage.
Thank you. Thanks for all the clapping.
Check, check. Hello. How's it going? I'm going to do something weird today, which is show UI.
You doing a UI demo live?
Yeah, there's like a demo with some UI, just to kind of break it up a little bit. My name is Aubrey. I'm a co-founder and CTO at a company called the New Computer Corporation. We build kind of low-level tooling for consumer applications. The goal for us is to make all things Web3, Web2 easy. A year ago, I would sit up here and talk about how we want to really go after the Web2 people, and everyone would just sort of stare blankly at me, like, what about NFT prices? And I'd be like, well, no, I think it's the Web 2 people are really where it's at, big time scale. But so we've been hard at work all along. We don't do DeFi, we don't do speculation. It's just a pure play technology company.
And I think, you know, like the name of this talk was onboarding the next 10 million users, right? And I think what I like about Aubrey's company is that they're taking Algorand tech because they recognize, again, it's fit for purpose and it's able to give people a good experience. Again, because let's say at the recent event that you guys did, which maybe you could talk about, you know, folks are having a good experience in using the tech there because it's so fast, because it's reliable. But the best bit is most of them didn't know they were using it.
Yes. Yeah, the goal, especially, we do some work where people are at festivals or they're at events or they're at conferences, and we want to add value with something with the decentralized workflow. At music festivals, they're drunk, and it has to be really easy. The evolution of this wallet system that we have, oh, my computer went to sleep. Isn't that always the case? We built the wallet called Inky as a result of trying to do it every other way. We tried an embedded system. We tried using Wallet Connect to bounce over to Parawallet and bring people back. And what we found is particularly at events and with the completely uninitiated, it was just full stop. We found that nobody will install anything, particularly on site. And if it isn't familiar and easy, as soon as they see something that feels scary, they stop.
And I think this is it. Like, you can't expect people who are rocking up to a gig where you've got your new POAP token or you've got, like, you know, a deal with the people who are running the event to allow people to buy services or goods at the event. You can't expect these people to download some app they've never seen before in the middle of the desert, memorize words, test them, can they remember their 24th word?
It's never going to happen.
It's just not going to happen. So I think the coolest thing about this and what your technology at NCC enables us to do is go out to existing regular people that are using normal computers to do normal stuff who already have an iPhone app. You know, whether it's a football club, whether it's a baseball team, basketball team, whatever, these guys, they already have their apps. They already have them built. They've had them for the last decade, okay? So it's like, how can we seamlessly be part of that rather than trying to get people to jump into a totally new application? And so that, I think, is how we get the next 10 million users. It's going to them and being part of their existing ecosystem, not trying to force them to do something different, right?
Yeah, I think it's critical to be able to embed decentralized workflows with current audiences, and particularly already scaled and enthusiastic audiences, rather than having to introduce multiple workflows all at the same time. The drop-off is enormous. All right, you want to see some pixels?
Yes, let's do it.
All right, let's do it.
Are you going to demo Inky?
I'm just going to show you how it works. I made lots of pixels just because, you know, it's the end of the day. So this is a great example of the Inky wallet. We just did an activation at 3 Points, which is a music festival in Miami. We were able to embed ourselves in their current mobile app. I'm going to go back a little bit. So they currently have a mobile app that's already distributed to hundreds of thousands of fans in their ecosystem. About 30,000 of those people showed up at the festival. We embedded ourselves in an iframe inside their current mobile app, so there's nothing to install. The thing that showed you the schedule also allowed you to transact. The process looks like this. You go to the section, it was really just a tab in their application. That loads up our workflow. What you see, the Mango is part of a dApp that we built, and everything with an octopus is an interaction with the embedded wallet. The wallet embeds itself, in this case, in an iframe. The iframe is memory protected from the dApp that surrounds it, but it all just feels like regular old Web 2.0. I create an account. I get a little bit of advice about not losing my password. I pick a inspiring username. I chose 3 Pints. You choose a reasonably secure password. I'll give you some inline advice about that as well. and then you start the create flow. What's happening behind the scenes here is I'm creating a wallet for this person. I am pre-funding that wallet with a little bit of algo so that they can actually transact. And then I'm dropping them into a workflow that already feels familiar, which is just making sure they're not a robot. And then we can start having brand communication with the person and just take the kind of technology and scariness out of it. I mean, what's less scary than a roller skating lizard? So we have one more step in this process after the wallet is created and funded. They have to approve a transaction to bring themselves, in this case it's a token, it's a Algorand ASA, which allows them access to do all kinds of things at the festival. Boom, we're done. The whole workflow clocks, if you do it quickly, about 7-8 seconds, because we're wrapped up into 2 transactions. And the transactions, as was just discussed, we close out each transaction under 4 seconds. So if you kind of move through in a timely way, it's fast enough that people came to the festival, saw that there was an express line that had no people in it, were able to sign up for this and get the token, which allowed them to go into the line and go into the festival. At the festival, they just used this symbol as a resource. That was, because it's an interactive bit, this is just a little WebGL render thing that's touchable. If a non-crypto native bartender could see that you had the token because you would just tap the thing and it would move around. It's not a video, it's not a screen grab of someone else's. It was secure enough for their purposes.
Aubrey, you were talking about the adoption and the conversion rate and that kind of thing. We discussed it a few days ago. Can you remind me about that?
Yeah, absolutely. It's worth pointing out. So about 30,000 people came to this 3 Points Festival. They're back to kind of a normal attendance after the sort of COVID downtime. And we watched the metrics very, very closely. Our hope was kind of on the high end to convert a couple thousand people and open a couple thousand wallets. What we found is we actually opened 4,500 wallets, which is about 15% of all the attendees. We had very, very high engagement. Click through the link. It was about like 8,000 or 9,000 people clicked through. About half of those, 50% conversion, ended up actually going all the way and creating a wallet.
It's very impressive, and I honestly do think that if you used a more traditional route, where you built your own iPhone app, rather than dropping Inky in, so Inky is this module that you can drop in a frame in any web context, right? And actually done so, surprising to my surprise, in a way that protects the keys, so that the key material is not at risk. There's no way you'd have a 15% uptake.
No, the last activation we tried, we had about 2%, about 1.3% conversion. And I mean, so this is just a massive change.
Yeah, and the thing about it is that you can build as great a protocol as you like, and you can have the best developer tools. But at the end of the day, we need normal people and regular people to be able to use this stuff and do so in a way that doesn't require them to go outside of their daily flow.
Yep.
And I think that things like Inky are really paving the way for that.
The other thing I think we should point out, just about like a learning and takeaway that we found, we sort of figured that emails about the activation went out a week before the festival. We kind of thought we'd see desktop people, but we didn't. We saw 99% mobile before the festival, during the festival, on day one, on day two, it was like effectively all mobile. And it occurred to me that I think there's this massive underserved or unaddressed audience who expect to begin work and end a workflow completely on their phone, and they think it's super bizarre if part of the workflow involves the laptop, which they don't have. That's always been my suspicion, but it's nice to have hard numbers to underlie, like there's real people that we don't know who aren't in this ecosystem, who aren't at this conference, they're all on their phones.
Yeah, it's amazing. Is there any other technologies then at NCC that you're working on that are like Inky pushing forward the kind of status quo?
Yeah, so this is a kind of a through line with all of the tech that we're building. We have what we call decentralized APIs, which are for developers who understand RESTful interfaces. They give you a RESTful interface into all kinds of smart contract workflows, tokenized workflows, and kind of micro applications that we're building the decentralized APIs in front of.
Yep.
The goal, again, is to allow embedded existing audiences to just move with one hop into experimenting with decentralized workflows without having to stop anyone at a wallet sign up, without having to ask existing users to like do another workflow. They can just, I'm in here, I'm about to stream this media, and you can just add calls to the APIs to move the media stream onto the blockchain.
Fantastic.
Okay. Oh, let me put up the URL here.
There's a question there from the gentleman in the back. Did you catch that one? Yeah, would you mind? He's going to bring you a mic. Sorry, it's just so hard to hear over here.
Basically, why not Web 2?
But just to clarify, your workflow with Inky did not include any mnemonic phrases, so there's no like custody of the wallet. So at that point, why not do it in Web 2?
So the workflow is actually very similar to what you'd see in like a MetaMask, where we ask the user to create a username and a password. We're actually encrypting your mnemonic with your password. And so it's not like a custodial wallet, and that authentication actually can follow you across other dApps, anywhere that Inky is embedded. So if I started a workflow on the 3 Points mobile app, I can actually use that same authentication on some other dApp where Inky is embedded. So they are actually transacting, they are actually signing the transactions. We're just trying to make it as frictionless as possible, and make it familiar. Oh yes, absolutely. The wallet is your wallet. The mnemonic is your mnemonic. You can export. You can import an existing wallet from somewhere else if you have a mnemonic from another wallet system. I didn't want to bog us down with the sort of import-export logistics, but anywhere Inky is embedded, it's a fully functional transaction mechanism. What we don't do is things like trading, or we don't do any on-ramp, off-ramp. It's just your kind of the ability to transact in your pocket wherever you happen to be working.
Good question, though. Like, I mean, I think you need to be true to the principles, and so it's not about creating another wall garden. You got to avoid that stuff. I really do think, and so I had the same questions before I got up here. But no, it is important to empower users to do what they want, but at the same time make it as easy as possible. But I think it's a good question.
Yeah, and it's, I mean, just like every blockchain has a strength and a perfect use case, I think every wallet has a strength and a perfect use case. And the goal with Inky is to solve a problem that we encounter all the time in actual implementation, and that sort of was our North Star in terms of the design of the wallet. Like, it has to be easy, it has to be embeddable, and it has to look familiar for people that don't do this all the time. And then I had a bunch of nerd requirements as well. Like, it really bothers me that people put wallets in browser extensions. Like, that sucks. Like, the memory model in a browser extension is very, very unsafe. I much prefer it in a sandbox, memory safe area like we're doing with Inky.
What I like about it is when, like, at the foundation, it's all about encouraging adoption, ecosystem, enabling builders, basically trying to cultivate this whole thing, right? And so we regularly will have folks call us up from household brands that you've heard of and go, oh, we're kind of interested in doing something. Maybe it's ticketing, maybe it's purchases, maybe it's like loyalty stuff, fan club stuff, a whole bunch of things like that. And like, Para is a great wallet. I use it myself personally for holding like small amounts of algo on my phone, and I love it, and I think people should use it. But it's not the solution for something like this. Like, trying to build a solution around Para for integration at a football stadium or for a brand like Starbucks, whatever, it's just not a good experience. Those folks already have their iPhone app, right? They already have their customer base using this stuff. And so something like this, I think, is the sweet spot for enabling people to use Algorand, but in a way that they don't have to go and bother using Para or some other workflow.
And as users at a festival become more sophisticated and realize what a wallet is, what an address is, we do expect over time that they'll move into more sophisticated wallets like Para.
Sure.
They're compatible.
But this is the onboard we need.
Yeah, it's the critical thing for us is just to get people into the ecosystem as quickly as possible, as easily as possible.
Yeah.
And then it's up to us what we do with them from there.
Yeah.
Good stuff. I think we got time for another question right here.
Thank you. Audrey, how do you monetize this?
Inky is open source. This is not trying to be a revenue stream for us. We don't want, everything that all of us want to do requires lots and lots of users and lots of people in the ecosystem. If we're trying to block people at this stage and extract fees, I don't think that's a smart strategic move. So we're trying to keep our vision on the kind of 10-year arc. We all have lots of ways to make money once we have 100 million transacting users, and that's our real job. To me, the wallet is table stakes.
That's cool.
All right.
I didn't know that. It's a good answer, though.
All right, gentlemen. Do we have time for one more question, guys?
Yeah, it's good for me.
Yeah, okay. Let's see if I can find one more. Oh, we got it.
This is what I'm doing today.
If the user can use the same address in multiple applications, and how can you protect the users so someone can implement and malicious things, and private key is shared in this case, or not shared, but you handle it in the background, as far as I understand. How, if the user can't see the transactions and confirm it, how do you plan to prevent it?
Users can still use a block explorer and go and look at their transactions. They still have an address. There's a kind of a utility screen in Inky that I didn't show today. That'll give you your address and link you through to a block explorer and let you do more kind of blockchain native workflows. We want that to be. We want to put that kind of workflow in the place where you're like, what is going on here? I'm getting kind of curious. Because at that point, great. Like now you are beginning to onboard into the actual underlying ecosystem, but we don't want to do it the other way around.
One last question there, I think, just behind you.
Right here.
Sorry, but what is the keys? Where do you store the keys of this wallet, for these users?
When can you use it?
Where is the keys?
It lives at a URL. If you go to inky.ncc.la, there's documentation and code and sample project and that kind of
Now, I'm asking, so when someone at a conference used this application to create a wallet and they claim an NFT to use it for a fast lane as you showed in the demo, you created the wallet for them? Is that the assumption?
Yes, exactly, and you have to reverse the traditional thinking. We go from a decentralized app, which might live at a URL. The wallet is then embedded inside that application. So we can be embedded in a mobile application. We could be embedded at a dApp that lives at a URL. We're trying to do the opposite of what's been the norm lately, which is to download a wallet application that's very heavyweight, and then try to synchronize that workflow with another application or the web. That's been very.
I get that. It's amazing. But if the user wants to claim their wallet, to own this one, where is the keys for their wallet? The private key of the wallet, where does it live?
The private key is encrypted with the password they choose.
Okay.
It's AES encrypted, and we don't ever see it. We don't know what it is.
Could they know it?
What's that?
Could they know the private key for that wallet?
Absolutely, yeah. We will print it back to you whenever you want, as long as you enter the private key.
Okay, so it's like it's stored somewhere encrypted in your back system, and they have access to when they want with their password.
And the DApp has some options there about where they want to store it. I personally, like, once it's AES encrypted, you could print it into a block. Like, you're not going to get that mnemonic without knowing the private key.
Okay.
And I mean, provided they didn't use the password. But you know, like the users are going to still screw things up.
Yeah.
But I think we can provide like baseline of security. It's as good as any other wallet that's out there in terms of how mnemonics are getting encrypted and how you decrypt them with a private key.
Cool. Thank you so much. Yeah.
Excellent questions all around.
Yeah, thank you. That was awesome.
Gentlemen, I want to thank you both for coming up and spending some time with us.
My pleasure.
John and Aubrey, thank you so much for joining us here. Round of applause for these couple of guys. Really cool tech that you've been building there.
Oh, we want to do this. There you go.
Where's the beers? Jesus Christ.
Hey, easy. We still got more presenters. Come on now. All right, everybody. Aubrey, thanks very much. Wonderful to see what you've been building there. We've got some more wonderful partners within the Algorand ecosystem to come up here at the end of the day here. So at this time, I'm going to begin welcoming to the, no, he is not paying attention. No. Leo.
Go ahead.
Yeah, I tried. I practiced it a whole bunch
It's complicated,
of times.
it's fine.
It's a really hard name. Yeah.
It's Basque.
Leo is easy.
Leo is easy, yeah. There you go.
Three letters. It's like Fox, F-O-X. Like I can figure this out. 3 letters, L-E-O. But
Totally,
the
that's
whole,
much
okay.
easier.
Yeah. Well,
You can go with that.
welcome to the stage, CEO of Koi Banks. Koi Banks are going to be telling us about onboarding the next 10,000 developers, specifically in LATAM.
Exactly.
Awesome.
There it is.
Welcome.
Thank you very much. Well, I must say, after last presentation here, the 10K might seem a little less than the 10 million, right? But the truth is, we have a tremendous gap in Latin America on how to bring people on blockchain technology. What I want to present you here is telling you a little bit on our background. I've been in the crypto space since 2013, specifically trying to build the traditional world into blockchain tech. And why in Latin America, it's probably one of the biggest questions that makes sense for blockchain technology to develop. So what you're about to see, it's the outline of a platform Koi Banks is launching next year. Its name's called Koi Banks Build, that will enable, in a nutshell, for any developer that is not savvy in blockchain technology to start coding top-level blockchain products directly on the Algorand protocol. So a little bit overview in LATAM ecosystem. LATAM today has a little over 660 million people. Out of those, 1 million are developers. That's a very small percentage when compared to other areas. Out of those 1 million developers, only 50%, over 50% are not knowledgeable in blockchain coding. And on the other side, you have that Latin America has, and this is already known metrics, a little over of 60% of the population that it's unbanked. More than half of every transaction takes place in cash, and you get almost 3% of the entire region's GDP that it's relying on remittances. And when you take that to specific countries, such as El Salvador, Honduras, Guatemala, it's even above 12% on 30% of the country's GDP. So if you ask me, this is like a perfect recipe for crypto, for blockchain adoption, for blockchain products, for building on a blockchain infrastructure in the region. However, when you talk to these developers, and this is a sample taken out of 2,000 developers distributed equally in the region, in terms of developers per population, these are the answers you get when you ask them how they interact with blockchain technology. More than 50% of these developers are not savvy in blockchain coding. And when you double click on why is that happening, you find reasons like these ones. And truth to be told, they make sense. I mean, some of the reasons are, I don't have the time. Other of the reasons is, basically, I don't know how to apply it quite yet. And when you really get into the deep of that, you'll see that you're a developer, fresh out of college, or a hackathon or a bootcamp, whatever you want to call it. You need to choose your protocol. You need to understand how to manage keys, custodial, non-custodial, hybrid approach, whatever you want. You need to understand how to manage fuel. You need to understand how to manage security. All of that while you're either studying or building your own startup or working at a company. So these tech disruptions like the blockchain, they at some point represent a barrier, an entrance barrier for a lot of these developers. And it's understandable. So how do we make blockchain programming easy in one of the regions that needs it the most? So this is there's a clicker. We also conducted a survey on which of the formal education organizations in Latin America have already blockchain programming in their curricula. And by having in their curriculum, I'm not meaning like an extra curricular course, a talk, a panel, like they're actually teaching tech students how to code or how to interact with blockchain protocols. 6. Only 6 in the entire Latin America. And when you double click what they are teaching, having some issues with the clicker, there you go. Basically, this is what they find, what you find in their curriculum. Ethereum, okay, I'll give you that, but then you have BitChain, Hyperledger, and in Argentina you have Blockchain Federal Argentina, which is not even a blockchain. I'll say that. I have trouble myself recognizing most of these are blockchain protocols. So you got a region that has the most need for blockchain programming, developers that have trouble onboarding blockchain coding, very few institutions actually teaching, and what they are teaching is not actually blockchain tech when you go really into that. A little bit on our trajectory and what are we planning to do about this. Coinbanks has 7 years tokenizing asset and integrating payment rails in the region, operating in Mexico, Colombia, El Salvador, Argentina, and Uruguay, growing in Central America this coming year. We have countries in more than 9 countries. We are connected to credit card processing companies, APIs, different blockchain protocols. We worked out of these 7 years. We worked with Ethereum, we worked with RSK, Bitcoin, Lightning Network. We also did Hyperledger, not proud of that. Also worked with Polygon. So everything we've done, and we came to the conclusion that Algorand was the best blockchain in terms of capacity for what we're needing. The problem is how to onboard those developers to Algorand, once again. Some more numbers of what we've done or what we have available in our platform right now. We are tokenizing over a billion assets, 4 on and off ramps in the region, integrating to, again, different credit card processing companies, 1 exchange license. And all of this we've done learning protocol by protocol, testing our smart contracts, and making it usable and ready to deploy mainnet for top quality banks, governments, and different organizations. So just for you to stay with me, getting the context in the region, the need for this type of technology, the lack of education and proper tooling, at least widespread, and what we have done at Coinbanks, this is what we decided to do. We are opening our APIs, launching Coinbanks Build, a developer-faced-oriented platform for any developer to start coding directly on Algorand, testnet, and mainchain without having to know Teal, without having to know Golang, directly using our methods, our tested contracts, our APIs to be able to launch, for instance, an NFT marketplace, a stable coin, to call our contracts and integrate that to credit cards, to issue your own security tokens without having to go through all of the trouble of understanding key management, fuel, different security methods, protocol selection, all of that made easy and made available at an API level for any developer in the region. Make it easier to build in blockchain is the way to take Latin America out of this situation. Again, more than half of the transactions take place in cash, more than 60% of the population underbanked, 3% of the entire region GDP depending on remittances, and only 6 education organizations teaching how to build on the technology that actually solves this stuff. So this is our little SandGrain to contribute to the ecosystem. We are already working with some early adopters. They are starting to implement Koibank's build in their tech labs, in their curricula, in their courses, to get these students, these future coders, these future hackers into Algorand blockchain directly without having to go through all the low-level coding that most of us that have some years in the ecosystem had to go through. And as per our educated guess, if I may, on the service that we've done and the people that we've been working with, my commitment to the Algorand ecosystem, to you all here in Decipher 2022 and for next year, is to onboard 10K developers for next year building on Algorand in production directly. Thank you there. So we'll be around with our team over here. Feel free to come chat with us, to subscribe. We are beta opening the platform for the first developers as from December this year, January next year, a second launch. So whoever wants to try it will be more than happy to do so. Particularly aimed to Latin America, but looking forward to widespread it as well. It will be a delight to get to know you, to get you on board the platform or reference. Thank you very much for staying to the very end. It's been a pleasure. I'm really looking forward to see you all. Thank you.
Leo and Bojan, thank you so much for being with us today and for what you're building. The Coinbase build is something that's brand new to me, and I am super excited to see this announcement. I didn't know that this was coming, and I'm really excited for the devs to get out there and do this. So thank you very much for all that you add to our ecosystem,
pleasure.
mate. Brilliant.
We'll do it.
All right, everybody, we're going to take just a couple minutes break here, and then we are going to come back for one more presentation with Emi. So sit tight. We'll be back in just a couple of moments. GM. Algo Devs, welcome back to the Greenhouse and to the Tech Talk stage. I'm still Ryan Fox, Developer Relations. Welcoming you back. We've got one more presentation to come. So if we think about today, like we have seen it all today, right? We have seen the vision, the tech that has been built, the tech that is going to be delivered, right? We've seen the 3 pillars. We've talked about it. We've seen the pitches. And to wrap it up today, we're going to welcome Imi to the stage. And Imi has a great story. He's been developing in Algorand over the past couple of years. He was in the first class of the Encode Club, and then he went through an accelerator. And now he's going to give us a demo about 2i2i. So if you are a developer out there and you're wondering, you know, how can I do this and what's possible, Imi is really the manifestation of what it is to come, to learn, and to actually build and deliver. So, Imi, welcome to the stage, and let's see a little bit about 2i2i.
Hi, I am Imi. I am a cyborg, and I create technology to help humans. Today, I'm presenting 2i2i. That is a technology that allows users to receive energy by talking to other users. 2i2i enables everyone in the world who has internet to have a potential income stream. And it enables to jumpstart the provably fairest and most inclusive economy ever. If you want to know about me, there's my CV. We start with the realization that energy and coins are essentially equivalent. To understand why that is the case, you can go here. In 2i2i, users can receive energy in the form of any coin, whether it's coins of objective value, like a Bitcoin or a Buttcoin, or coins of subjective value, like art NFTs or cinema ticket NFTs. Essentially, 2i2i is an algorithm that fairly orders the multi-dimensional demand for your time. 2i2i is also infinitely inclusive. That means that the value of the energy that can be transmitted can be arbitrarily small or arbitrarily large, allowing everyone participation. Practically speaking, you set the minimum value for your time, and those that bid that minimum, we call them cronies. There's those that will bid more, they're called high rollers. There's those that will bid for your time using subjective value coins, we call them eccentrics. And we even include those that bid less than your minimum. Those are called lurkers. They will not meet you, but they complete the picture of the demand. Thereby, we have captured the broadest spectrum of demand possible, all kinds of energies for your time. Hence, this becomes the fairest market for your time. And hence, you can harness the optimal value for whatever it is that you have to offer. If you want to see more details, you can go here. The general innovation of 2i2i is the multi-dimensional, infinitely inclusive market model that connects any supply with its demand in the provably fairest way possible. We have chosen as a first example of a supply social interaction. To understand this, let's do a little philosophy. Energy and information are two fundamental elements of nature. Each of us is a bundle of energy and information, and a social interaction is an exchange of information or energy. It's a trade. And social interactions cost energy. Here's a link to a video explaining this, and it features a fictional Silvio Micali, but it applies to anyone. And what it shows is that if you would decide to interact with everyone in the world that wants to interact with you, you would be completely depleted of all energy. To make social interaction fair, those that want to interact with you should replenish your energy. In fact, we know from microeconomics that a fair trade raises the value of both parties. That means if we have a network of fair trades, we get a fair economy of social interactions, exchanging information and energy in the fairest possible way. Plus, everyone in the world has some information to offer. And the value of that information is greater than zero. It might be minuscule or huge, but it is never going to be zero. And because, thanks to Algorand, we can transact arbitrarily small or large values. Imagine giving someone a trillionth of a dollar coin per second of interaction with that person. That means everyone has value and can harness that value, the fair value, using 2i2i. Another way to think of 2i2i is as a bridge between energy networks, that's blockchains, and information networks. One such information network that I would like to mention today is Twitter. In fact, 2i2i could instantly solve Twitter's revenue problem by allowing users to offer each other energy for having one-on-one conversations with each other. Even users with lots of followers will be happy to hang out with random other users if they receive enough energy. In fact, that would be a real way to brag. You can say you have so and so many followers. What percentage of those are real? But if you can say people have actually been committing this and this much energy in coins to talk with me, that's real value. And the business model for 2i2i, to help someone like Twitter or anybody, is trivial. It's simple. We have transactions, and so we can take a cut. But besides thinking about people with lots of followers, Think about people that are displaced or oppressed. Imagine you could have a few minutes of a small talk conversation with someone like that around the world, and you offer them some energy. They can take that energy, you say, hi, how are you doing? Where are you now? Okay, bye, a few minutes. And they get the energy and they can spend it to better their own life as ever they want to. Since this technology literally provides the potential of an income stream to everyone who has internet, this technology can help Algorand go truly mainstream. And so, AlgoFam, I would like to ask you to relay this message to the Twitter team. If we can have a Twitter person understand the efficiency of the blockchain that we have and this system that I described today, we could be having a great celebration soon. 2i2i is live on mainnet. It's easy to use. All you have to do is share your QR code, your 2i2i link with the world, and the world can share energy with you. So go and harness your energy, or just hang out with me. Okay, thank you.
Imi, thank you so much for showing us a little bit about what 2i2i is. And you have wrapped us up today on the Algorand greenhouse here. We thank you very much for joining us and showing us, as a developer, what you can do on the Algorand blockchain. If you have vision, as Imi does, I'm sure that we can help you also realize that vision by building on top of the Algorand blockchain. That's what I do as a developer relations specialist here with the Algorand, the Algorand Foundation. All right, as a wrap here, on this stage, it is not yet done here. I want to invite everybody to head over to the arena, the big main stage, where the closing keynotes for today are going on. Tomorrow, we will have the greenhouse open again from 10:30. I'll be back on stage. Actually, I'm gonna kick it off. I've got a session on setting up your developer environment. So for the devs out there who have never built on top of Algorand, I'll get you started. We'll get your development environment set up. The rest of the day, we are going to have my colleagues who are going to tell you about the languages and how to actually build decentralized applications. So we'll have a team talking about PyTeal, the advancements that they have recently added to that SDK, as well as the team from Reach to talk about the Reach Lang. We'll also talk about Beaker and the Beaker framework and how to build with all of these different languages. And ultimately, we're going to see a couple of different presenters building the same application, the same decentralized application using multiple different languages. So we invite you back here tomorrow from 10:30 a.m. here in the developer greenhouse. And with that, thank you very much, and we welcome you on the main stage now for the closings. Until tomorrow, have fun building an Algorand.
Hi, welcome everybody. Thanks for coming to our Decipher Careers Bootcamp, and we're kicking it off the first time this year. We are in touch with the student community here in the UAE. We're very excited for everyone to be here, and we have some special guests here to get us kicked off. Before we get started, my colleague Eva and I want to tell you a little bit about what Algorand Foundation does for universities and for students all over the world. So one big program that most of you will be familiar with is our Algorand Centers of Excellence program, the ACE program as we call it, where we have almost 50 organizations across the globe, from Fiji to England, from Australia to the United States, across the globe that we work with to advance blockchain research, blockchain education, community building, and really making sure students, can get familiar and learn in the blockchain space at their home universities. You can see here a lot of the universities that we work with and organizations, and a big focus for next year is our Algorand Blockchain Clubs program, or as we call it, our ABC program. And Eva, our student engagement lead, will tell you more about that.
Hello, everybody. Welcome. First of all, thank you very much for being here. My name is Eva. I am a student engagement lead of the Algorand Foundation. My role here is to lead all the activities for students globally. And have you seen how many universities are we working on? We have partnerships, we have universities, student clubs. We work in Latin America, in Europe, Asia. Now we are working with Middle East, with Ryan, our community manager, and also with Crypto Oasis. And of course, we have many opportunities for you to onboard the Algorand ecosystem, and also to join the Algorand as entrepreneurs, as professionals, as builders, investors, and many things that we are going to learn with Doro, and of course, with our colleagues. Thank you.
And we want to talk a little bit about what we're doing for students today and tomorrow. So today we have our interview boot camp with our CEO Stacy and the COO Deirdre, where they will share a little bit about their experience as an interviewer, but also from their past as an interviewee, and give tips on hand for the job seekers. And then tomorrow, for a selected group of students, they'll have the chance to meet with Silvio and ask him for advice, ask him their burning questions. At lunchtime, we'll have a lunch and learn where our principal scientist, Hugo Krafczyk, will speak, and our student club leaders, and then our head of gaming, who used to be one of the founders of the Blockchain Acceleration Foundations. And we'll talk about all the exciting things that are happening at the intersection of blockchain and academia. And last but not least, we're doing a speed interviewing session with 10 selected ecosystem partners, where we will enable students to get the internship of their dreams in the Algorand ecosystem for next year. And this is exclusive for Dubai-based students, so very excited to work with the student community here. With no further ado, I want to introduce Jack Chan, who's going to lead the exciting conversation for the rest of the session. Thank you.
Well, how was day one so far with Decipher? Love the energy. Such a unique opportunity to have the Algorand Foundation CEO and COO here with us today. I feel super privileged to be, helping you guys out and talking about the bootcamp with them, talking about their interview experiences. I think between them, there's probably over 1,000, maybe a few thousand interviews that they've gone through, and we'd like to take this.
Are you calling us old, or?
There's a lot of speed interviews, but I think this is great. Thank you for taking the time for helping us out here. So without further ado, I'll just quickly kick it off with some of the learning experiences around interviewing as we go through our careers. One of the takeaways that I could maybe share with from my own personal interviewing experiences more recently, I think I just joined the Algorand Foundation for about a month now, is that when you interview for an opportunity, you got to be really, really sure that that's a place that you want to go to. And then interview is actually a two-way interaction. once you put your mindset as, hey, I really, really want this opportunity, but I want to make sure that I am a fit for this role so that the organization, is actually a fit for me as well. So if you think of it as a two-way conversation, then it sort of calms yourself down to be very comfortable in your skin, to say, hey, you know what? I'm just going to go for this, and your confidence level will actually go up. Just putting yourself in that mindset. So, again, without further ado, I'd like to introduce Stacy to share her experiences.
I was having a chat with John Woods the other day about an interview candidate, and he told me that you are a very tough interviewer, actually. He's been in a couple of interviews with you on the interviewing side. Is that true? You're a tough interviewer, would you say?
Am I a tough interviewer? I'm a structured interviewer.
That means?
That means I look for a certain amount of response types coming in from candidates. So I'm looking to see whether they're able to describe the situation of a question that I had, whether they're able to break that down to things that the candidates did as a team and as individuals, and then the results that come out of that. So yeah, I'm pretty structured that way.
Are you asking me about when I have interviewed or when I interview?
Both, actually. So I think both will help.
Okay, so when I have interviewed, I think when I was younger, a couple of times I applied for jobs that I really was not qualified for. I had no really business or no experience to bring to bear, no direct experience. And as a result, I decided that I needed to know everything that I could about the organization and talk about what I was going to do, because I did not have available to me the idea of talking about what I had done, because I hadn't done anything that was relevant in my view. And I can think of 2 occasions, and I got both of those jobs, and it made me think that it's a better strategy probably not to talk about yourself, but to try to talk about the situation at hand and the problem at hand and what you think you can bring to the situation, rather than just a list of everything that you've done. And the corollary of that is that you need to really understand the company or the organization that you're trying to work for. So for example, when I'm interviewing for, say, community managers at Algorand, and I have interviewed, they interview with a few people before they get to me, actually. And I have probably interviewed 10, and I've probably vetoed 5 and gave the green light on 5. And one of my questions is, I meet you at a meetup, and I kind of know something about crypto, and maybe I hold some ETH, and I'm okay, but not super knowledgeable. Tell me about Algorand. And you have got to be able to tell me about Algorand in that context, because I've given it to you at a very high level. I've just met you at a meetup, at a cocktail party, and if you can't describe to me, how Algorand works and how the protocol works in a way that's at least factual, if not a little bit salesy, then it's almost like you don't care enough. And so if you don't care enough, I don't want you to work here more than I care so much whether you do a super good job describing it or not. So there's 2 things, I guess, that I look for there. But I also think that you have to have confidence to riff a little bit. So I had a young woman that I know her parents, so I know her, and I thought maybe she would be a good candidate for Simon. And she knows about econometrics, but he wanted somebody that had a lot of SQL experience. And so she made a comment to me. I was obvious in the first 2 minutes that I was completely unqualified for this interview. And I thought to myself, you can't even survive 2 minutes? Anybody should be able to survive 2 minutes of an interview. I mean, maybe by the end of the interview, Simon decides you don't know what you're talking about. But you've got to be able to get through the first 10 minutes by just being smart and leveraging whatever it is that you do know to the situation at hand. So maybe I'll stop there, but those are some of my initial observations.
Before I ask or kind of answer the question, let me ask the audience a question. So how many here are students or heading into your first? And how many are kind of midway between their career? Most? Okay. So for me, from my experience in interviewing, and then I'll talk a little bit about kind of interviewing. For me, it's always been about, as everyone will say here, being prepared. So knowing about the company, why you want, so you have to do your homework. But it's actually about how you interact in the interview. And that's generally what's kind of gotten me the roles that I have. On the flip side of that, I have, and I own my age, interviewed hundreds and thousands, and I've interviewed right across, including developers, because I've had developers report, directly into me. So when I'm in that situation, I've created the interview sheets and the actual, recruitment process, because as an ops, I've had, HR and recruitment come into me. So I need to kind of understand from the organization the type of pool, the type of people we're looking for, the competencies, the skills, but also in a face-to-face, how to understand, what skills that person has, and they may not have had a job before, to the point, like they're coming fresh out of college. They may, have, done some different projects, but I think the one core thing is demonstrating what you've done with the knowledge that you have and your capabilities. And to me, that's always been the core thing, in interviews, is like when somebody comes in, it doesn't necessarily matter that they haven't done the job before. It's, do I have a sense that they have the skills, the competencies, the qualification, the curiosity, and can they demonstrate that? But also, I have a kind of an interesting kind of aspect as well. I like to see, okay, would this person fit in the culture? Could they go have a cup of coffee with everyone in the room? So it's important. So I tend to kind of have a structured format, but also there's a human element of it as well that, I think you need to bring your authentic self to the interview as well, is what I've found.
Right, that makes sense.
There's a couple of people that I've interviewed and hired in this room, actually, and so maybe I'll just call a couple of them out. John Woods, for CTO, he knew everything about Algorand when we had our first conversation. I mean, he was like, this is what I know, this is what I think, this is so cool, this bit, and did you know, and da-da-da-da-da, and, but what I think is not so great, and then, I mean, I barely had asked him a question, and he was so already steeped in, and it was a version, again, of what he was, what he was planning to do. You should also know, that if you don't answer the question I ask you, I am going to notice that. So it's much better to just kind of own up to what you do and you don't know. Hey, I'm not sure about that, but let me tell you one other thing that I do think or I do know about, as opposed to trying to avoid it. I will also notice if you do excessive flattery. No, so tell me about your career. It's so interesting, and you can do a little bit of that because you want to demonstrate that, maybe you've seen the talk that somebody gives you, but you don't kind of want to over-index on that at all. But I will give you my, maybe of all the people I've hired, my force-ranked best interview was with our head of business analytics, Simon. Put your hand up over there. He came and I was needed very much a head of business analytics, and he was the maybe 10th person that I had interviewed. And we gave a Zoom community meeting. We had a Zoom community meeting the day before. And Simon showed up for the interview. It's for business analytics, and this is about like creating dashboards that we can use to understand what's going on in our organization. And he showed up in the interview, and he's like, so I noticed you're talking about a bit of data in your meeting yesterday, so I sort of stayed up last night, and I put together a business analytics dashboard for you that you might want to use. And here you talked about this, and here how you can see it. And I was like, oh my God, hired. I mean, like, what else do you need to, like, there's nothing, I mean, he didn't have to, I mean, as long as he could speak English at that point, I was just so impressed by that. I don't know, so maybe Simon, I should ask you, how do you think about the approach to this?
I think we need a mic for him. So.
Thank you. My approach was, I said, how can I bring value to Algorand Foundation? Why would they need me and what would I bring? And as Stacy said, there was a talk before and she was saying, you know, we need to do this, I need this information. And I said, that would be a nice thing to show. Because in an interview, you can speak as much as you like. But if you can show something, this is what I can do. And if you're a creative, if you're a developer, you can show a piece of code, an app. If you're a designer, you can show something. I said, okay, let me build this dashboard. Yes, as she said, it took me all night, but I was happy to do it. And in the interview, I just showed that dashboard and we discussed it. And I think that was, okay, he can do this, so he can bring value to us. And that's what's the most important thing. And as Deidre said, you need to see that there's the culture fit as well. So if you fit in Algorand, you should build on Algorand and work at Algorand as well. Thank you.
Thanks, Simon. For those that just joined us, we have on stage the CEO of Algorand Foundation, Stacy Warden, and COO of the foundation, Deirdre Halligan, and myself, Jack Chan. So to summarize, I think that was really cool, is that I think communication is key, and being articulate is actually even the finest point that you can get to. And then there's that experience that we were talking about, like if you don't care enough for the position, that means that's a little bit more on the preparation side and also on the fit. So if you actually in a subconscious already know that you are not a good fit for this, you just care less for it, and then you go in to an interview thinking you're just going to practice that interview and not wanting that job. I think that's not really a good mindset to go into. But on the flip side, I think I'm just going to add to that, ad-lib a little bit, is sometimes you do want, like if you haven't had an interview for like last 10 years, you do want to have a few throwaway interviews and just go in there, like you kind of want a job, maybe you don't, and then just go through those interviews just to brush up a little bit. But if you've gone through too much of those, it might hurt you in the long run, right? So you're getting like 8 no's after 8 interviews. That's 100% no's. That's pretty detrimental. So make sure there's that fine balance in that strategy. I'm going to add one more thing, is like adding value to the organization. I think that is a very, very powerful statement. If you know that you can already add value from your previous experiences or your skill sets, you're just going to go boom, 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 boom. I can do this, X, Y, and Z, and your confidence is just going to go 110%. So I think those are really great examples. Thank you for that.
Maybe some negative rules. I mean, you probably have some rules, like some please don't do these. I'll start, but I bet you have a few. And Jax, you're a great example of this, actually. Don't trash your current employer. Even if it's maybe not always going well for you, even if you have issues with it, you have to be diplomatic about that. And I may already have an understanding, especially if you come through a headhunter, of maybe how it's going on, and I'm going to maybe look for that, and I'm not expecting you to say anything bad about where you work now, no matter how tempting it might be, as one example.
So yeah, I think to add to that, the obvious one is, don't talk too much. And what I mean by that is just keep talking, keep talking, keep talking, keep talking. Listen. You'll see you'll see potentially a glaze. So when you see, pause, give the interviewer an opportunity to ask another question. And some of the basics, like I've some, anecdotal stories, dress appropriately, don't wear t-shirts. I had a wonderful interview, I'll always remember. The guy had wasted on his t-shirt right across here. So rightly or wrongly, that creates an impression. Could be the smartest person in the world, but, this is an important kind of meeting. And then as well, I think, don't forget to ask about what a day in the life of the job will be. So a lot of people, and particularly in our world now, we've got very generic headings for roles, and particularly in the developer or the technology work. So ask, what's a day in the life of, what is this actual role going to do, you know, in any given day? Because that will tell you so much more than a piece of paper or a job description on the website. So don't be afraid to ask, what is this role expected to do?
I'll tell you my funniest recent interview story. So I was interviewing somebody at the Algorand Foundation, and I have like a patio. I have sort of my dining room has glass doors, and then there's a patio. And I was on a Zoom outside, so with my back to the dining room, this sort of dining area, and my laptop, so the interviewer could see into my house as I was talking. And so I asked a question, and he started answering the question, and then he paused, and he was kind of like mid-sentence, so and he paused, and he said, your dog is eating off of the table.
Setting, guys.
Funny. So funny. I was like, oh, thank you very much. Hang on for 1 minute. And I was like, Wilhelmina, get off the table. I'm sorry. Thank you very much for that.
Preparation right there, ladies and gentlemen. So I guess we heard a little bit like the top things to do and the top things to sort of avoid doing. And by the way, we're going to hold a mock interview with Stacy. So if there's any one of you interested to come on stage and practice interviewing skills and whatnot, there's an opportunity to do that in a few moments. Oh, Deirdre. We got one here. All right. Come on up. Yeah. Right. Let's set this up. All right. What's the job? I'm just going to make it up. I don't know you. You look like a fine gentleman. I'll just say maybe Web3 related product manager. Yeah. A product manager role.
Okay, product manager. Business-oriented product manager. Okay. You want to start, Stacy, or are you going? Okay.
Oh, could we loan a mic to him? Yeah.
Oh.
Yeah, we probably need a microphone.
Did you have one? Oh, you were lit up. Okay.
Thanks.
Okay. It's hard to do a mock interview. So let's just say you can kind of make up answers because obviously nobody knows anything, right? And this is how I start every interview. Come to think of it, I didn't mention this. I will say what's going to happen in the interview. So I'll say, first I'm going to ask you some questions about yourself and what brought you here and why you might be interested. And then I'll try to persuade myself that you understand what the job is and that you've prepared for it, and you will convince me that you have a good skill set and experience. And so that's how, and then you'll have a chance to ask me questions.
Perfect, thank you.
All right, great. So why don't you tell me why you're interested in being a product manager at Algorand?
Yeah, thank you very much for having me here. I worked for several projects in my career, from beginning in the ecosystem as writing articles, and again going deeply in the ecosystem, touching everything from DeFi, from NFTs ecosystem and others. And what I wanted to do is to make real-world use cases. And what in this position that you're offering me, that you're proposing and you're putting on this table, I think that we can do great things together, like when creating a new governance platform, for example. That's something where I can bring value, because I worked, for example, for decentralized organization before, working remotely, and also working as a new system of governance. So I think maybe you can tell me more about the job description, but I have related experience on this kind of subject. I've worked previously in my team. I hired 3 developers, and we made like sprints and to work on to develop the project. So now I can present you the mineable viable project that we created with my team, and to see how it is to develop a product.
Very good.
Before I give it to you, you some feedback on that, and I think you brought some experience to back, but you never literally answered the question. You know, I said to you, why are you interested in being a product manager? And so it's okay to elaborate on your experience and find a way to bring your experience, but you also have to, in that answer, tell me, say the words, I am interested in being a product manager here because, you know, so that I know your.
Yes, okay, but I don't know really the expectation of the job of product manager. So I do not know what we expected or what it really can be. So I'm sorry, I didn't really understand the question, but if you tell me more, I think I can expand.
So again, hypothetically, talk me through or tell me one of the projects, out of all the projects you've done, that you're most proud of and why?
Really, so I first been discovering blockchain and I was alone. So what I wanted is to create a community. So I launched my own blockchain association in my school, and that now we are 25 people in France in my business school, and we have been launching some great project. And from scratch, we organized in 6 months one hackathon with top industry leaders like Ledger, and make amazing products created. And now there is one project, one DeFi project that is incubated thanks to this hackathon. So thanks to this blockchain organization, we have seen like some change in the ecosystem. So that's something that I'm really proud of. Created with 10 volunteers of the association, a huge, big hackathon, for the biggest hackathon done by blockchain students in France.
Thank you. I'll do my. Thank you very much for that one. So then let me ask you then a follow-up to kind of that is, you know, what was your personal involvement in that? So did you manage it? Did you design it? Did you?
I first put the idea in place. I recruited the group of people. I managed it. I found the sponsors. And then the thing that was most difficult and we didn't expect to is to make marketing and communication to find a good amount of people, real high talented people to come at the event. And that was, I think, the most difficult stuff.
Great, thanks.
Any feedback on that, Dieter?
I was just going to say that I thought both of those were nice. It was very clear that where you had had experience and how you and then I thought your second answer, which was very short about what you did, was also nice. What did you?
Yeah, I think you're, you know, concise and clear in terms of what you've brought to it is always looked favorably upon, because you can then, as an interviewer, I understand, okay, this is what you did in the broader project. So when you're involved in big things, where you can kind of say elements that you've delivered without looking like you've taken all the credit for everyone else's work, of course, but to the certain points that you've brought, it's really clear to the interviewer, you know, what your contribution was. So really good.
Okay, I'll give you the feedback up front before this question. So I'm going to ask you for, it's going to invite a kind of a list-like answer. And so I'm looking for a list-like answer, not a meandering answer. I'm not saying that you would do that, but just to say. So tell me the qualities in all of your project management experience. Tell me what makes for a good project, a well-managed project, and a not so well-managed project. What are the kind of, you know, the great things which are indicators of a project that's gone really well, and you know, of some of the killer things that when a project's going off the rails?
Yes, I'll begin with the project that I didn't manage well. First, it was a hackathon. It was at HCC hackathon this summer, and we are launching a startup to help DAOs to merge together. And the first thing we found a path, a way to do it. So we found an idea, and we try to deliver it right now without consulting external advisors. So we had a good result at the hackathons, but after the solution was not good because as a manager, I didn't took the time to see if the solution was real, and take the time to see if it was usable. The UX was not good, even if the solution was theoretically good. So I think that was one error from my side to make it, because it was not something that people would use or to pay to consume. But after that, after making a lot of call with VCs and after, we heard this feeling and we discussed with many, and we been back for research to see how to improve the solution. So we found the problem, and by managing, having deep discussion, not only with the developers in the team, but also seeking for external advisors that can be considered as freelancers, and going out of, thinking out of the box, I could answer this problem. And I think this is thanks to that, by making a pivot, like changing our point of view in the team, that now we are 4 months later with a mineable value product that is really usable and that is ready to search for fundings.
What do you think, Deirdre? Does he have the job?
Of course.
Thank you so much.
Thank you very much.
Thank you for being such a good sport.
Thanks for being a good sport. Thanks, Jack.
Fantastic. So before we part ways, maybe we'll just summarize a little bit. And one of the things I sort of noticed is, I forgot to get the gentleman's name. Juice. He was able to articulate in a way where he described the situation, talked about the task. This is called the STAR method, STAR. So describe the situation, the task involved, the action that Juice did, and then the results, right? So congratulations on that. Thank you.
I never heard of that. That's awesome. What is it, STAR?
The STAR method. So the backstory behind that is I worked at Amazon for like a year as a software development manager, and that place is like a boot camp. They train the managers to like do a certain amount of things, and interviewing skills is one of them. And although I've interviewed a lot before, Facebook had different ways of interviewing, Google have different ways, Amazon have the STAR method that they go with, and it's been very effective, I think, making it very structured, like I said earlier. So, any parting words, Stacy?
I don't know that if I have parting words, but just just prepare. You know, act like you want it. And if you're doing the interview, remember you're also selling. You're trying to put the best light forward of your own company. So yeah, and just relax and have a good time.
I think my parting comment is, you know, when you go to an interview, irrespective of what stage you're at in that interview process or what stage you're at in your career, bring your authentic self. Because if you bring somebody different to that interview and you get the job on that basis, you're then in the organization, you know, and you ultimately want to be in a place where you have your authentic self. And if you don't get the job, there's a very famous Irish saying, which is, if it's for you, it'll come to you. So, you know, if you don't get it, okay, while you might have been, you know, really rooting for it, something else will generally come along the way. So, best
Great.
of luck.
Thank you. Thanks so much, Stacey and Deirdre. Have a nice evening, guys. We'll see you back tomorrow. Thank you.